Hello everybody, Chris here, and in this video I wanted to cover the basics of GameObjects, MonoBehaviours, and components inside of Unity. So inside of Unity, when you're creating a scene, everything that will exist inside of the hierarchy, whether you create it while you're editing the scene, or whether you spawn those objects with a script when the game is actually running, every thing or object is going to be put under the scene in terms of a hierarchy. And since we're building games, we refer to all of those objects inside of the scene as game objects. Now, game objects can be things that will interact with other objects in the world, such as enemies, players, or tiled walls. But a game object can also be something that is specific to the graphical user interface or the UI of your game. But a game object can also be something that does not interact with your game world, but rather exists on an overlay called the graphical user interface or the UI. But regardless of if it's directly part of your game or just for showing information to your player, all of those elements will be considered game objects within the game. Now, what does a game object have attached to it? To demonstrate briefly, I'm going to right-click on the hierarchy and go down to UI, and we'll create some kind of UI component so that we can compare a regular game object to a UI game object. Essentially, they are the same, except that UI game objects are attached with this component called a rect transform, instead of any other game object not attached to the UI or the canvas here, which would just contain a regular transform. Aside from that, any game object is able to have different components, like this camera component you see here, an audio listener, or in this drop-down UI component, an image, a drop-down script. All of these extra elements are called components inside of Unity. So essentially what that makes a game object inside of Unity is a container for components that will interact on the game object. But the game object itself is required to have a transform at the very minimum. And you can see up here at the top that there is always some information that's associated with game objects, such as a tag, the layer which the game object is on, and a checkbox up here in the top left of the inspector for whether or not the game object is enabled or disabled within the scene. So how things work in Unity is that you start by creating a simple game object shell. And then when you want to add behavior or information to that game object that can be referenced in other scripts, then you add components to the game object. And the easiest way to do that in the inspector over here, you select the game object in the hierarchy, go over to the inspector, and then you hit add component. And you can choose from any MonoBehaviour script or any of the default components that exist inside of Unity, such as a box collider for determining collisions. Now, I mentioned a MonoBehaviour script. So the default way of doing things in Unity, if you're trying to write scripts, is to do things in C#, and then in your script, you inherit from a class called MonoBehaviour. So what you need to know about a MonoBehaviour for right now is that it affords certain functionality, like being able to reference the transform component and its position, rotation, and scale, making it have some useful information to use in the script. But the critical aspect of it being a MonoBehaviour script is that you can attach it as a component to a game object. And by doing that, you can have the game object use that script and to be able to call the methods that you write within that script class. So for instance, you can see here in the scripts folder of this project, I have a script here called game menu. And this game menu is a class, meaning you can create an object from it. And this class of game menu inherits from MonoBehaviour. That means this game menu script can be attached as a component to any game object. And by attaching one of these scripts, we can easily have that game object run the functionality. So you might be creating scripts from MonoBehaviour to do things like manage the health of an enemy, to manage the inventory of a player, or to handle 2D movement and collisions. It's possible to cram pretty much everything you want an object to do into one script if you want. You can also decide to decouple functionality. So you might separate all of the things you want a player object to do into separate scripts. So you might have one script for inventory, one script for movement, and so on and so forth. So if I wanted to quickly create a new script, I can right click over here and go down to C# script. So right click, create C# script. I'll leave it at the default name, new behavior script, and you can see that when you create a new C# script in this way, it's already inherited MonoBehaviour. It doesn't really do anything, but it does write these empty methods for you. So start and update, they occur in the life cycle of Unity, so you can have certain things happen at certain times during your game's operation. Okay, so now if we want to attach this new script to a game object, we can drag the script in, and as long as it's a MonoBehaviour, should be able to pop it right in. You can remove scripts by clicking on the gear over here and then remove component. And we can also search for the component, even ones that we created ourselves, by typing in the name of the script and adding it in there. So one more thing I wanted to point out about UI game objects is that they must exist under a canvas game object. So you can see this canvas was automatically created when we added in a drop-down UI to our game. And this canvas game object contains a canvas component, a canvas scaler component, and a graphic raycaster. All these components are added by default, and we can usually leave them as the default settings. But what this allows to happen is our rect transform UI game objects to render on the canvas. So when we have UI components added to the canvas, the main difference is that these UI components are never going to move with respect to the camera. So if I put this drop-down menu in the bottom right-hand corner over here, inside the canvas, then when we go to game, it's going to draw on the screen. And we do have a camera in the scene. It's not following anything at the moment. We would have to write a follower script for that. But if the camera ever moves inside the scene, these UI components will not move. They don't have any perspective or viewing angle with respect to the camera and the scene. They are simply a layer that goes on top of things. So you would use the canvas often for drawing things like how much money a player has, how much health is left, possibly what weapons or items they have equipped. So for any non-canvas UI game object, if I add it to the scene, and let's adjust the position a little bit and maybe change the sprite so we can actually see it in there. So for all of these other game objects that exist outside of the canvas, whether or not they draw on screen depends completely on whether the camera is looking at them or not. So if I go to this game tab over here, but I adjust the position of the camera, you can see, oh, the UI doesn't move, but the object appears to move because the camera is moving. The camera is not looking at this object anymore. And of course, you can move the sprites as well, changing their position within the game world, including Z-axis if you ever are working in a 3D game and not a 2D game. Aside from that, there's a few minor differences between any game object that might appear on the canvas rather than the game itself. Another thing that you might notice here is that when an item has a rect transform, it works at a different scale than objects in the game world itself. So you can see here these game objects are working in terms of game units, and a game unit is basically determined by what size you have the sprite drawing at. So if we take a look at some sprite sheets that I've imported, if I set the pixels per unit on that sprite sheet to 512, then that means 512 pixels of this sprite is the equivalent to 1 unit in the game world. But then items inside of the UI are based on pixel values, and those pixel values, well, the size is going to be relative to the screen size. So if you have a scene that's 640 pixels by 360 pixels, like I currently have it set up over here, and you can define your own custom sizes by clicking on this drop down and going to the plus, then that means if I take one of these canvas elements and I set the value to be equal to the screen size, then it will draw itself all the way across the screen. That also means if I set something like the position X to 50, we're talking about 50 pixels away from the anchor point. You can see here anchor points. I currently have it set to the center, so it's 50 pixels off center. So here would be the center roughly, and then this is the center area for the game objects. So it's drawing about right here, which is what we would expect. So beyond that, there is a couple minor differences between game objects outside of the canvas and those inside. For one thing, if you want to render an image in the canvas, you use an image script which is specifically for drawing on the canvas UI. UI components are also going to have these canvas renderer components attached to them so that they can render on the canvas. And when you want to render an image as a 2D sprite image on a game object that's in the game world, you use a sprite renderer instead. So you don't use image on actual game players or game enemies. You use image when you're talking about the canvas UI. But aside from that, all game objects in your scene follow the same basic structure. It's all about adding components to give them extra functionality and accessing the values in those components, like the transform, in order to achieve what you want inside of the game world. If that's moving something's position, changing its scale, making it visible or invisible, or changing a value on one of the components, like a health total. Hello everybody, Chris here, and in this video for Unity I wanted to explain to you guys all of the UI components, how they interact together, and what each of them are used for. So when I'm talking about UI components inside of Unity, I'm of course referring to, if you were to right click and go down here to UI, all of the different game objects you can create that are for building your in-game UI that's separate from the actual actors, the player, the enemies, all of that, but rather the stuff that displays on screen like a GUI interface. Another way you can create these UI components in any other game object is to go up to the game object menu, and then you would choose UI and you'd have pretty much the same options available here. So for this video at least, we're going to be sticking to the default UI components for Unity and not covering any thing from an add-on like Text Mesh Pro. But yeah, let's go ahead and get into it anyway. So the first item I have in this game hierarchy created already is the canvas. The canvas is the base UI component because everything else that's a UI component, like a button or an image, at least an image that's for your UI, needs to be added on top of the canvas. The canvas is going to be where your UI renders. So the important thing to know about the canvas UI component is that it's where all of the other UI components go on top of. Now, the canvas itself doesn't really do much. It has a couple things on it, such as the graphic raycaster, which allows things like mouse clicks to interact with UI components. But every other UI component needs to be added onto this as a base. So next up is panels, and panels are basically boxes that you can add extra stuff under. You can add any game object as a child to another game object. You can see here that buttons have text components by default as a child. But the panel basically provides you with an image that by default is this kind of boring gray. But you can change that to any other kind of pattern or image that you want as the panel background. And then what you generally do is you add extra components like a text box for a title onto that panel, and your panel would then become a menu object. So one thing I like to do is if I have buttons or key bindings that would open up a game menu, I would actually specifically be targeting the panel itself. Because if you set a panel, or basically a parent game object, to active or not active, you can show or hide everything beneath it all at once. So panels tend to be a good object to rename to a menu, and then just stick everything else that is contained in that menu beneath it. Okay, so next up is the text box. So this is for displaying text, not for entering text like an import field. With a text box, you can add in whatever text you want it to display, including hitting enter when you want a new line. Now you'll notice that by default, you may have text that does not properly display on that text box, and that may be due to your vertical overflow setting. Where it's truncate, it's going to just not show the text that can't fit in the box, but if you do overflow, then it will just go over the line and show anyway. You can also change the font size if you want to resize everything, align it to the center, both horizontally and vertically, and of course changing the color of the text located inside of it. So generally you'll use text elements for things like titles or labels for other items such as an input box. But just know that it's only for display. You can change what it says in script, but you will never get user input directly on a text UI component. So next up is an image component. Whenever you need to display an image on your UI, something like a logo or any graphics that you need to pop up there, you can just pop in a image UI component, which will have an image script. You might notice that the panel also has an image script, but its defaults are different. This is more for backgrounds. And the image is set up with the expectation that it's more like just a general graphic you put on and not a box to contain everything. So when you have the image script attached to a game object, it's going to be sprites located inside of the script. So my understanding of the difference between an image and a raw image here is that images will take the image and display it as a sprite, which gives it some extra functionality, being generally better for things like animating it and being easy to work with. But then a raw image is a little bit faster because it doesn't have the extra overhead of all that sprite functionality. So raw images can be used for stuff like basic textures when you don't need to animate it or anything of that nature. But honestly, you could probably just get away with making everything an image. Unless performance really matters to you though, you can probably get away with just using image components in all cases really. I haven't run into any situation yet where using images, which might display it as a sprite, has actually slowed everything down enough to be noticeable. Okay, so next up is button, and you'll be using buttons a lot because buttons allow you to attach a on-script event delegate down here. So basically you can drag any object that has a script into here, and then you can run one of the functions on that object. And then you can run one of the functions from that game object or the script attached to it. And basically what that'll mean is when the button is clicked, it's going to run all of these functions that are listed below. And you can, of course, have multiple functions. So buttons are really useful. When you want to do something like enter a new menu, you can use a button to do that. And then you just enable the menu by GameObject set active. But really, as long as you can reference a game object that has a script attached to it, you can basically make the on-click events do whatever you want. You could also have buttons on screen for mobile games for things like attacking enemies or making an in-game purchase, whether that's for the cash shop or part of the game itself. So buttons are super useful. And as for the text that's displaying there, buttons always come default with a text component as a child. It's not mandatory, you can just delete it like that if you want. But the text basically to title the button and let players know what that's going to be about. Just as easily though, you could replace it with an image on top of it as well. Basically whatever floats your boat. Okay, so next is the toggle component. This is where you have basically a true, false, yes, no question or option, and you want them to be able to toggle or switch between those two options, basically on or off. So if you have a Boolean value or you want to control a Boolean value in script, this is really useful. So it might be like enable music, and then you would use a toggle. Because you just want it to be an on or off situation. Now you can see here as child elements, they've got an image component down here and another image for the check mark. And also the label, which is just a text component to label the button. So it's basically 4 components built into one, but using the toggle can make it a little bit more straightforward. And whenever you want the toggle to change something, whenever you hit the checkbox, on value changed works very similar to on click, just instead of when the button is clicked, it's whenever this checkbox is marked. So next we have drop downs, which are for drop down menus. So the idea of the drop down menus is that it will allow the user, or the player in this case, to choose from a few different options. So when you drop this down, it's going to expand this template area, fill it in with a white background by default, and you'll be able to make a selection there. You'll also notice that there's a onValueChanged event here. So when the user selects a different option, you can have it invoke some methods down here on different game objects. So this can be really useful when you want to give the user a series of options and basically let them choose one out of many. Input field is kind of similar to text in that the import field box is going to allow the player to basically enter in some text here, whatever the purpose for that is. A really common example would be if you need to get the player name or a save file name, have them enter that in here, and then maybe you'd have a button on the side so that you could submit that, and then it would take the value inside of the import field. Of course, you have to reference these in script. But it would take the value and you could save it, or you could start a new game with that value. You'll notice that there's some placeholder text in there, but as soon as the player starts typing in the box, that text goes away, and then the real text would start being entered. So another cool component that's a little bit more complicated is the scroll view. You can notice in the scroll view I have 2 pieces of content here, which is actually the same 2 images from over here, but you'll notice that the scroll view, I've set its width and height to not be big enough to actually fit all of those, but yet it has both of those inside of there. And you'll notice that this vertical scroll bar updates to reflect that you can scroll up or down, of course, when you hit play and actually try the game out. There's also the option of having a horizontal scroll bar. You can enable or disable these with these checkboxes over here. So the general idea of the scroll view is if you want to add content, you would go to scroll view, viewport, content. And I think it's better practice to actually put it as a child object of the content, and then these images become a child of that. So now if we hit play, which we'll do in a second here, we'll be able to scroll up or down and view the different objects that are contained in there. No matter how much stuff we put in there, we'll be able to scroll through all of it as long as the corresponding scroll bar is enabled and still there as these child game objects. You can see scroll bar horizontal and scroll bar vertical. You can of course change everything, so if you don't like the white scroller or the background for that, that's all changeable. You just change the image or the color for it. So let's go ahead and hit play and just kind of try out some of these components over here. Okay, so just to demonstrate, you can see the text element is not interactable with by default. You can click on it all day, but it doesn't do anything. Same with images, but images are actually attached as part of the component for a button. So buttons actually have a little UI image here, and you can of course change the button to be something like the Unity logo if you choose. But you can click on the button all day. It won't do anything until you actually add an on-click event here, but you can see that you can interact with it. So the toggle, you can interact with that of course. It's on off, so it's either true or false, and you can take that Boolean value and use it in your script. The drop-down menus, you can see it gives you a little checkbox for the selected option. And we can go down to different options here. The input box, you click on it or press on it depending on what device you're on, and you can import the text. If you're on Android or iOS, of course, it would present you with the keyboard. So let's just type something in. And of course, you probably want to use this in combination with a button or something so that you can submit. Really, all of these would work really well with a button so that you get these import fields filled out by the player, and then you hit the button, which might say run a save script, and then all of this information gets saved somewhere in your game so that you can use it. And you can see with the scroll bar over here, we can scroll to see the 2 images. If we had images that were going wide horizontally rather than tall vertically, you would also see a horizontal scroll bar here, which would allow you to scroll left and right as well. So that's all there is to the default UI components. As you can see, they're individually pretty simple for the most part, but where it becomes powerful is when you start combining them and you build out your own menus using combinations like input text, drop downs, and toggles, and then you complete it with a button. But maybe you also throw some images on the side to give your menu a little bit of a nicer look. So that's going to be it for all of the default components inside of Unity. I've been Chris, thanks for watching, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this tutorial we're going to be covering MonoBehaviour scripts. I'll be introducing you to a few simple concepts of MonoBehaviours, and we'll be creating a simple script that we can test out by attaching it to this robot game object I have gone ahead and created. You can see that this robot has a transform, which all game objects do of course, and a sprite renderer, but nothing else besides that. So if I was to go ahead and hit play, absolutely nothing would happen. Even if I was to remove the tiles that exist under it, it wouldn't be affected by gravity. So our game object is about as simple as we can make it while still displaying it right now. So if we want to make it so that our robot character can do something inside of the game while the game runs, we're going to need a MonoBehaviour script for that. So to add a new MonoBehaviour script to our project, we can hit add component and type in the name that we want to give our MonoBehaviour script. So I could call it change color, And by doing this, it will create a new C# script called change color. By default, this will go in the root folder of our project. I recommend trying to organize things a little bit and putting it in some kind of scripts folder like so. Just because as your game grows, there's going to be a lot of assets, so you kind of want to try to manage things a little better, and I definitely need to clean this up, so let's just delete that for now. Okay, in any case, the script exists inside of our project now, and it is attached to the robot, but it doesn't currently do anything. So in order to edit it, we need to go over here to the right and hit edit script. So edit script is going to open that file up in our code editor of choice, and we can check what code editor we're using with Unity by going up to Edit, Preferences, and then External Tools. You can see here I'm using Visual Studio 2017. Visual Studio Code is also an option. And I believe Unity also has MonoDevelop. I don't know if that's still standard or not. And Unity used to at least have MonoDevelop. I don't know if that's still around, but you can use whichever editor you want. I prefer to go with Visual Studio 2017. So I'm going to go over to the change color component inside of our robot inspector, and I'm going to edit the script. So now that I have Visual Studio opened, we can see what's inside the script file currently. So you can see here it's by default declared as a public class change color, which is the name of our script. And this class extends the MonoBehaviour class. So you can see if we hover over MonoBehaviour, it says it's the base class from which every Unity script derives. And what that means is that basically if you want anything to occur inside of your game, it's going to need to come, at least at some level, from a MonoBehaviour script. You can create classes that don't inherit from MonoBehaviour, but you're going to need a MonoBehaviour in order to execute anything. And the reason for this is that there are certain lifecycle events that exist within Unity that you need scripts, MonoBehaviour scripts, in order to hook into. So what will occur inside of Unity is that the game engine will be running through certain cycles. And on every frame, it'll go through all of these methods, and any script that uses MonoBehaviour will execute their methods at those points in time. So for instance, update is a method you can implement, and what that'll do is that once per frame, whatever is inside of here is going to be called. So if your game runs 60 frames per second, it's going to be called 60 times in a second. There's also void fixed update, which operates like update, except it only is called a set number of times per frame. I'm not exactly sure how many that is, but the difference is update can run as many times as your computer can handle, but fixed update will be more of a consistent number, like 30 or 60 times in a second. Usually it's recommended if you do any kind of physics calculation that you do it under fixed update instead of update. So that's the main thing to keep in mind there. Use fixed update if you're dealing with physics or rigid bodies. There's also late update. Whenever you call late update, it's guaranteed to happen after update. So if you're waiting for some value to be obtained inside of one of your MonoBehaviour update methods, you can call that within update. And then you can be assured that when late update is called, everything that needs to happen in update has already happened. There's also awake, which will happen the moment that this script exists in the scene, whether or not the game object is created. And then void start will happen whenever your game object is set to active. And then void start will happen the first time that the script is set to be active. So just like you can enable or disable a game object, you can also enable or disable scripts inside of the editor. You can see here this little checkbox. If I was to have this unchecked, but then during the game somehow I enable this Boolean value, then at that point in time, the start method would be called. So there's these different lifecycle events you can kind of hook into by implementing these methods. And by doing that, we can achieve most of what we need to inside of Unity. So for this particular script, change color is going to randomly assign a color to the sprite renderer. What this means is that on every update, we can call it fixed update to make sure it doesn't become too ridiculous. So what this means is on every update or fixed update, we can just get reference to the sprite renderer, take the color of it, and set it to a randomly assigned RGB color. In order to create such a script, we're only going to need private void awake and private void update. If you care about exactly how many times it gets called per frame, you could also do fixed update. By the way, if you're wondering how many times fixed update actually will call per second, it's depending on what you have set in your game. If you're wondering about how many times fixed update gets called or how you can change the amount of times fixed update gets called, you can go to the edit menu inside of the Unity editor, go up to project settings and then time, and you can see fixed time step here. So this is set to 0.02 seconds, which means 50 times per second. Whatever is in fixed update would get called. So if you want to double that and you want this to run 100 times a second, you could just cut the time step in half. So this would be 100 times, because 100 times 0.01 equals 1. Or you could also reduce it to something like 0.05, where it would get called 20 times a second. So that means that the default is in fact 50 times per second for fixed update. So for this method, I guess we'll just use the update method, which means it'll get called as many times as frames happen inside of our Unity project. But in order to change the color, we need to first get reference to the sprite renderer. So you can see on this robot game object, we have a sprite renderer attached here, but the script doesn't know anything about that. So in order to get reference to that, the common way is going to be to first declare a sprite renderer variable. So sprite renderer, and we can call this sprite renderer. Now, whether you set it public or not here is going to largely depend on if you want this to be set inside of the Unity editor, because any public variable that you set inside of a MonoBehaviour script is going to be serialized to the Unity editor and to show up here. And if we set these variables to public, they automatically show up as soon as we save the script. So if we wait here for a second, it should pop up with a field where we can actually set reference to the sprite renderer. You can see that here right now. So one way to get reference to the sprite renderer, of course, is to make this variable public and drag it in. For right now, we'll just leave that as our option, keeping it really simple here. So we're using the robot sprite renderer in order to change its value in this script. If you're wondering why this value is black here, well, it's because this robot has a prefab object in our project, and this value actually is different from what's ever in the prefab. So if I check the prefab, you can see there's not even a script here for the color change. So if we want this script and this sprite renderer to exist on the prefab, basically whenever we copy this robot to the scene, we can just go ahead and hit apply up here. So that basically takes this change and makes it permanent across all robots that don't have their own overridden values. Since we've set the sprite renderer inside of the Unity editor, we simply need to make sure that that sprite renderer still exists, and then we can reference the color and change it on every frame. So we need to make sure the sprite renderer is set. So if sprite renderer does not equal null, then we know it has been set. So it's been set. And now we can do sprite renderer dot color is going to equal a new value. And this new value, I want to set it in several parts. I don't want this code to all go on one line because that'll be hard to read. So we will do color, new color, and that's going to be equal to a new color instance. So this new color that we're creating, it's going to need 3 variables, or you could also set 4. The 4th one would be alpha, but we don't actually care about alpha right now. So if I recall, we can set this as a value between 0 and 1, 1 where it would have full value for that color, and 0 where there would not be any of that color at all. And the colors are red, green, blue, I believe as well. So we just need to get 3 random values. So we can actually call the C# standard library of random.value, which you can see gives us a value between 0 and 1.0. Okay, and that's actually a property reference, so we don't need to have the parentheses there. I think this works. I'm actually not 100% sure if this is going to return the same random value or if it'll return 3 different random values. So we'll have to test that and see if that works. So sprite renderer.color is going to be equal to the new color. Pretty simple here. And that's going to be it for the script. Now, just to point out one other good way of getting reference to the sprite renderer, if you don't want it to be manually set by the user, What you could do instead would be to do sprite renderer equals get component sprite renderer. And what this means is that when the script awakes in the game, when the game object exists and the script is attached to it, it's going to automatically find the sprite renderer component on the game object, and it's going to set the sprite renderer variable equal to that. So by doing that, we could actually just change this to private, and the editor, the game designer, wouldn't even need to set the sprite renderer. Now you would want to make sure that the sprite renderer actually exists on your game object, so you could do one of these, a require component sprite renderer or type of sprite renderer. And by doing this, when you actually attach the change color script to the game object, it's going to automatically add a sprite renderer to that game object if it doesn't already exist. By doing that, it's a lot harder for someone designing your game object to forget about adding the sprite renderer when they add this change color script. This, by the way, if you don't know, is called an attribute, and there are a lot of attributes in Unity which you can get useful functionality out of in ways like this with require component. So this script should be pretty crazy, and because I made the variable private, you should see it disappear from the inspector. So whoever is working in the inspector doesn't need to worry anymore about this because it will automatically get referenced to the sprite renderer. Now, if you have multiple sprite renderers on your object, then obviously you probably want to specify exactly which one you want. And in that case, you might want to make it public again so that you don't accidentally grab the wrong sprite renderer. Either that, or you could get components and store all of the sprite renderers inside of your code file. But that's getting a little too involved for right now. So let's actually just go test this crazy script. So what should happen is that on every frame, the color changes to something completely wild. So let's give this a shot. Okay, awesome. So we now have a seizure-inducing robot that is changing color on every frame. And that was all done by just getting reference to the sprite renderer, attaching our change color script, and making it run on every single frame. Kind of reminds me of the star effect inside of Mario. You might actually want to slow this down a bit too. So if you want to slow this down a bit, one thing you could do is get reference to time.deltaTime, which is the amount of time that has occurred since the last frame update. And then you add that time to a timer variable, and if that timer variable has been passed, then you can change the color. So let's go ahead and do that in our color change script. So we're going to create a variable called public float time to change. And this variable will have a default value of 0.1f, which means 0.1 seconds represented as a float. And because it's public, anyone in the inspector can change this. So if they want to change how often the change color occurs, all they need to do is go into the inspector here, and that variable will show up as soon as our script has compiled. Now we're also going to need to keep track of how much time has occurred since the last change. So we can do a private float time since change. This, of course, is going to default to 0. And we're making it private because this is an internal reference variable. We don't want anything else to be able to change this or to mess with it. We only want this update method to handle this time since change variable. So what we can do out here is add the delta time to the time since change. So time since change plus equals time.deltaTime. So now every time update is run, which is many times per second, this is going to be incremented with however much time has occurred since the last update method. Now what we can do with that is we can see if the time since change is greater than or equal to time to change. And if so, then we can change the color. And if we change the color, then we want to reset the time since change. So we'll make that 0. And this is the basis of how you can do simple time-based effects inside of Unity. Whether that's determining the amount of time between a transition where you fade to black and load into another screen, or in this case, to randomly change its color. So let's go into the Unity editor here and wait for this variable to pop up. By the way, if you are working in Unity and you ever see red text down here, that's the error messages that are being given to you by Unity as it tries to compile scripts. You can check your error messages and find their spot in code by going over to the console, which is almost always at the bottom of your screen. And that would be one reason why variables like this may not refresh, because your scripts have to properly compile before they will actually update and reserialize all their variables inside of the Unity editor. But if everything goes well, then you should see the time to change variable. So this is set to 0.1. Let's hit play, and it should occur 10 times per second. So you could probably guesstimate that that's occurring about 10 times a second, but let's change the value here, which we can do, by the way, while the game is running. But if we change it while the game is running, it won't permanently change, only until we stop the game. But we can change this value to, say, 0.2, and oh, look at that, it slows down to half the speed. It's occurring 5 times a second. And let's change it to 1, just so that we can really see that it is, in fact, running once per second. And then if we want to make it something ridiculous again, we can go back to 0.01 or 0.0001, but obviously it can only run so many times per second, and you can only see so many frames per second with human eyes. If your value is ridiculous like this, then it will only update as many times as you have frames per second, because your game just won't be able to handle more updates than that. So let's stop the game, and you can see the value goes back to how we had it set in the editor. So if you just want to test out what a value would look like inside of your game while it's running, feel free to change it while it's running, and you won't have to worry about permanently updating it inside of the editor. So hopefully that gives you a good instruction on how you can implement time-based functions inside of a MonoBehaviour script inside of Unity, and a good overview of how MonoBehaviours work and some of the Unity lifecycle events that you can hook into. So that's going to be it for this tutorial. I have been Chris, thanks for watching, and I'll see you guys in my future Unity videos. Hello everybody, Chris here, and in this video we're going to be talking about scriptable objects inside of Unity. So right here, I have an instance of a scriptable object inside of my assets folder. So you might notice that it already is sharing some similarities to a prefab in that we can store it with all of its values inside of our assets folder. And then like a prefab object, we're able to reference the scriptable object from other scripts, MonoBehaviours usually, which would actually take these values or take the functionality of this scriptable object and do something with it. So you can see here, I've created a scriptable object called default settings. So over on the right, you can see it's got a Boolean value for whether the game has loaded or not, a integer for the number of times it's been loaded. And keeping track of something like that in a scriptable object is not a good idea, and I'll show you why in a bit. The name of the first scene that we might load into the game when the player hits new game or whatever, the amount of starting money and the amount of starting health. If we actually take a look at the scriptable object, we can go out in here. It's an instance of a game settings, but the idea behind that particular one is that I would use it as default settings in a game manager class, which can be a Singleton, or some other script you have in your project. So things to note about scriptable objects versus MonoBehaviours. For one thing, you do not attach them to a game object directly. They're not a component, and they don't run their own functionality. So you're not going to have something like public void update on a scriptable object that you would have in a MonoBehaviour. So note here that scriptable objects, although they're generally used for storing data inside of your project, they can still have methods in them because they're still a class, of course. So if you wanted to have something like public void multiply starting health, and then you could do like, I don't know, starting health times equals 5. For some reason, I mean, just giving an example here. You can have that, but the thing is, because a scriptable object isn't its own MonoBehaviour, it's not going to be executing any of these functions on its own. So generally what you need to do is that you would have a MonoBehaviour doing its on-update cycles as the game runs, and then it might do something on a scriptable object or call one of the scriptable objects methods. So inside of a MonoBehaviour, you would have the update method reference whatever scriptable object is attached to that MonoBehaviour in your hierarchy or your prefab. And then maybe you call the multiply starting health method. So it would be like the name of the file dot multiply starting health. Now, while we're on the subject, I'd like to point out that these manager classes I've been creating are actually scriptable objects in themselves. And that's why you see up here at the top, create asset menu, game manager, systems game manager. Just like in this example scriptable object, a default scriptable object that is, we have create assets menu, the name of the class, and then how you want it to show up in the menus. So it's under the settings dropdown and then game settings. The difference is with this Singleton library, which is available on the Unity Assets Store, there's actually a parent manager class which pulls in all of these scriptable objects and actually calls their functionality. So although this manager class is a scriptable object, it's being called by a Singleton updater, which actually instantiates a single MonoBehaviour, which takes all of these Singleton scriptable objects and actually calls their functionality inside of that MonoBehaviour. Okay, so why would you actually use a scriptable object in the first place? Well, there's a few advantages. First off, if you've ever worked inside of the hierarchy inside of Unity, looking at all these prefabs, the game objects, you may have occasionally noticed that things sometimes go missing and you might lose references to certain data. For instance, when you delete a script from your project, then it might show up here, oh, a missing script, and all of the stuff that was tied to that script is kind of lost because that script's no longer in the project. But if you have a scriptable object, this is actually an asset in your project. So this is going to stay there until you delete it. So this default settings asset file is going to contain this data until you delete this from the project. So you could attach this to a MonoBehaviour, and that MonoBehaviour script might lose reference to this, but it still exists in the project and it's still going to contain all of these same settings inside of here. So it can be a decent way to store certain information if you don't want to lose it later on. Now, another cool thing about it, and I'll show you an example of this, is that you can reference this same object from different MonoBehaviour scripts. So you can have one default settings object and it can be referenced from multiple scripts and multiple objects throughout your project. So for instance, the game manager, which is another scriptable object, as I mentioned before, has a reference to this game settings scriptable object, the default settings. So if I double click there, you can see it pulls us over to the default settings instance of game settings, which contains all of this information. So by having that object set here, we basically have all of the information inside of that object ready to reference inside of Game Manager. You also will be able to notice if you click over here on the right to get the selection, you can see all of the asset files, which are specifically instances of this game settings here. So it's pretty easy to pick one out from your project. And you can, of course, reference it from scripts that already exist inside of your scene or another prefab. So you can see here, default settings here is a field that takes a game settings, and I chose the default settings asset file to be the instance of that. So multiple objects referencing the scriptable object for different reasons. So now we can talk about why saving values to a scriptable object at runtime is not a good idea. The reason for that is that values in the scriptable object only permanently save when you're within the Unity editor. You can see here that the game manager, when its initialize method is called, it sets game loaded to true, and it sets times loaded plus plus, which means add 1 to it. And then over here in this is game loaded text script, which is purely just for testing here, it will output the base text message, whether it's loaded or not, true or false, and then the number of times loaded. So in theory, what you would expect to happen would be that every time the game loads, basically every time I hit play, it increments by 1, and that text should show a new number. So start at 1, then go to 2, then 3, then so on. And that'll work in the editor. So if we're hitting play in the editor, like we'll do right now, it will work that way. So you can see here, scene loaded, true, 1. Okay, great. Now let's hit it again. And then we'll have scene loaded, true, 2. If we check the scriptable object, we'll see that those values have been changed as we would expect. So game loaded is checked, times loaded 2, right? And we can hit it one more time just to prove that it does work within the editor. But as soon as we build the game, and we're no longer working in the Unity editor, but actually the executable file for the game, that functionality no longer works. So well, I've already built the game. Let's just build it to, prove it one more time that, I'm not pulling your leg or anything. So I've built the game one more time. We'll set the resolution here to what I actually want for the project, which is 640 by 480. Actually, it's supposed to be 640 by 360. We'll fix that later. So let's go ahead and hit play here. And it'll give us this scene loaded true. You know what actually happened? Because we changed the value in the editor, it actually saved to the executable build with that value. But I will show you, without a shadow of a doubt, if we run this one more time, it's going to show 4. So scene loaded 4. And we can run it one more time just to double prove. Okay, so we have scene loaded 4, right? So the value only changes inside of the editor. So for those reasons, you can't really rely on scriptable objects to be a good way to, say, save data permanently, and rather for something like that, you would want to write to an XML file or binary through a serializer. But what scriptable objects would be good for is something like the default settings that should load with your game. Or maybe you create a folder with all of the items that might exist in your game, all of the swords, potions, whatever. And then the data that's stored in that, you can reference that or pull that in for other classes, other manager scripts, other player objects or NPCs. But you should not change the values in the scriptable object simply because it's not stateful, and those values are going to reset to whatever it was at build time. So that's going to be it for this primer to scriptable objects inside of Unity. In future videos, I'll be showing you guys more about how to write them properly and what you can do with it on a more serious scale. So that's going to be it for this video. I've been Chris. Thanks for watching, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this video I wanted to give you guys a concrete idea you can use for scriptable objects inside of a Unity game. So you'll see here in this folder, I've created 4 instances of a scriptable object. So these are all saved as .asset files within our game project. And each of these files stores certain information. You can see that you can edit it inside of the inspector quite easily, just like a MonoBehaviour script. The difference is that these asset files created from the scriptable object script don't get attached to a MonoBehaviour directly. These are independent files that will exist inside of your game project, and they can be pulled into a MonoBehaviour. So you can basically set these objects as a field value, which we can kind of demonstrate that right here. So you can see here the shop script would actually be able to take a shop scriptable object asset file, but that's for the next video. So let's go back over here to game items. So the idea here is that you can actually create a big list of things that exist inside of your game or data to use inside of your game without having, let's say, like a MySQL database. So if you need something a little bit more lightweight than that, you can just come in here and do something like create items game item and create a new copy of the scriptable objects. So by doing that, you can just have a big folder with a whole bunch of scriptable objects, and they can represent all the items that exist inside of your game for inventories, shops, and stuff you might find in treasure chest if you're making an RPG. So let's take a look at how this script actually looks. In this case, it's pretty simple, because we don't generally want to write methods inside of these scriptable object classes. You can definitely do that, and sometimes it makes sense. But at a base level, they were really intended for being able to store certain values inside of your game project to use inside of your game. So we extend scriptable object, so public class name of your scriptable object extends scriptable object. And then here we just have the data which I want to store in that scriptable object, which we would obviously take and use in another MonoBehaviour script somewhere else. Now, the magic of scriptable object happens when you create a way for it to be added to your game project as an asset. So the easiest way to do that is to use the create asset menu attribute, which takes a file name, the default name for the file itself, and the menu name, the path to actually basically run the command to create this scriptable object. So you can see item/game item. And if we go over here to the project folder, we can do create items/game item. And just like that, we've created the scriptable object. We can drag this into a MonoBehaviour script. We can edit the values within that game object, which will not change unless we manually do that inside of the editor or while the game is running inside of the editor. So it's not a good idea to usually change the values of our scriptable objects here because, change it when the game is running. Because if it's in the editor, it'll save those values to the actual asset files in our game project. But if it's a built game, it won't save those values, so you'll get a lot of inconsistency there, and you don't want to actually overwrite this data, like accidentally changing the value permanently within the game when you only meant it to be sometime after the game has started in a specific file rather than for the entire game project as a whole. So generally, try not to set these values outside of the editor, unless you really understand what you're doing. So yeah, anyway, you can create scriptable objects. The fields don't necessarily need to be serializable, and we can take these game items and create an inventory system or a shop system by just referencing these files to create basically a list of which game items should exist inside of the inventory of a shop or a player, adding copies of this data to those shop inventories or player inventories, and we'll be talking about that more in the next few videos. So I'm gonna leave this one here. I've been Chris, thanks for watching, and I'll see you guys in my next Unity video. Hello everybody, Chris here, and in this video I wanted to talk a little bit about referencing scriptable objects within other scriptable objects, making it nested, and also using scriptable objects in your MonoBehaviour scripts. So first off, let's take a look at the script here, which is going to be relevant in the next video, shop event, which takes a reference to a shop scriptable object. You'll know it's a scriptable object because it'll always have this symbol over here. You can see that you can select this from the drop-down, and if we take a look at the actual script very briefly here, let's see, shop event. All you need to do to set a scriptable object is to declare an instance of that class object, and as long as we have it set to public, we'll be able to choose that scriptable object from our game project. So it's really easy to take this asset file data, which we have saved in our project as a physical file, and reference it within our other scripts, MonoBehaviours or other scriptable objects. So an instance of where it would be a scriptable object referencing other scriptable objects here is the shop itself. So the shop has a shop inventory, which, as you can see, has a list of these shop items, and the shop items have references to the actual game objects that we were talking about in the last video. So this cloud exists as a game item inside of our game. We might use it in a bunch of different places, but this is one place where we actually references it as a sellable item inside of our shop. So we can do the same thing with the fireball item, the servant item, or any other items we decide to create here just by going right-click, create items, game item. And now this would be another referenceable game item within our project. So by doing this kind of thing, it becomes really easy to have manageable data for basically a list of things like possibly enemy templates or item templates within your game, and to reference that from other scripts. And as long as these files remain intact inside of your game project, you don't go ahead deleting them or anything, this data should stay there properly. Now, one thing I do want to reemphasize though is it's not a good idea to go ahead and change the values in here while the game's actually running, because there'll be an inconsistency between the editor, where values that change in the game while the editor is running will actually be saved to the asset file directly. But when the game is built and exported, those same changes won't be reflected in these asset files because it's already been built into a game. So probably stay away from that, but scriptable objects become a really good tool for having data you can use when the game loads to start formulating things such as a shop inventory or the details of an enemy that you spawn on screen. So we'll be getting into that more in the next video, where we start creating the actual shop UI, referencing the shop and the game items that exist inside here. In order to create a decent shop experience, we can sell items to the player, and we'll actually have an inventory which will reference these same game objects or game items or instances of the game items that the player can use throughout his adventures. So that's going to be it for this video, just giving you guys a little bit more information about scriptable objects and their applications. I've been Chris, and I will see you guys in my next Unity video. Hello everybody, Chris here, and in this video I'm going to be showing you how we can take scriptable objects and use them to populate a shop's inventory and show that to the player inside of the UI. Now, I had already recorded this video. The recording didn't come out quite so well, so the scripts are already written, but I'm going to go ahead and talk through them as best as I can. Sorry about that for losing the original footage. So, to get started here, we have this chest object. Ignore the fact that it's a chest, but what it has attached to it is the shop event script. So the shop event script has reference to a scriptable object called the shop, which basically contains, if we double click on it, a list of the shop inventory. So all the items that should exist inside of it and the starting amount for those shop items. It also contains a shop slot because we're going to copy this data over to the shop UI as we create it. And the shop slot is going to be the game object where we actually create that object on screen. So that's going to take the game item data, the icon, the value, and the display name, and show that to the player as a shop slot. Could be a better name, but you'll see what I mean when we actually go ahead and hit play. So the shop event script is simply going to pop open the shop UI, instantiate this. Let's actually just take a look at the script here. So shop event here. If a shop UI prefab has not been created, or hasn't been opened, it's going to instantiate one of those on the canvas. It's going to get reference to the shop UI component. That's a script that's actually attached to the game object. And it's going to open the shop from that script, copying over the data from the shop scriptable object to the shop itself. So let's go ahead and show that happening on screen. And there'll be more magic that you'll see immediately that we'll have to talk about. So hitting play here, whenever it decides to load. Okay, there we go. So on the canvas, the shop UI has been created. And this shop UI has a grid layout where the shop slots have been created onto. So you can see here it takes the shop data, it copies it in here, and then the shop slots are used inside of the shop UI script. And these shop slots, of course, you can click on the buy button. They currently do nothing, which is going to hopefully be our next video, actually selling the item to the player directly. But you can see that it has the price set, it has the title set, and it has the icon, the image set. This is actually a sprite being set onto an image. So the shop UI script over here, it gets a few values from the inspector, which is the shop passed in through the shop event. The advantage of doing this is we only need to create the shop UI prefab once, but we can copy any shop scriptable object into those instances of the shop UI that we want. So basically, one shop UI can display any shop we have in the game, which is really handy. And then it has the panel over here, the grid layout group, basically the spot where we want to put all of these shop slots onto. And then the shop slot prefab, or shop item prefab, which is what keeps getting cloned here to display our data. So let's go take a look at that script in a bit more detail. So the shop UI script, as I mentioned before, has those stuff in there. Also has the shop inventory as a private list over here. So rather than modifying the shop scriptable object, which honestly it should probably be renamed a bit like shop template. Let's do that now, actually. I'll forget about it otherwise. So let's rename this to shop template so that it can be referenced everywhere more properly. Because we're copying this data, we're not trying to edit it. So let's see, an open shop, which is being called from shop event. The shop inventory is being copied over from the shop template. We'll also rename that here, shop template. It's being copied over into the shop inventory. And as you know from earlier, the shop items, which there's a list of, the shop inventory, contains a shop slot. The reason for that is we want to associate the game object with the game item itself. So when we display a game object on screen that maybe has the image from that game item data, we also have a link. We have a link between the data and what's shown to the player, which makes it easier to edit later on if we ever need to do anything like subtract one item from the inventory, which we'll probably do in the next video. But then besides that, we have this populate shop items function method, which is really important. So what it will do is when the shop opens, for every item that exists inside of the shop inventory, which we're taking from the shop template, basically every item we want to have in the shop, we create a new game object here, instantiate, and we instantiate that on top of the shop layout. The shop layout is a grid layout group, so it takes care of organizing its display on screen. Grid layout automatically does that. And after we've created the prefab, it should have a shop slot attached to it. This is another simple script which contains references to the title, price text, and the purchase button. And we take the data from the copied over shop items, and we update the shop slots with that same stuff. So whatever the display name is for the item that we've set in the scriptable object, we put that on the title here, the text of the title. Same for the text of the price. We update the value from the scriptable object. We also take the icon from the scriptable object and use that to show for the button's image display. And lastly, we take this object we've created and we associate that inside of the shop inventory. So that's where this shop slot comes into play, which will allow us to link all this data together later on and make it easier to edit. So the last thing we need to talk about here is the shop slot, which simply contains references to the title, price texts, and the purchase button. And that is manually set in the editor for the prefab, so I can show that as well here. We have the shop slot. So the shop slot, as you can see, is a game object prefab, which has the script where we set the references. And then we have the name text, the purchase item button, and the price text. So the reason for the script is just making sure that everything is linked up properly and we can reference those fields in the shop UI script to properly update them. So one thing I want to point out is that if you ever change the class name of a scriptable object, you also need to change the script name of the scriptable object class. So you see here it's now shoptemplate.c#. The script name has to match up with the shop template, or else your asset files are going to kind of be a little bit screwy and lose their references. But your asset files are still there, so once you update the C# file name, the data will still be there. Don't worry too much about that. Just know that you need to change both whenever you change one. So now we can go ahead and take the shop, which we'll call shop template now, and we'll link it back up to the shop UI prefab. So shop UI as a prefab is going to take reference to the shop template. And now if we go ahead and hit the play button, it should work as it was doing before. And it is. So in the next video, we're going to be updating these scripts with the ability to have a player inventory and to copy one of these items into the player's inventory so that they can use it as they adventure throughout your games, whether that's a healing potion, a fireball, or a servant that they can spawn in the game and use to help them out with their quest. So that's going to be it for this video. I hope you guys are learning a bit about scriptable objects, and I will see you guys in my next Unity video. Hello everybody, Chris here, and in this video I wanted to give you guys a comparison between Aseprite and Pyxel Edit, two pixel art creation tools specifically designed for pixel art. You could of course use something like Photoshop or GIMP and you'd be able to create pixel art, but because those programs aren't specifically designed for it, you get a lot of weirdness when you're trying to do things like, let's say, rotate a few pixels 45 degrees, or to place a 1 pixel square on your screen. So one thing I want to point out for you guys before we get into this video is that I am definitely more of a developer than a pixel artist. I am new to the whole creating pixel art thing, and though I think I am improving, I would not consider myself like a professional artist or anything. So keeping that in mind, let's go ahead and get started with comparing the two programs and hopefully give you an idea of which one you should pick up, if not both of them. So in both of these programs, you're able to create multi-frame animations quite easily. You can see that the different components of this animation are split into separate layers, which makes it easy if you want to do something like move this top petal without moving the flower base down here at all. Or if you want to add things to, let's say, this pot down below, rather than messing with the whole pot, but having that sit on top of it. So layers are pretty much a given, but in addition to that, both programs are going to have onion skinning, which allows you to see the before and after frame, and the ability to play back these animations while you're editing them. So you can go between animations, pretty much same in both of these programs. So over here you can see the pixel edit version of this. If I wanted to make some changes, I could just draw them on, and you'd be able to see them appear here in the animation. Basically as soon as I edit it, or even while I'm considering making that change. So if I increase my brush size here and I was to hover over here, you can see in that playback window, it'll show the pixel that I'm trying to edit. Of course here there's also onion skinning, same as with Aseprite, and they are really good tools for being able to animate this pixel art. It's a lot easier to actually see what you're doing when you have that playback window and the ability to animate different components on separate layers. So that's all well and good, but those are where these two programs are really similar when it comes to animation. I would say where Pixel Edit falls weak here is that you can't really see the layers and their reference to the animation you're doing so easily. So you'll have these layers over here, but you won't have any indication about if there's something in that layer with this little circle. You can't click on a layer in a frame of that layer and copy and paste that somewhere else, just with Control-C, Control-V, unless you're going to basically go to that layer, find the frame, copy it like this, and then drag it to where you want it to be in the next frame. Also, I feel that the labeling you can do up here in Aseprite makes it a bit easier to organize your frames, your animations, and to see exactly where you're working on. The ability to copy entire rows of frames is also nice. Now, how you can see where an animation starts and ends in Pixel Edit is when you have those animations selected. You can see over here that there's this thin blue line. So that's where the animation would start, and over here in the bottom right we can see where the animation ends, but it gives you a bit less information about what's going on with those individual layers over here. And then having the layers over here is a little awkward if you were going to do an animation on multiple layers. It's not that you can't do it, you totally can. It's just a little bit more awkward than the flow of Aseprite over here. Now, a couple other things about Aseprite that are good before we get to the advantages of Pixel Edit. First off, Aseprite does have more tools for you to work with when it comes to creating pixel art. So you have a contour tool over here and polygon tool for creating various shapes. You have the jumble tool over here, which is pretty cool. If you want to create something like a gravel effect, you can take pixels and mix them up very easily. And the blur tool allows you to easily get some kind of anti-aliased edges on your pixel art if that's something you want. So then there's also the gradient tool over here. Pixel Edit only has paint bucket tool. So if you wanted to get effects where basically you have one color transition into another, that's something that you don't really have access to in Pixel Edit. So I could see this kind of thing being useful if you have like a base background color that's just kind of blurred out. Maybe something that looks a bit more like this, where you would have grass in the background and then above that some kind of sky or mist. So one other tool that's pretty useful inside of Aseprite is shading. So if you have the pencil tool selected, you just change the ink from simple ink to shading, and then you can select colors over here. And while you have these colors selected, and it recognizes one of those colors inside of your artwork, you can see here the middle color is there. Left click will turn your color towards the left, basically making it a lighter shade. And then right click will make it darker. So this would be really useful if you're doing something like creating a rock. And then you want to get a couple different shading colors really easily without having to manually switch between them. So you can easily make your colors lighter and darker. Now that said, although Pixel Edit doesn't have that, you could easily just select your colors manually and then kind of go over here and draw them. Now that said, although Pixel Edit doesn't have the shading tool, you can just kind of shade yourself if you want to do it more manually by selecting the color you want to shade, left clicking, and then you go to the next color and putting that in. It's not hard to do that in Pixel Edit. So let's talk about where Pixel Edit is really strong, and to me that would be tiling. So in Aseprite, for whatever reason, you don't actually have the ability to take let's say a 16 by 16 pixel square and turn that into a tile, and then to tile from within Aseprite. You can draw in tiled mode, which you can do by going to view, let's see, view tiled mode, tiled both axis. And then if you have like 132 by 32 pixel sprite, you'd be able to see how it tiles, and you can still draw it like that. And yeah, that's all well and good if you only want to work on one tile. But if you want to see how multiple tiles can interact with each other, then Pixel Edit is definitely going to be stronger here. So inside of Pixel Edit, I can create a tile, and then now that I have it in my tile base, I can just put it onto the map really easily and start placing my tiles. And you can also rotate them, as you can see here. So you don't need to make 4 corners, you only really need to make 1. And then we put the sides in, and just like that, we've tested our tile inside of Pixel Edit. Now to create the tile, of course, you have to use this tile placer tool. So to use the tile placer tool, we've got to hit Control click to create a new tile. And once you've done that, it appears down here below. You can duplicate it, make modifications to it, whatever you want to do. Earlier today, I was working on this a bit. So this is basically kind of a prototyping of how one of my levels might look in the game I'm currently working on. And you would have a pretty tough time doing this kind of tiling if you were working out of Aseprite. Now, that said, you could just get a tool like Tiled, which is specifically about taking tile sets and creating your game maps, and then you can export that to programs like Unity. So it's not like you couldn't just create your tiles inside of Aseprite and do that. But having these features for tiles, it makes it a lot easier to test out your actual pixel art if you're trying to deal with tiling and see how it all kind of comes together before you actually put it in your game. So that basically summarizes most of the differences between the two programs. Which do I think is actually better? It's a really tough call. I think I like Aseprite when it comes to animation, and when it comes to things like making a character animation, I think I'm going to be playing around with this tool more. In terms of creating tiles, I definitely give the edge to Pixel Edit. So I suppose if you had to pick one of the two programs, it would depend on what your focus is. If you are trying to animate a bunch of characters, I feel it is easier to do that inside of Aseprite. And if you're trying to test out tiles, I think you're going to have a better time going ahead with Pixel Edit, simply because when it comes to creating and using tiles, there's a few additional tools in there that are more specialized towards that. But you would be just fine if you used Aseprite plus another tool, such as Tiled, which is free to use, by the way. There's also been good tutorials on YouTube so far for creating tiles in Aseprite. Even if you want them to kind of tile them together and see how it goes, you can do all of that in Aseprite. So you'll be fine either way. And then, of course, when it comes to doing animation, the UI in Aseprite feels a lot more user-friendly for creating your animations in the program, thanks to the timeline down at the bottom. It's very nice. So just to point out a couple more things that are pretty relevant, Pixel Edit, I believe, is still in its beta. It's pretty much fully usable. I mean, you can see everything on screen, but it's still at 0.4.8 version-wise, so maybe it's not quite as complete as Aseprite. Aseprite has been around for quite a while. It's version 1.2.9. That said, I've actually been using Pixel Edit longer than Aseprite, which I picked up a few days ago. So, you know, maybe a little biased there. But hopefully overall I was able to give you guys a really good idea here of the two programs and the minor differences between them. So I've been Chris, thanks for watching, and I will see you guys in my future video content. Hello everybody, Chris here, and in this video I wanted to show you guys how we can install extra color palettes to Aseprite so that you can use them on your pixel art. So first off, I'm going to go find a decent color palette online. So lowspec.com/palette-list is a really good resource for finding colors for pixel art. Okay, so Dawnbringer 32 colors looks pretty good, so we'll go ahead and download this palette file from here. So as you can see, this site has special formats for Photoshop and GIMP, but inside of Aseprite, we can actually just use PNG image 1x here, which is going to give us a really tiny image file to download. Essentially what this is it's just all the colors in a row. So if we zoom in here, we can right click and save this image. So where we're going to want to save this new color palette is going to be wherever we have Aseprite installed and then into the palettes folder. So for me, I have Aseprite on Steam, so I want to go to C drive, program files, and then from the Steam directory, we go to Steam apps, common, Aseprite, data, and then into the palettes folder. So yeah, if you have Aseprite and it's not purchased on Steam, the location might be a little different, but we just save the PNG image into this folder. And now we need to restart Aseprite. So I'm going to close this out and I'm going to relaunch it from my computer. So booting that up, we can start a new sprite file very quickly. And let's go to presets over here in the top left to select a color palette. And we should see the Dawnbringer 32 over here. So we can just select that and then we can start editing with those colors. Now, if you want to customize your own palette, you can click on the edit color icon over here in the top left, which will unlock the palette, and then we can make changes to the colors by selecting the color we want to change to a different one. And let's just say we did this a bunch. Then we can go over here on the right and choose Save Palette, and then we would save this in exactly the same location. So for me, that's going to be back in the Steam folder, Steam apps, common, Aseprite, data, palettes, and just put it here with a new name. So we can call this custom palette and just save it. And then the next time you load up Aseprite, that custom palette should load up by default. So we can see custom palette loaded right here. And that's pretty much all there is to adding custom color palettes into Aseprite. So I've been Chris, thanks for watching, and I will see you guys in my future content. Hello everybody, Chris here, and in this video I'm going to be showing you how you can properly import 2D sprite art assets into your Unity 2D game project. So if we take a look here at these little sprites I've dragged and dropped onto the scene, you can see a few problems with them. For one thing, if we zoom in a bit here, it may appear blurrier than it otherwise would look. If we opened it up with a program like Photoshop, it may appear blurrier in Unity by default. So another thing is that we drag it in here and the scale might not be matching up. So you might have an object which is supposed to be as big or bigger than other characters, or you may have designed your character so that it fits into a couple square units. Like let's say you designed it at 32 pixels per unit, but it's not displaying at 32 pixels per unit. One other problem that may occur while you're trying to drag a sprite into the scene is that if you are using a sprite sheet, if you drag the image over here, it may appear on screen as every single sprite inside of that image rather than one individual sprite. So all of these very common problems of blurry pixels, the object not matching its pixels per unit properly, and having multiple sprites be dragged onto the scene can easily be rectified inside of the project folder. So if we click on a sprite-based art asset that we've put into our Unity project, what you'll notice is that over on the inspector, we get a lot of modifiable properties that we can use to adjust how those sprites are rendered inside of Unity. So the first thing you might notice up here is called sprite mode. It's by default set to single, and you only want it set to single if there's only one sprite inside of the image. So if you have an image like this, where it's one of those piranha plant type things, or if you have a mushroom sprite that does not have any other sprites inside of the file, then leaving it as single is fine. But if we're working with something like a sprite sheet of 4 chests, we need to change this from single to multiple. However, in order to actually break this file into multiple sprites, we also need to go into the sprite editor over here. So it'll ask unapplied import settings. We can go ahead and hit yes on that. And when the sprite editor pops up, you'll notice all of the sprites basically displayed on screen for you to slice the sprite sheet up into individual sprites that can be used within the Unity editor. So to actually slice them up, there's a slice option up here at the top left. Automatic is one option you can sometimes use in order to get decent results, but if you know the exact grid size that you are working on, doing grid by cell size or grid by cell count may work better in many cases. So I believe that these files have a 32 by 32 pixel grid size. So if I change the X and Y pixel size value and then hit slice, we're going to get perfectly sliced grid items. For the record, this is why it's so important when you're making pixel art to keep things on the grid so that they can be sliced up properly on the sprite sheet. So once you have your 4 sprites individually sliced here, we can close that out. It'll give you unapplied import settings. We want to apply that because we want to confirm the slice. And now the chest object that we've dragged into the scene is showing as one sprite. If we expand the sprite sheet now, we can drag in individual sprites as we please. So that fixes one problem. The other here is that the sprites look blurry, which isn't good for a sprite game. In order to rectify this, we can select multiple items to be efficient. So all of these items that we're working on right now, I select them by holding the control button down. And you'll see under the Advanced tab in the inspector, filter mode bilinear and compression mode normal quality. For a low resolution sprite based game, I highly recommend you change filter mode to point, which is no filtering, and then compression mode to normal quality. When we hit apply now, what you'll notice is that these sprites become much sharper, similar to this robot and the tiles underneath. It looks like it should, or it looks like we designed it to be inside of another program like Photoshop or GIMP. So lastly, you can imagine that these little game objects, or the sprites for the game objects, were designed to be at least 1 square big, but currently they're not rendering as 1 square, and that's because they were designed at 32 pixels per unit. But whenever you import sprites into Unity, as you can see here, it defaults the pixels per unit to 100. So if you are designing your items or your characters or your game objects at 32 pixels per unit, for any sprite sheet or sprite you import into Unity, change it to the proper pixels per unit. So here I'm going to set it to 32. Now we can hit apply. And now this object should appear with the right size, and I can drag it where I want it to go. Just like you did with filtering, if you know that all of your art assets have a consistent pixels per unit size, you can grab everything in your assets folder. This time I will do a shift left click on the last file in order to select everything between the first and the last file. And we can change the pixels per unit to 32 and hit apply to change them in mass. And if I do the same thing with all the files in this folder, changing the filter mode to point and the compression quality to none, then we can get the right look for all the sprites in here. When it comes to changing the sprite mode from single to multiple and slicing up the files, you'll have to do that individually because each sprite sheet is going to need to be cut up differently in many cases. So just to reshow here, I'll go into the sprite editor after setting it to normal mode, and we'll slice 32 pixels by 32 pixels. You can see that this actually takes up 2 squares. So one thing we could do if we want this to be settable as one object is we could actually change it to a width of 64 pixels by 32 pixels, and now each of these mushrooms are one object, even though they take up 2 squares horizontally. And we can do the same thing with these mushrooms that are supposed to go on the wall. So set it to multiple, sprite editor, apply, slice it up, and then 32 pixels by 32 pixels, because that's how these mushrooms were designed. So we can apply it. And now we've taken care of the import settings for all of these art assets inside of this objects folder. So hopefully that gives you guys a really good idea of how you can import 2D pixel art or sprites into your Unity games and get them to display properly. I've been Chris, thanks for watching, and I will see you guys in my future Unity content. Hello everybody, Chris here, and in this video I want to show you guys a quick and easy way you can have sprites render in front or beyond each other through a simple calculation. So in this case, I have this movable dog character and this tree, and if the dog is in front of the tree, I want it to render in front of that tree. You can see that as the sprites overlap, the dog gets shown on front, but if I go behind the tree, then the tree will show in front. So that's a pretty cool effect you can get, and it's not too complicated in order to get. If I go take a look at one of the inspectors for these game objects, you'll notice in the sprite renderer that there is an ordering layer that's set to something other than 0. So by changing the order in layer, we can change which one will show in front of the other. So you also notice as I move around that order in layer changes. And that changing as I move in the Y direction is what allows the game to figure out which object should show in front. So over here I have the code for controlling that sorting order. So in my case, I have it as a Singleton, basically a game manager system. So this is always running and there's only one of it. Now, if you want to implement this kind of thing, you can use the Singleton package. But really, the only thing we really need to focus on here is that we get all of the sprite renderers in the scene in one way or another. This way, calling it on update is not very efficient because that means on every single frame we have to go look through all the objects in the scene and find every single one that has a sprite renderer. That said, it does work. In any case, find a way of getting access to all of your sprite renderers. And then for each of the sprite renderers, you have to change the sorting order to some kind of formula. So the important thing isn't exactly what's in this formula, but rather that it is consistent across all of your objects. So in this case, I'm taking the Y position of the transform of every game object that has a sprite renderer, and I multiply that by -100 to get the sorting order. The reason why you multiply by a negative number is so that if you're going down on your game and you get to a point where the position is actually on the negative units, so like -0.9, that the order in layer is positive because positive numbers will show in front of negative numbers. And if you want the items that are lower, basically to have negative Y positions, to show in front of the ones that have positive Y positions, then you should make it a negative number. That's the important thing here. I've also seen people do times -10, but I like times -100 because it gives more fine control over the order of the objects. Basically, by multiplying it by 100 before you cast it to an integer here, because the sorting order is an integer, you'll get more variety of numbers there, and slider moves will have a greater effect on this order. You could even do times 1,000 if you really want. But anyway, you just run a calculation and you put that into the sorting order, and then whichever items have the highest sorting order value are going to show in front of other items for that layer. Beyond that, the only important thing is that all of these objects that you want to sort with each other should be on the same layer. So if you go over this sorting layer and you add sorting layer, you can create a layer which all of these things are going to show on. So you can see here I have one for objects, and I'm also playing around with a sorting layer for shadows and particles, which you might want to always show in front. In terms of these layers, the layer that is at the bottom of the list will always show on top of the other ones. So that's really all you have to do. You have to give it a sorting layer value through script, and you need to make sure that all of those objects are on the same layer. And then by doing that, you can have an object go behind a tree, but then at the same time be able to go in front of it as well. So that's going to be it for this video on controlling the renderer sorting order inside of your Unity games. I've been Chris, thanks for watching, and I'll see you guys in my future video content. Hello everybody, Chris here, and in this video I want to expand on my last video on sprite renderer sorting order and talk about how to get shadows to work in a 2D game for Unity. So this method of doing shadows is basically where you have shadows baked into the scene as its own separate sprite. So this tree has a shadow, but this tree and the shadow down here are actually two separate objects. And the reason for that is that we want to be able to, let's say, have the tree show in the background, but the shadow to still fully affect this dog as it walks through. Basically, having the shadow and the tree on different sorting layers allows this to occur. Otherwise, you'd run into issues like the shadow would not show if you were in front of it, like right here. So if we take a look at this game object, it's called shop event, but really it's just the tree. You'll notice that there is a sprite renderer for the tree And then as a child game object, I have a secondary sprite renderer that's rendering the shadow. So note here that the sorting layer for the shadow sprite is on the shadows layer, and you can call them whatever you want. If you want to add your own layers, you just click on sorting layer and then add sorting layer. Whatever is nearest to the bottom will always show on top. So this player game object, is on the objects layer, so the shadows will always show in front of it, and that's why if the dog walks through it, even if the dog's position is actually below the shadow will still show on top of it, and it's partially transparent, of course, so it gives a nice shading effect on the dog. And you can also see that the tree itself is also on the objects layer, so that allows sorting to happen for like the dog to actually show behind the tree if it is at a higher Y position. If you have any questions about getting the order and layer value set, just refer to my previous video. Okay, so this is what the actual image for the tree looks like, and I'm pulling these images off of OpenGameArt. There's a bunch of really cool trees, originally by Casper Nielsen, but there were some recolors done by William Thompson. This is the information. Go look them up on OpenGameArt if you want to check these trees out, because they're really well done in my opinion. On this sprite, we have the shadow down here, and you can see that it's not being rendered inside of the game engine. It's actually baked into the sprite itself. And then we have the tree over here, but currently it's all in the same layer. It's the same image. So what we want to do is we want to separate it into two separate images. So basically, we need to take all of this shadow area and move that into a different layer. So to do that, I'll use the magic wand tool over here in Photoshop. The process would be very, very similar if you happen to be using GIMP or some other program at the moment. So I'm gonna have to turn this tolerance down to get a better selection. We don't want to grab any of those tree pixels. Maybe I'll even lower as low as 1 or 0. Okay, so what we actually have to turn off here is anti-aliasing. I forgot about that. And now you can see that all of the pixels, which are specifically the shadow, have been selected, but everything else has been left alone. So we can just Control Z to grab that. And while we're on this new layer, we want everything to appear in the same spot. So I can go up to the edit menu, paste special, and then paste in place. So it's now in the same spot it was in the previous layer. And for these extra pixels, I can just kind of rough grab them with the lasso tool, and then I'll cut them again and do another paste in place. Okay, great. So now that's two separate layers, we want to merge them. So I'm gonna right click and merge down. And now the shadow is all one layer. Great. Now you could make the case that since we're dealing with two separate images now, it actually makes some sense for the shadow layer to actually include some of that inner area, because there would be shadows where the tree trunk is actually at. Up to you if you want to do this, but if you want to fill that in, relatively simple here. We can just eyedrop to get the color of the shadow, set the opacity, which I believe for the shadow is 60%, and to go ahead and fill that all in, adjusting the shape a little bit as needed. So this is basically dependent on whether or not you want the shadow to hit the tree as well. So now, as you can see, by putting that shadow in, because the shadow will always be on top, it'll look something like this, and the tree will actually have a shadow as well. Now that the shadow has its own section over here covering the tree itself can cast its own shadow on the tree trunk. If that's something you're looking for, then great. If not, then just don't worry about filling it in. Now we need to export these as two separate images into Unity. So in Photoshop, there's a function called layers to files. It's under export. So file, export, and layers to files. And by doing this, we can create two separate files for these two different layers. So I'm going to export that to my Unity game. And I'll hit run here. As you can see, it takes both the files and exports them. So back in Unity, we can see that these two files have been created. So because these images both have two sprites on them, we need to change the sprite mode to multiple, and let's stop the game for right now. And also we need to change the pixels per unit to be consistent with the game and the sprite size. So I'm changing that to multiple and 32, and multiple and 32 for the shadow as well. So now we can just open those up in the sprite editor. and we can slice them. I'll just do an automatic slice for right now. So that basically cuts around the edges of the sprite and figures out what should be inside of it for both of them. And I'll hit apply. Now one other thing I want to do here is to actually change the pivot point. And I think this is one of the things I was trying to find a better solution on, but for right now, changing the pivot point will basically determine for the rendering order, where should it be calculating the order from. So if you have that kind of calculation in your game where you're taking the position of it, this will be basically where the position is in terms of the sprite. So at about 0.15 there, and then 0.12 for this one. But of course, that's not directly related to this tutorial, so you don't necessarily have to do that. Okay, so I'll hit apply here, and we can go back to the shadows. So in the shadow sprite editor, I'll just automatic slice them. And yeah, you know, it might make sense to cut away all of this extra white space in the final export. I think you can have that crop when you're exporting from Photoshop as well. But for right now, we'll just leave it like that and worry about it later. So I'll apply that. And now we need to bring those items into the scene. So I'll just copy that prefab I had, and we'll change the sprites on it. So we'll do this green tree over here. Oh, and the reason it's blurry, by the way, is because we have filter modes turned on for the sprites. So for both of these layers, we want to turn it to point filtering and no compression, hit apply, and that'll make your sprites look a lot smoother. So obviously, because this is a different sprite image, the collider isn't going to be perfectly right, but we don't need to worry about that for right now. Let's just focus on getting the shadows in there. So changing it to the second shadow, you can see that the position isn't quite right. So we want to align that. So I'll just do this like the most simple way possible, which is going to just be to layer them on top of each other. Now, I think this shadow is supposed to be a bit darker, but you know, for the sake of just having the ordering go here, we can just stick with this for now and worry about that later. So the important thing for this video is that the character can walk behind the tree, but will be affected by the shadow in all cases. And you can see that because we have the sorting layers set to shadows for the shadow object, which is a child of the main tree, and the tree itself has a sorting layer of objects, which is consistent with the player dog, we'll be able to get the effect we're looking for. So let's go ahead and hit play and test this out. So the character walks behind the tree, but as soon as you go in front of the shadow, it's going to start showing on your character. And that applies whether you're behind the tree, whether you're in front of it. And also if the player is well below the shadow, but just barely touching it in terms of the sprites, if the shadow was in a higher layer rather than a lower layer, or in the objects layer, then it clearly would not be affecting the dog. It would hide behind the dog. So you could actually make the case that the shadow could also be on the objects layer as well, because if you think about it, if the camera is coming from out here and kind of looking at the tree, but the player itself is between the tree shadow and the camera, then you might actually not want that shadow to show in front of the dog when it is this close. Simply because the shadow might be cast on the opposite side of the dog, but not on this side that's actually facing the camera. So if you want that, you can just change the sorting layer over to objects. And what you can have is, by setting a pivot position on the sprite, the sprite of the shadow, you can kind of determine at what point will the shadow start affecting the dog, or where will it not. So kind of up to you on exactly how you want to implement that. But the general idea here to take away from this video is that your shadow and the tree, or whatever objects you're working with, should be separate images. You should bake the shadow as a separate sprite rather than having it render in real time, rather than it might in many 3D games. And you'll just have to keep in mind your sorting layers and the order in layer as you figure out which objects should be showing in front of the camera and should the shadows actually show on the dark or not. Once again, if you want to take a quick look at that script I had in the other video, the main thing is that you just take all the sprite renderers and you give them a sorting order through a simple calculation. And the reason we times it by a negative number here is so that negative numbers, which are closer to the bottom of the screen, will actually render in front of objects that are closer to the top of the screen, in other words, more in the background. So yeah, just take a quick look at that code if you want to implement that. And you might do this as a MonoBehaviour, attaching it to every game object, but I have it as a singleton using Singleton, which is a package you can get on the Unity asset store. But the general idea is just take all the renderers and give them a sorting order through your calculation, and you should be good to go there. So that's going to be it for this video on how to get shadows to work when you have a game object that needs them, having them as separate objects and getting their sorting orders to work properly. So I've been Chris, thanks for watching this video, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this video I'm going to be showing you guys how we can add lights to a 2D pixel game inside of Unity. So there's going to be a few steps for this. First off, for all of the sprites which we want to receive lighting from the Unity lights, we're going to need to change the material on their sprite renderer, or if you're using tile maps for all of this floor and wall stuff, then you also need to change it for the tile map renderer. So by default, the material set here is Sprite's default, which does not receive lighting from any sources. It only displays it as you imported it. So what we need to do is create a new material. So this material, I'm calling it Pixel Diffuse. You can see that it is using the shader Sprites/diffuse. So we can just go ahead and recreate this real quick. If you right click and go to create, and then down here for materials, we should be able to create a new material. And shader, we want to change this to sprites, and then diffuse. The last thing I'm going to do is check pixel snap, because we are trying to do a pixel art game with pixel perfect art. So once you've done that, you can go ahead and assign this material to those sprite renderers. Because I already have it, I'm just going to delete that new one. So I'm going to shift select these 6 grid tile map components so that I can change their material all at once. So where it says material, I'm going to select here, and we're going to go down for Pixel Diffuse. When you do that, you should notice that all of your tile map objects pretty much get dark immediately. So now they need light in order for you to see it properly. So creating a light inside of Unity is pretty easy. I can come down here to a game object, or if you want to create an empty, just right click, create empty. This is only a parent object to kind of organize all of the lights. So I'm going to right click it and add in light, point light here. Now for me, it's showing it immediately. For you, depending on the Z value of your grid or all the objects in your scene, you may need to change its position, because remember, even if you're building a 2D Unity game, objects still have a 3D position. And now with this light, we can manipulate its range and intensity to get the settings we want. So if we want less spread across our tile map grid, we can decrease the range here. If you want the intensity, basically the amount of light, to go up, you can take intensity and you can ramp that straight up to whatever you think would be necessary. And of course you can manipulate the transform. So pretend this light was like a torch on the wall, then you could kind of position the light right on that torch and it would make a lot more sense. Now, you'll see in mode that it's going to be set to real time, and if you click on this drop down menu, mixed and baked are probably going to be disabled for you out of the box, because we need to enable the setting for baked and mixed lighting. So we can do that by going up to Window, Rendering, Lighting Settings, and now we want to scroll down here, and there'll be a checkbox, Baked Global Illumination, associated with mixed lighting. If you check that, and you set the lighting mode to either Shadow Mask, Subtractive, or Baked Indirect. I'm using Subtractive right now. There's obviously different lighting modes, and you can check on the website if you're really curious about that. But the reason we are changing it to Baked Lighting over here in mode now is because real-time lights are incredibly unnecessary for a 2D pixel art game. We don't need it to constantly do things like calculate shadows. So where we have mode, we can just change that to baked, which is going to make the performance on the light a lot better. It won't be taking up nearly as many system resources. And with that, we can basically go ahead and test it out. Now, if you want game objects, like for instance this door up here, to also receive that material and thus receive the lighting, then you got to change it for each object individually. So for the sprite renderer here, I'm going to change the material as well to the pixel diffuse material that we've gone ahead and created. If you want more lights, you can easily do that. So I'm going to duplicate and move this light. Let's say over here, maybe increase the range of this light a bit and decrease the intensity. Move it a little bit more towards the center. And we can also duplicate the bottom light one more time, position it over here. And now I'll go ahead and test it out by hitting play. So this character over here, my Bernese Dark, it already has the material applied to the sprite renderer, so it can receive the lights as I move about in the scene. So if I get it really close to the light, you can see it becomes fully illuminated, and as I go further away, it gets dark. Same with everything else in the scene. Now, if you run into any issues with the rendering of your light, like if one of the lights happens to flicker for some reason when you kind of go off screen, what you can do is change the render mode from auto to important, which will force it to prioritize the rendering of that light. Just a quick fix if you run into any flicker issues, but I think since I changed that to baked lighting, there's no issue there at all. So that's pretty much it to adding some basic lights inside of a 2D game for Unity. Just make sure that any objects that you do want to receive light, like this leaf over here, you have to assign the material. Otherwise, your objects will display as if they were fully illuminated, and that may not be what you want, unless you want it to be obviously visible, like this dog in the corner over here. So that's going to be it for this tutorial. Hope it helps you guys out. I've been Chris, thanks for watching, and I will see you guys in my future Unity content.
Hello everybody, Chris here, and in this video I'm going to be showing you how we can add in a simple tiled background to a 2D game inside of Unity. So the idea here is that rather than changing the camera directly, adding something like a 3D skybox, what we actually want to do is to put an image inside of our scene and make sure it's tiled and also behind everything else in the scene, the tile map and any game objects that might be interacting inside the scene. So I'm going to show you guys how to set this up step by step. First off, you want to right click on your scene and go to 2D object and create a sprite. So this sprite, which you're going to set, you can call it background if you want. So I'll just call it background 2 here. And then you need to pick a sprite to go in this box. So over here in my assets, I have a background. You can see that the sprite mode is set to single. Pixels per unit is dependent on whatever tile size you're using in your game. Pixels per unit is going to be dependent on whatever tile size you're using for your game. And mesh type should be set to full rect. If you don't have it set to full rect, then when you tile it, it'll give you a warning. So we should just set that to full rect there. Now, assuming you're also doing a pixel-based game, filter mode should be point and compression should be none. This will make it so that there's no anti-aliasing or any kind of blur effects on the edges of your sprites when you put them in. And as a result, they will look exactly how they were created in an editor such as Aseprite. So with the proper settings on this BG Cave PNG, now we can drag this into the sprite field of the sprite renderer. So that should give you something like this. You probably want to center it on 0, 0, 0. But now if we go to game, you'll see that it's just one copy of this image, and that's not really going to look like a background, but more like a tile within the game, like these platforms. So in order to make it tile automatically, we can change the draw mode from simple to tiled. Now we need to figure out how far this should be drawn. So we can change the size, the width and the height to something like 32, 32, and that can get you the result that we were looking for. Now, I doubt it's going to be an issue, but if your game map is particularly big and you don't want this image to be stretched over some massive area like this, you could simply make sure it stretches to the camera size and then moves with the camera, always being a background, but always perfectly sized to the camera. But that would be an extra script you need to add, and I don't think it'll be necessary for our purposes here. But now we've got a completely different problem, which is that the image here is actually showing in front of the tile map grid. If we go to the game view, we can't see any of the tiles. So to change that, we need to use sorting layers in order to make sure that the sprite renderer for the background is hiding behind everything else. So it should be the last thing people see if there's no other tiles in front of it. So I've already created this background sorting layer. If you click on add sorting layer, you'll be able to see all of the sorting layers you've created for your game. Generally speaking, I think your background is going to want to be at the top because it's going to be in the background, hence the name. But since I've already clicked the add button and added that in here, all I need to do at this point is to change the sorting layer to BG. Now, something to point out about sorting layers as well. If you're going to make a very complicated tile map that, say, has 3 or 4 layers of different tiles, then these sorting layers will be very useful for that too. Just whatever you want to show in front of other things should be on the lower sorting layer, and that's generally how it goes. And order in layer, if you want to order things within a certain layer, then you can change this numeric value as well to further make sure that everything is in the right positions for your game. So now if we go into the game view, we can see that we have the background here. If we were able to move around a bit off the screen, then the camera would move and you would just see more copies of this tile. You might need to make it bigger if your map is going to be particularly large. But for most people's purposes, we're pretty much done here. So I've been Chris. I hope you found this tutorial on adding a 2D background in for your game to be helpful, and I will see you guys in my future Unity content.
Hello everybody, Chris here, and in this video I wanted to show you guys how we can use layer masks in order to hide part of a sprite that may be in an animation using Unity. So the basic concept is this. We might have something like a trap, like over here in Mario Brothers, where a giant pillar comes down and strikes the ground. So while it's in its idle state, most of this spike is actually hiding above the ground up here, and then it will come down and hit the ground. So at various points of this animation, parts of the spike are going to be hidden and parts are not. Now, it might be possible in many cases to just hide the sprite by having another sprite in front of it, such as this background wall that we see up here. But what if you don't have that? So you can actually hide sprites inside of Unity by using layer masks, which is a built-in tool for your game objects. So here I have a pillar trap. Forgive the very rudimentary art here. And this pillar is going to have 2 different states. So it's going to have an activated state where it comes up here and would theoretically hit or damage a character, and then it has its idle state where it will return to once it's triggered and drop back down here to the bottom. But then you'll see here, I have a layer mask here, which will actually hide the sprite as it comes down here. So in order to do the animation, we simply adjust the position of the sprite, basically moving it up and down. And when it is down, although we don't have anything covering it here like background, it's going to be hidden in the game because we have a layer mask hiding everything below here. So I can show this really quickly by adjusting the position of the pillar. So I'll bring this down, and by dropping it down to 0 or around there, we can see that although the sprite size is the same, the layer mask is hiding everything that drops below this point right here. So to show what this might look like in an animation, I can show you the idle state. So this idle state is what would be shown until the pillar is triggered. So this would be where everything is hiding over here below the layer mask. And then when you actually have the animation trigger, it will start at that idle state and it will play back, going to its highest point, and then sync back down. These curves are of course optional. Out of the box it gives you a simple one. So when you have a basic animation here over 1 second, it looks kind of like that. Okay, so in the actual game object itself, I have pillar trap base. This is where you would want to control the position of the trap in general. As you can see, although the sprites are split into 2 different parts, this base area right here, everything you see in red, So then on the pillar game object, which is a child of the parent, obviously in the animation you can change the position of it however you want. And by splitting your sprite into two, it becomes very easy to manipulate them individually, which can be helpful. Now to actually add your mask, I have a separate game object also attached to the parent pillar trap base here. And you can see it's just a basic game object that has a sprite mask attached to it. So for the sprite, I'm using a simple white square. It's 100 by 100 pixels. And then however much I scale up this simple sprite to is going to determine the bounds of this layer mask. So pretty much that's all you really need. I don't think I needed to even change the alpha cutoff point at all. And then once you have your trap animating properly, you can simply attach a box collider for where you want it to do damage. Use an animator in order to actually move the sprite. And I created a little pillar activation script, so when W is pressed, the animation gets triggered. So we can hit play and see how that would look like. So you may decide that it's not the player who's actually controlling the pillar at all. So I'm going to hit W here, and the animation triggers right after that. Note here the important thing that is when the pillar is actually down here under the base, that it is completely invisible. And to prove that it is there, I will disable the mask temporarily, and you can see how it looks without having the mask there. So if it was like this, that would not be the result we want, and that's why the layer mask is very useful in this case. So I'm going to include a link to this project in the description. You're free to use it however you wish. I've been Chris, thanks for watching, and I'll see you guys in my future video content. Hello everybody, Chris here, and in this video I'm going to be showing you how to move a character by adding forces to the rigid body of that character. And the reason why we would want a character to have a rigid body with a dynamic mode is so that other objects which may apply forces to that object can work properly. So if we have like a giant ball coming down the field and it crashes into this character, it might apply a force to him and change the direction in which that character is traveling. That's only possible if we're doing physics through the rigid body 2D, or 3D if you have a 3D game. So in order for rigid bodies to work, we obviously have to have one attached to the character. So I'm going to go here and add a rigid body 2D, and you'll see it's set to dynamic by default, which is what we want for that kind of physics-based play. You'll notice that it has gravity scale out of the box. This means that it will be affected by gravity if there's no ground underneath the character. He's going to fall down on the screen. Possibly something you want for platforming games, and you can customize how much gravity there is in the game by going to the preferences or the physics calculations for the game. Let's just take a look for that. I think it's edit project settings physics 2D, and then we have gravity. So it has a X direction and a Y direction, and you can see that this is set to real world physics of -9.81. You could have gravity to the left though if you wanted to, or you could have no gravity at all. Up to you for your game. So now that we have this rigid body 2D, we're going to need to reference that in script so that we can add forces to it when keys are pressed. So I'm going to add component here, and we're going to create a new script. I'm going to call it player movement for now, keeping it relatively simple, and pointing out that this is a script for the player's movement, which probably means in one way or another it's going to be getting input from the player, whether that's WASD on your keyboard or tapping on the screen to move the character. So let's go ahead and edit this script in Visual Studio or your editor of choice. Okay, so in this player movement script, the first thing we're going to need to do is get reference to a rigid body 2D, and I guess I'll just call this player rigid body. There are some default names, rigid body and rigid body 2D, for basically deprecated classes that exist in MonoBehaviour, but because those are deprecated, it's recommended that you don't reference them, and instead you get the player rigid body by doing something like get component on a rigid body 2D. So we could do that in Awake, or you can manually assign it in the inspector, but I think in this case we'll just grab it in script when the script awakes. So this is going to be equal to get component of rigid body 2D, and we'll also require the component of type of rigid body 2D, so that whenever this script is added to the player, it's going to make sure and add one, if it doesn't exist, a rigid body 2D. So right, this should work as long as the rigid body 2D is in the end attached to the player. So now what we can do is on update, we can check if any of the keys are pressed that are relevant to the player. And if so, then we can apply some forces to that rigid body. So first off, I'll check if the player rigid body does not equal null, then we'll proceed. And if not, then I want to be logging out some warnings to the console. So debug.log warning, rigid body not attached to player. I guess we could get GameObject.name. But if the rigid body is attached, then we want to check for input. So I could make this a new method called apply input. We'll go down here and make that method. So public void apply input. And this method is going to check to see if any player keys are down. And if so, perform relevant actions. So for seeing what key settings we have applied to our game, we can go to Edit, Project Settings, and Input, and you'll be able to see the default controls for the game. And this includes stuff for basically joysticks, for keyboard controls, and I believe you can set stuff up for like external devices as well, if you have like a game controller. So ideally we'd like getting the input to not be specific to the controller, but we only care about the value, and then the input manager handles which controller is assigning what value to the input fields over here. So one way we can do that for left, right, up, down movement is to check the axis input. So we can do get axis. So let's get axis, and the name of the axis I think might be X. I'm not actually 100% sure on that. We'll have to test it a bit. Oh, and actually this returns a value. So we want to take the float X input, and we'll do that by getting the axis value, and then we'll get float Y input and input.getAxis. Okay, so in theory that should give us an X and Y input. So if X input does not equal 0, then we're going to want to apply that X input as a force on the rigid body. So let's get the player rigid body and add force. And that force is going to be a vector 2. Okay, so in order to apply a force onto the object, we're going to need to create a vector 2 for that force. And we can do that by creating a new vector 2, getting an X value, and then a Y value here. And then finally, we apply that as a force to the rigid body 2D. Now in my mind, I'm thinking it's better probably to do this only once per cycle. So if we have like a jump going on and X input for moving left and right, we'd probably rather get those values, combine them into one vector here, and then apply the force once rather than trying to add force multiple times in the same script to the same object. So for right now, we'll just have the Y set to 0. We won't do jumping yet, but with the X input, if the X input is not equal to 0, but with the X input, we can get a X force here. And the X force is going to be equal to X input times move speed, which is a variable we'll just set up here in a minute. And then times time.deltaTime, because we only want to add a force relevant to the amount of time it's been since the last frame. So if it took 1 second for a frame to occur for some horrible reason, then we want to apply a lot more force, obviously, than if the frame took 1/100th of a second, since this is applying every frame update. Oh, and also, now that I think about it, because we're dealing with physics here, we should be doing all of this on fixed update, not update, so that this will occur a set number of times per frame and have more consistency. Unity does recommend that you do this whenever you're doing physics-based calculations. So now we need a variable for move speed, and we'll probably set this as a public variable, so public float move speed, and we can default this to 1 or 5 or whatever, but generally we'll set this on a character by character basis to determine how fast they should move. And we take this X force, we add that to the vector, and then that force gets added here. So we don't need to worry about if this is 0, because if the x input is 0, there's no input, which means all of this multiplication is going to result in 0 anyway. So basically, if the key is pressed down, then it's going to move, but if it's not pressed down, then it's not going to move. Or rather, it's going to add a force to the object. So the difference is this is more of an acceleration-based thing. If the object still has force in play that hasn't been reduced by friction or other objects stopping it like a wall, it'll keep moving. So you can actually, in the inspector, for the object, you can add stuff like linear drag and angular drag to determine how quickly those forces should fade out. Mostly something you just need to kind of tweak around with here and figure out exactly how you want this character to interact with the world. So one more thing, I'm going to make this rigid body private. Because the script is already grabbing the rigid body if it's attached anyway, we don't really need to have the game designer mess around with it and the editor. We just need to make sure that there is a rigid body attached here. So we don't need this to be manually set, and we can make that private. So let's go ahead and see if this works at all. So by the looks of it, I have the axis name wrong. So let's go ahead and take a look at that. So let's see, input horizontal, vertical. Okay, so these are the names actually, horizontal and vertical. So let's go ahead and get that there. And these are names that you can change, by the way. Okay, so I'm pressing left and right here, and we can see that it's not moving, or at least it doesn't look like it's moving. So we'll need to debug the script and figure out exactly what's going on there. So I'm going to add some breakpoints here, attach the debugger to Unity, and let's go ahead and figure this out. So we can see that it's hitting the breakpoints on every frame, but it's kind of going to be a pain to debug it like this because this is a on update physics calculation, so it's going to break in here every single time that the game loads. So I'm thinking an easier way to do this might be to just run some debug logs to the console. And let's debug.log if we can get the velocity of the player rigid body. Let's go ahead and do that as well. And for the sake of making it a little bit easier to read, let's actually label these. So let's see, velocity, and let's go ahead and save it and hit play one more time. Okay, so we can see that it is getting X force and Y force when we do hit the plus button there. The velocity, however, is remaining 0. And one of the problems with vectors is that you don't really get the floating point value there. And you can see one of the problems with logging a vector to the console is that it does cut off a lot of decimal points. So you can't really tell if this is actually exactly 0 or if it is some very small number. So what we can do is instead log the float values. So player rigid body velocity.y. And let's try that one more time. So kind of weird. We can see that it is an infinitesimally small number, but it's not exactly 0. Let's see if we bump the movement speed up times 100. Does anything change here? No, it doesn't. And I'm guessing what's happening here is that it's actually stuck on the ground beneath it. So what would happen if we say took this wall ground and moved it down a bit? Okay, so we can take a look at the box colliders that exist over here, or in this case, these colliders are actually a tile map collider. But in any case, it's applying that collider to everything that is on this grid, every tile, and we can see that it goes a little bit above the robot's feet, but the robot has a box collider, which actually goes down below that. So two box colliders are overlapping each other. They're basically stuck on each other. So I'm going to manipulate this box collider's position a little bit. And actually, because currently we're doing a dynamic rigid body game, it might make more sense to use a capsule collider even. Capsule colliders tend to work better when a character is close to falling off an edge in terms of modern 2D game physics. So this may be preferable. So let's go ahead and lower this down, and let's check the grid collider. Seems okay. We'll give this a shot and see if this works. Okay, so the robot fell over, so that's something. At least it's not getting stuck in the collider right now. let's see if I bump the movement speed up, if it's able to move to the right or not. Okay, doesn't look like it. So one thing we might want here is to add a rotation constraint, not allowing this sprite to fall over on its side due to gravity. So let's freeze the rotation on that character, and I'm also going to increase the default move speed to 10, so that hopefully if something is going to happen, that it's a lot more obvious when it does. Okay, so I hit right, I hit left here, and it's still not going. So let's take a look at the collider really quick. Okay, it looks like the collider is above the ground. And you might also want to lower the colliders on the ground, or change the sprite so that that ends up happening, cutting off that little top area, whatever you need to do. Okay, so as it turns out, the only thing that wasn't going quite right now is that the value is so low in the move speed that the player, I guess the drag keeps it from moving before it can actually move. So it looks like the current fix was actually to increase the move speed, because the natural drag of a dynamic rigid body object was keeping it from moving, basically, because the drag was greater than the force being added to it. But now that the move speed is set to 1000, it can move a lot more like what we would expect. And you can see that when I let go of the input button, it slows down on its own, which is pretty cool. So that aspect of the physics engine is already included for us. And if I fall off the edge, the gravity goes ahead and takes place. So that means obviously that the character sits on top of colliders like this ground by default, and we don't need to write anything else for that part of the script. So one little detail here, having the move speed set to 1000 might be a really big number and kind of displeasing to look at. I think usually people like to use numbers that are a lot smaller. So one thing you could do is have a global variable, something like a move speed multiplier, and you can just take whatever move speed you have here and then multiply it by that global modifier before you assign it to the actual character. But if you do that, then you need to make sure at any time when you actually assign a force to the rigid body, you need to add in that global multiplier before adding in the final force to make everything consistent. You could do that with a manager class that manages the movement of all characters within your game. It's kind of up to you on how you want to do that precisely. So one more thing we might want to add here for left-right movement is a max velocity. So let's see here. Public float max speed is equal to, we could just say 5f for right now. We'd need to tweak the value later on. And so if we add the force and the player rigid body dot velocity dot x is greater than max run speed, we'll change the variable name there. So what we're going to want down here is some kind of extra function to cap the velocity. We could actually put that over here because it's not really relevant to the input. It's making sure that the rigid body doesn't move too fast afterwards. So we could call this cap velocity. And now we'll come down here, public void cap velocity. And we will do this for both the x and the y axis. So we're going to be creating a new vector, and this will be... So for this function, we're going to need to get the capped x velocity, and we can set that equal to a math function. So we can set that to math.floor, which means takes the lower of the two values. And we'll do that on player.rigidbody.velocity.x and the velocity cap, so max run speed, we'll call that. Renaming this up here, so max run speed. Running, of course, being left and right velocity. Oh, actually, what we want here is min, I believe, taking the minimum of the two values. So that means if the velocity is above the max run speed, then it'll just return the max run speed. Now, one thing here to note, though, is that if you are running this function, if there's anything that would want to make the character move somehow beyond that max velocity speed, you'd somehow have to work with this function, because this function's going to keep trying to cap it. You could have like a Boolean value where it's like, is capping enabled? Actually, we could go ahead and set that here, so why not? Public Boolean cap enabled. And we'll set that to true. So we could say if cap enabled, then cap the velocity. And we could also rename this something a little bit better. So velocity cap enabled makes a little bit more sense to me. So now we can take this updated velocity and pass it into the actual rigid body. So player rigid body dot velocity is going to be equal to a new vector3, and that's going to be equal to capped x velocity. For right now, I guess we'll set the variables, but they won't mean anything much here yet. So capped y velocity, and just for fun we can say capped z velocity, though this is a 2D game, so that's probably not too relevant. And we'll just set these. Capped y velocity is equal to layer rigid body dot velocity dot y, and the z velocity, same for the z value, player rigid body dot velocity dot z. And we're just using these as a placeholder, so that if we ever need to set a cap for going up or down speed, like fall speed, and a cap for z speed for some reason, then we can go ahead and assign it in there. Actually, no, rigid bodies 2D don't even have z velocity, which makes sense because they're supposed to exist within a 2D game world, so we don't need to worry about that. Okay, so let's see. The velocity cap is enabled, so it'll cap the velocity. Let's see if it works here. So I'm going to hit right here. So it looked like it wasn't going any faster than it should have, but let's make sure by making this very, very slow, the max velocity cap. So with a cap of 1, oh, we can see it actually does cap very slowly. Oh, but it's only in one direction as well. So that's kind of a problem. We're going to need to make this an absolute value. So let's actually take mathf.abs of both values. Or really, we only need it for this value. And then regardless of what it returns here, we're going to want to multiply it by the sign. So we'll take mathf.sign of player rigid body dot velocity dot x. So the idea here is that initially we just want to compare the raw value of the velocity against the run speed. And then we take the smaller of one of those two values. But we still want the sign to be relevant, because if the character's moving left, we still need to make it negative in the end. So we need to take the sign of the velocity, which is either plus or negative 1 or 0. I think it can return 0. And it's going to multiply that over here. So this should work for us. Just a little bit of simple mathematics. Let's go ahead and make sure that that's the case. So pressing right to move it to the right. Okay, and it slows down thanks to drag. But we can also go to the left. That's good. Now, let's make sure that this is working properly by multiplying the speed by 10. Okay. So what it looks like is happening is that the velocity gets applied to the object. It's going faster than it should, because I guess the move speed being added is so great that in a single frame, it can force it to move faster than the run speed. So we're going to need to work around with that a little bit. But let's increase the max run speed to something ridiculous as well, and wow, we can see that the character just flies off the screen. Okay, so if you want to get around this problem where you increase the move speed to a ridiculously high number so that it can move faster than the max run speed within a single frame, then one way you can actually work around that is to change the force mode when you're adding force to the rigid body. So you can do force mode impulse, and then that will be limited by this velocity cap, even if that force would make it go so fast that in a single frame it can exceed the max run speed. So let's go ahead and demonstrate that in play mode. So if I increase the move speed here to 100,000, we can see that despite having an insane force of like negative 2,000, it's still capped by the max run speed. And if I add the max run speed in here, you can see that it's still being limited by that speed. However, we can also see that the forces that need to be added for an impulse-based force are a lot lower here. You can see that I've set the move speed to 10 and the max run speed to 10 here as well. And that gives us kind of the movement where it goes left and right, still affected by drag, and it doesn't hit the max velocity immediately. But the numbers need to be way lower than with a force-based force mode. which is the default of force mode 2D.force. But you know, honestly, in most cases, you probably don't need to worry about this, because this only happens if you have such a ridiculously high move speed that it would exceed the max run speed. Because you only need to worry about this if your move speed is so ridiculously high that in one frame it would exceed the max run speed. So you don't necessarily have to worry about this so much. I suppose for now I'll just leave it on force mode impulse, since it does sort of seem to solve that problem, and just for demonstration, and just to show off one overload of the function where you actually change the force mode 2D. Okay, so now that moving left and right is generally working for the most part, let's go ahead and add jumping. So to perform jumping, we're going to need to get the vertical axis, which we already did before, and see if basically the player is pressing the up button or the equivalent on their device. And then, depending on if that is pressed up or not, and whether the character is on the ground already or not, we will allow the player to jump. So, okay, so let's comment this move left and right, and then we'll have a space over here for jumping. So a couple ways that pop into my head about how we can do jumping. One way would be to see if the y velocity is 0, because if that's the case, then it's probably standing on top of something. But probably a better way would be to see if there's an actual collision between this game object and a collidable object, and if it's standing on top of that object. So let's create a method here. If standing on object is true, then we will allow it to jump. So we could make this a property or just a method. I'll make it a method here. So public boolean is standing on collidable object. Let me rename that in there. So this is going to need to check colliders. And to check for colliders, we're going to need to make sure that it has a collider. So I don't necessarily want to force the player to have a collider, so I'm not going to require it up here. And the reason for that is that sometimes you might have a character that can pass through walls and therefore doesn't collide with anything. You can, of course, require it if you want, but I will have a variable set for the collider. So let's do that here. Collider or player collider, maybe to be a little more specific. And we will check on awake if there is one. So let's get that collider 2D. And so we'll only check to see if it can jump if it has a collider. So if player collider exists, then we'll check that collider. So let's see if the collider is colliding. So we can do that with collider2d.overlap collider. So we can apply a contact filter there, which is basically filtering out some colliders from other ones that we don't want in the results. So for instance, if a collider is a trigger collider isn't meant to actually block game movement. It's only meant to spawn events. So you might want to say filter out colliders that are set as a trigger collider. And it'll return a list of results here. So let's create a contact filter 2D, and we'll call this filter 2D, which is a new contact filter 2D. And I believe this is just a structure. So we can change the values in here, such as trigger. So use trigger, set to filter contact based on trigger collider involvement. And I believe we want to set that to false because we don't want it to contact. We don't want this to return a list that includes trigger colliders. So let's add that in there as the filter 2D, and we're going to return it into a results array. So let's create that array here, and we'll pass it in. But we do need to initialize it, so a new collider 2D array, and I suppose for now we can just initialize it with 10 spaces. That should be enough. And so we get the results, it fills in here. So now we want to loop through those results. So for each collider 2D, collider, and results, we want to check if character is on top of collider, and if so, then return. Okay, so I suppose what we can do here, if it did return that it's overlapping, we can make sure that it's on the same Z value, because if it's further in the background, like a Paper Mario type of thing, then it wouldn't be technically on top of it if that item is way further in the Z background, because in Unity everything is still technically 3D. So we want to check if the Collider.transform.z is equal to the player Collider.transform.z. And if so, then we can say that it is colliding, and therefore return true. Otherwise, if it gets all the way down here and it hasn't returned true yet, then we can return false. Not 100% if this method's foolproof or not, but we can try it out for a while. So let's set some description here. Checks if there are any non-trigger colliders that are below the player. Okay, so I thought about it for a little while, and I don't think that this method is going to work properly. Well, it would work if you're standing directly on top, but the problem is it would also include overlapping collisions from the left, right, and top, and we don't want those collisions to allow the player to jump. So what we can actually do here is a simple cast, where we cast in the -1, basically the downwards y direction, so new vector 2, 0, -1, and we return that into the results array. And we want to use the same contact filter, so filter 2D. And we also want a distance. So this would be the standing contact distance. And we could just set that up top to something like 0.1. Public float standing contact distance is equal to 0.1 f. And honestly, I don't think this is a value which would really need to be changed, but I guess we can leave it there for right now. So in this different method, it's actually returning a list of raycast hit 2Ds. So let's change that here. Of course, we need to instantiate the array as a raycast hit 2D as well. Okay, and the location of the contact filter is also changed here. It needs to go before the list of results. Let's see here, and I think the last variable still remains the float for distance. Let's double check that. Yeah, that should be correct. So let's change that to raycast hit. And now a hit will have a collider, so we can do hit.collider and get the same values there. Okay, so now what this cast is going to do is it's going to return a list of colliders that exist below the player at the max standing contact distance of 0.1. Really, it should be directly on top of it, but for right now, we can let that value be alone. And we also need to check if those colliders have the same Z position to make sure that that object isn't supposed to be in the background in terms of a 3D world. Now I'm going to rename this method a little bit, and we're going to call it is on top of collider, which doesn't necessarily mean that the character should be allowed to jump. So another thing I'm going to check for here, if the character is on top of the collider and the player rigid body dot velocity of y is equal to 0. So the reason for this is that we want to make sure that the player is not jumping already and that the player is on top of the collider. So I think by combining these two requirements, it should give the most consistency. So now let's go ahead and apply a jump force. So well, we have to set the y force here. So y force, and we'll default that to 0, but if it actually makes it here, then we can set that to y input times jump speed times time.deltaTime. And now with this y force, we can pass that into this vector over here. And now we just need a jump speed variable. So public float jump speed. And we'll just default that to 1 here. Or we can make them like, I don't know, 10 and 50. I think a character usually jumps a lot faster than it runs for most 2D platformer games. And let's see if all that updates in the inspector here. Okay, cool. So we have a move speed and a jump speed. So let's go ahead and hit play and see if a jump button works at all. So you can see when I hold the W button down that it does actually jump a little bit, but not nearly enough. We probably need to bump that jump speed up quite a lot. So let's change this to something like 1,000. And when it's in the air and too far from this ground, we get an error, which is basically that there is no collider here. So what we actually want is to make sure that hit.collider is actually set here. So just do hit.collider. And with that, we should be able to have the character jump. So let's give this a shot here. Okay, pressing W. Kind of seems to work, although it doesn't seem particularly consistent. So maybe we need to tame the jump speed down a bunch. Maybe in this case, what we actually want is to remove the time.deltaTime here, because this is supposed to be an instantaneous force. So let's see if that makes more sense. So let's set the jump power to 5, because with removing the time.deltaTime, it should remove a lot of the jump power needed to make it go up. So let's see here. Jump power 500. Press up. Okay, so when we try to jump here, we get a lot of inconsistency in how high he actually jumps. And I think I figured out the reason for this. It's because the Y input isn't always set to 1 when we press down on a control stick or we press W on our keyboard. But we want to make sure that it will always be set to 1, basically. We can do that by checking if the value is above 0, and if so, then we just set the import value here to a solid 1. So let's see here. Jump power, we can set times equal to Y input is greater than 0, and we'll return either 1 or 0. So if Y input is greater than 0, this value is 1, otherwise this is 0, the jump power is 0. So let's try that. I'm gonna hit play here. Okay, so it seems to be consistent, but I guess we have to boost the jump power way up. Okay, still kind of weird. What if we make this really big? Ah, okay. Okay, okay, let's work on this code a little bit. First off, we don't want to go through the process of checking all these colliders unless there's a Y input. So if the Y input is greater than 0, then we'll just say it's trying to jump. And if it's trying to jump, we don't need to do any of that 1, 0 thing. We can just have this be set to the jump power altogether. So let's give that a shot. I'll bump the jump power up here to make sure it can actually jump high enough to be visible. Oh, what happened? Okay, so something crazy happened there. Let's bump that back down. So let's see, jump power of 5. Okay, yeah, that's more reasonable. I guess when I set it to 500, it went to the moon, quite literally. But now this is working quite nicely because the jump is consistent here. So now it's not being determined by how hard I'm pressing on the up button or the up joystick. It's only being determined on whether that's in a positive direction or not. Now you could also set it to be something like when space is pressed, then add it. That might make a lot more sense depending on your game. For right here though, I think this works pretty well. So let me see, what are the right values for move speed? Let's try 50. No, that's still too slow. 500. Oh, okay, it's being capped by the max run speed, right? 10 is clearly way too fast there. Let's see, 5. Still a bit fast. I'll set it to 3. Let's see, maybe we want them to have a little bit more jump power. And the nice thing about putting this all on the inspector while we have the play button running is we can play around with values that won't be permanent, and then we can figure out what values we want and copy those over into the actual project when we stop hitting play. So I think this is actually not too bad here. Maybe I bump the jump speed up a little bit more. So it's now a jump speed of 4. And that seems like a decent 2D platformer controller, being stopped by the physics on the ground, jumps at the right time. So yeah, this is all pretty cool. So let's go ahead and update those values. I think it was 500, 8, and 4. Just to be sure, I'll hit play one more time. So let's see, yep, the jumping, the movement left and right. and can also fall off a cliff and lose the game. Well, the game doesn't technically get lost here. What's really happening is he's falling for all eternity, never to ever, well, let's just say that's another kind of hell. Poor guy. And so, that in a nutshell is how you do basic movement with 2D rigid bodies inside of Unity. So I've been Chris. I hope you guys have learned quite a bit about all of this. If you don't like having the physics-based movement, you can always change your rigid body to kinematic movement. And then that's a little bit different in how you script it, but it's not too bad. But that's going to be it for this part of the tutorials on setting up basic 2D rigid body dynamic movement inside of Unity. So I've been Chris, thanks for watching, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this video I wanted to talk to you guys about an optimal way of checking for collisions with the default Collider components inside of Unity. So the method we're talking about is Collider.Cast. So this can be either done with Collider 2Ds if you're making a 2D game, or obviously Collider, which would be for any 3D variant of the colliders. And you just call it the .cast method, which takes a direction, a contact filter. So the filter allows you to take some of the other colliders that it may collide into and to remove the ones you don't like based on things such as a layer mask, a reference to ArrayCast hit 2D array, which just stores the results of this method into that, and then you can check through all the hits. And finally, the distance to check for. Now, I believe there are other overrides for this, like not including distance, but this kind of makes the most sense for me because usually if you're going to check for a collision, you want to check a certain distance. So what's really great about using Collider2D.move collider or Collider.move collider is that there are different components for the colliders that may exist inside of your game. So obviously you can see here on this player game object right now I have a capsule collider 2D, but there might also be, let's say, a box collider 2D, and you're really not sure which kind of collider you're going to be using. So without knowing that, you can't exactly determine where the collider should be casting from based on its shape and size. And that's why this method is so great, because it'll take any 2D or 3D collider and it'll determine how it should be cast for you. So you just feed it these parameters and it will let you know if there's a collision or not. To point out another reason why this is so much better than, let's say, just doing a simple ray cast in a direction. If you have a collider on your object, let's say you have the center of the object right here, right? And you try to do a ray cast out north of there. So that's fine. You can get a general sense of what objects might be in the direction. But let's say that your object is already halfway across to the left like this, where the middle is somewhere around here, and you check north because you're moving north on a grid. It's not going to detect these tile map colliders over here because it's casting the ray cast from the center or the top over here. But if you cast as a shape, it's going to basically take this shape, put it in that direction, and if inside of the bounds it collides with anything, like you move this half a unit and it checks everywhere inside its bounds for that collision, it's going to let you know that there's this collidable object there, and if you use it properly, basically not allowing it to move if it detects a collision, then you'll get the results you're looking for. So to show this in actual gameplay, since I'm using Collider.Cast instead of RayCast, if I go over here just a little bit where the center is off balance, it's not going to let me keep progressing there, because if we go back into the scene view, we can see if this collider went a little bit of a step further, it would in fact collide, but a raycast wouldn't detect that. A raycast would let us go up north, or in the case of this character down below, it would let us go south and pass through it, which is not what we want. So yeah, that's why I would just recommend using Collider2D.Cast, as long as you're not using the ECS system, which is currently in preview mode. I hope that they'll have something similar to this when it's done. But yeah, as long as you're still working with standard Unity components, then yeah, you can just use Collider2D.Cast, and basically all of the collisions are going to be checked for you because Unity has already done the math for you. So really useful. Hope you guys learned a bit with collisions inside of Unity 2D, and you can easily apply this to 3D as well. Once again, just use Collider.Cast instead of Collider2D.Cast. But aside from that, I've been Chris. Thanks for watching, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this video I'm going to be showing you how we can get smooth movement like this inside of a Unity 2D pixel art based game. You can notice it's very low resolution, and the problem that this method is going to fix basically looks like this, where you get ridiculous jitter as the position tries to move between pixels on the screen, and it looks very, very bad. But by clamping it to pixel units, we're able to get a smooth movement on the screen, regardless of having a very low resolution for the game itself. So let's go ahead and take a look at the code here. So let's take a quick look at this method, which we call on both the move vector and the old location as well. Basically clamping them both so that they're working with the same pixel units in a sense. And in order to do this, we need the vector that we want to clamp, and we also need the pixels per unit. So this is referring to the sprite. So whenever you import 2D sprites inside of Unity, there'll be this part in the inspector where it will say pixels per unit. And normally you set that to the pixels per unit that you are creating your sprite sheet at. So if you're, say, creating a 32 by 32 tile set, then it would be 32 pixels per unit, generally speaking. Anyway, whatever you set that value to should be passed in here as the argument. Now, a decent way of doing this would just be to get that value from the sprite renderer as the game runs. So regardless of what sprite is actually being used, it will always use the value per unit of that sprite, which you set for each individual image as you're importing them into your Unity game. So anyway, this should be consistent with the image value. So then what we do is not all that complicated. We basically have to get it to an integer value, which represents the value in terms of pixels. So the move vector, or whatever vector you're clamping, it can be the location vector. The x and y positions should be multiplied by the pixels per unit. So that's going to mean if you are trying to move 1 unit in game and your pixels per unit is 32, then this is going to make the x value 32, meaning 32 pixels. And by using mathf or math.round to integer, what you can do is you can drop off the trailing data. So if you would to convert it into 32 pixels, but then there was, say, 32.3 pixels, you can't have that extra 0.3 pixel. That's part of what's causing that flickering effect. So you have to round it to the nearest integer, and you should definitely round it to the nearest one, not floor it to the bottom, because if you do that, it may affect the actual movement speed of your character, but rounding to the nearest integer will get you the most consistent move speed results. So you do that for both the x and the y, basically the x value times pixels per unit, round to an int, and then the same with the y. And then we return it back into Unity units. So whatever this value is in pixels, we need to convert it back into units, what you see on the transform, what you're actually adding to the velocity or to the position. So to do that, we just basically divide by pixels per unit. So this is going to take this, let's say this was originally a vector of 1, 1. It gets turned into 32, 32, and then it gets reduced back to 1, 1. But if you had a input vector of, say, 1.01, then that extra 0.01 basically doesn't show up in the final result. So by doing this, all of your moves are going to be pixel perfect. They're going to correspond with the nearest pixel on screen, assuming that you are using consistent pixels per unit across your screen. Now, with a pixel perfect clamp, you should call it on 2 different things while you're adjusting the position. One is going to be the old location, and the second is going to be the move vector itself. You should do these individually and then combine them in the final move. And by doing that, your move and then your old location will both be, in a sense, using those pixel units in order to figure out where it should be on the screen. And you'll get the consistency you're looking for. There won't be any more flicker. So by doing this, Unity won't have any confusion about where it should be drawing your sprite, and it will draw every pixel in the right pixel area. So that's how you get your movement to look like this rather than this. So I hope that helps you if you were trying to get movement to look right inside of a 2D pixel game. I've been Chris, thanks for watching, and I will see you guys in my future video content. Hello everybody, Chris here, and in this video I'm going to be showing you guys how we can take a sprite sheet and create an animated projectile from that sprite sheet. So inside the sprite sheet, which you can access inside of your assets folder, we're going to need to churn it from sprite mode single into multiple. And the reason for this is that being a sheet, it has multiple frames for the animation. So I'm going to change it to multiple here. Now typically in a 2D pixel game, you're going to have some unit standard to go by for all of your art assets, especially if you're working on a grid. So that could be something like 32 or 64 pixels. Now for this particular sprite sheet, which by the way, I'm grabbing off of opengameart.org /content/high-res.fire-ball. It's actually got 512 pixels width by 197 pixels per frame high. So I think what I'm going to do is I'm going to set this to 512 pixels because this is a high-res vector sprite, obviously. Now, once again, if you have just like a normal 32 pixel game, then you probably want that to be 32 pixels or whatever the standard is for your game. Now we go into the sprite editor in order to actually cut up this sprite sheet. So you can see that there's going to be 6 frames for this animation here, and we can slice it up by going to the top left hand menu. So where it says slice, you can do automatic, which I think in this case would work just fine. So you do automatic and you can see that it makes the cuts, but in this case it actually didn't work properly because you can see that the areas that are separate from the main fireball have actually been turned into separate sprites. So for that reason, you may have to do grid by cell size instead. And you can see by the name of this file that it's 512 pixels by 197 pixels. So that's what I'm going to make the grid size. 512 by 197, slice it, and you see now we get 6 pixel perfect individual frames. So let's go ahead and apply that. Now, if you're working on a pixel art game rather than a vector art game, you're probably going to also want to change the filter mode from linear to point and from compression normal quality to none. Because when you're dealing with those low-res pixel files, you don't want it to have any kind of filtering which is going to blur out your image. You want it to be pixel perfect. You want it to be sharp. But in this case, this is a high-res vector image, so probably can leave it alone as it is for now. So now what we can do is just take one of these sprite images, drag it to the scene, and it will create a new game object that we can, say, turn into a projectile and animate. So in this case, I'm going to rename that game object Fireball for the sake of making it more clear what it is. And I'll also drag it into the assets folder as a prefab. Now I guess in this case, because I already have a prefabs folder set up, it'll go in prefabs instead. So this is going to be where the objects you can instantiate, like enemies or projectiles, go. So now what we need to do in order to animate this fireball is to actually attach an animator to it. So it already has a sprite renderer, and that can render a frame of a sprite, but there's 6 frames that it needs to animate between. So I'm going to add a new component animator here. And you can see that it takes a runtime animator controller. So to create that, we can go somewhere inside of our project folder and do right-click, create animator controller. So this is basically so what an animator controller does is it allows the different animations that would be attached to a game object to transition from one to another. Now you can have one animation in this case, but you can also set up events, but you can also set up triggers that will happen, such as when it's not moving, switch to an idle state inside of the animator controller, and then you go from one animation state to another. But that's a little bit more complicated than this video needs to get into. So I'm just going to call this Fireball AC, AC standing for animator controller, and we need to make sure that that is attached in the Fireball. So Fireball game object is using Fireball animator controller. Now we can double click this, and we need to add an actual animation in. So we can't create the animation inside the animator tab. We can create it in the project folder though. So in the same folder I have the animator controller. I'm also going to right click, create, and do animation. And I'm just going to call this Fireball loop because it's going to loop endlessly until it collides with a player or something like that. So we're going to want to check loop here because the animation can loop over and over again, going frames 1 to 6 and back to 1. And now with the fireball selected in the hierarchy that has the animator attached, we're just going to want to drag in this animation here. So the entry point is going to be fireball loop, and it has nowhere else to go from there. So basically that means it's going to start at fireball loop and it's going to keep going until the game object no longer exists or the game is paused. So now to actually set that animation. With the fireball selected as the game object, we hit Control-6, which will open up the animation window. And you can see that the animations that we've attached to the animator controller are going to show up here. So fireball loop. And now all we really need to do is to take these 6 frames and put them inside of the animation. So I'm just going to left click on one, hold shift, left click at the one at the end to grab 6 frames all at once. And I'm going to pop that in there. So you can see that there are now 6 frames created with that animation. Now, as it stands, 60 samples, I believe, is 60 frames per second. So if I hit play here on the animation window, it goes way too fast. I'm thinking something more like 6 samples or 6 frames per second makes infinitely more sense, and we can hit play to test that out. Actually looks a lot better now. And at this point, I believe we're done. We've set up the animation. We can just go into the game view. Let's disable this canvas and the other stuff here. And we'll also increase the size of that fireball so that it actually shows up better on screen. So I'm increasing the scale here. And I'm going to hit play. So with play, it should actually run through that animation loop endlessly. So we now have an animated fireball. So in the next video, we're going to work on making this into an actual projectile, which will interact with game objects such as your player. Maybe collide to it, explode, do some damage, that sort of thing. So I've been Chris, thanks for watching this video on setting up a animated projectile, and I will see you guys in my future video content. Hello everybody, Chris here, and in this video I'm going to be showing you how we can take this simple game object with a sprite renderer and an animator, basically a fireball, and turn it into an actual moving projectile that can collide with a player game object. So the first thing we're going to do is add component, and we're going to create a new script. I'll just call this projectile script, keep it nice and generic for right now. And we will open this up in Visual Studio for editing. Okay, so inside of this projectile script, we're going to need to set up a few variables. One is going to be a move speed for the projectile, because we want the projectile to move, and we want to be able to set how fast it's going to move. So I'm going to call this public float move speed, and we could default this to something arbitrary like 3f. We're also going to want a public int, or you could technically make it a float, damage, and I'm gonna default that to 5 points of damage. This means that later on, when an object that can take damage collides with the projectile, that character or object is going to take 5 points of damage, which might mean health in your game. It usually means that. So now how we move the projectile is going to depend a little bit on whether or not you have a rigid body 2D. In this case, we're going to keep it simple, and we're just going to update the transform of the projectiles game object. That would be when you don't really need physics to interact in your game. Most really typical 2D games don't need that. If you do need rigid body because you want physics to interact and to be able to apply forces to game objects, and when like a projectile bumps into something and actually moves that game object, then you want rigid body instead. But for simplicity's sake, if you want to update the transform here, we can take the move speed and apply it to the position of the transform. So in the update method, which is called once per frame, what I'm going to do is I'm going to update that transform position. So because MonoBehaviour has a direct reference to the transform, we can just reference that without anything else. So transform.position. And I'm going to set this equal to a new vector 3. A vector 3 just means it has x, y, and z coordinates. So I'm going to break that into 3 parts here. So for transform x, I want that to be transform.position.x, the current position. And then I'm going to add in the move speed. But we don't know exactly how many frames are running per second. So how we can work with that is to do times time.deltaTime. And what deltaTime is the time since the last frame. That's usually going to be something like a 20th of a second, represented by a float. So we take these values and we're going to add that to the position of x. So what this means is that the projectile would always be moving to the right because move speed is positive. I guess if you actually made move speed negative, it would make it move to the left. And we're just going to keep it that simple for right here. So everything else, the y and the z coordinates, those are just going to be left as is. And the reason we need to create a new vector for this is that you can't directly change the x, y, z values, as I recall. So we do need to do this. So transform x adds the move speed times deltaTime. Transform position y is left alone, position z is left alone, and now while this game object is active, it's going to start moving to the right, which is great. Now we can actually go ahead and test that in Unity real quick. So we have the projectile script attached. I'm going to hit play and see how this works. So you can see the projectile is moving to the right. Now it's not facing the right direction, which is an issue. But the important thing for right now is that it's moving in the right direction. So now what we need to do is actually set up collision, because it needs to collide with the player object, and it should do that as a trigger in this case. We don't want it to directly block the player, we want it to collide with the player, delete itself, and deal damage to the player. So we can do that with on trigger enter 2D. So in Visual Studio, just start typing on trigger and it will be able to find that method for you, which all MonoBehaviours are able to implement. So this method passes in a Collider.2D as a parameter, and the Collider.2D will be the thing that it collides with, the thing that this projectile is colliding with. So we can check to see if that collider is of a certain type, which in this case we want it to check a character type that we haven't created yet. So before we start writing this method, I'm going to want to create another script. And just to make things a little bit quicker, I'm going to duplicate this enemy game object, and we're going to turn that into a player. So I'm going to remove this spawner script, and I'm going to add a new character script that we're going to write right now. So you can see that the character has a box collider 2D and a Rigidbody 2D. So you can see that this character has a box collider 2D already added to it. The Rigidbody 2D, we're going to remove that. We don't need it for right now. And I'm going to rename this game object to, let's make it player actually. And we can enable it if we want. For the future, because we want the fireball to collide with it, I'll move it over to the right, and that should make this fireball run into it in the future. Now we need to actually edit this character script. In this character script, I'm going to set a few variables. So I'll do public, let's call it an int health, and we'll default that to 50 points of health. And we'll create a method called take damage. So void take damage is going to take an int of the damage taken, and we're going to update health to be minus equal to that damage. So basically we subtract the damage from the player's health. That's as simple as you could get. And the reason we need this is the projectile script, when it collides, it's going to need to make sure that the collider is something that can actually take damage before it runs the collider script. Now, you could also make this an interface, and then you could implement this interface in any MonoBehaviour class that you wanted to be able to take damage. You can also use this as a base class and then maybe make a parent class like player that extends character, and then it already has this stuff included. But we'll just keep it really simple for right now. So health and take damage. I think that's all it's going to need for right now. So now what we can do back on the projectile script for on trigger enter 2D is we can check if the Collider 2D contains a character script, basically if the game object has a character script attached to it. So I'm going to call this character is equal to collision game object dot get component. So we're checking to see if it has the character script attached to it, and if it finds one, it's going to set that to this character variable, and that will mean that the character variable is not null. So if character is not equal to null, then that character can take damage. I forgot to set it to be a public method. If you want it to be able to be called from other scripts, it should be set to public. So character.takeDamage, and we're going to set the damage taken equal to the damage that the projectile does up here. And and the final thing we want to do is actually remove the projectile, because it's not a every frame thing, it's a collide once and destroy the projectile thing. So let's do destroy game object here. And that's of course referring to the game object of whatever this script is attached to. So with that, if I'm not wrong, okay, the fireball does need to have a box collider, but if I'm not wrong, that should be all the scripting we need here. So we do of course need to add a box collider 2D to the fireball. So I'm going to add a box collider. The collider shape is just to determine where the bounds of where it can collide at are, and you can only see that of course in the scene editor. It might make more sense to do something like a capsule shape, because it is a bit round after all. But I'm gonna take this collider bounds and I'm gonna make it a little bit more reasonable here. Make it so that only the main parts will actually deal damage, and remove the projectile. So let's save that there, and it should be isTrigger. And the reason we make it isTrigger in box collider 2D is so that it can't interact in terms of physics, but something passing through it can trigger the onTriggerEnterTwoD method. So basically, it only serves to have something happen when something enters it, which in this case, if it's a character, it's going to take damage and then destroy the projectile. So let's go ahead and hit play here and see if it works. And it did not collide for some reason. Let's find out why that is. Okay, after messing around with it for a little bit, what we needed was a Rigidbody 2D set to kinematic mode for the player. So to cover rigid bodies really quick, dynamic rigid bodies allow physics to interact with it. You can have things like gravity, and objects can push each other, and kinematic objects have to be moved specifically with the script. So that would be things like doing transform.translate on a game object in order to move, rather than applying a force to the rigid body 2D. But in any case, a kinematic rigid body, so you add a rigid body 2D and you make the body type kinematic, will allow the collision to occur between this game object and the player. So once again, I'm going to correct the rigid body a little bit. One more thing I want to point out here is while I was looking through some of the documentation, transform.translate is actually a better way to apply a change in the position of a transform. So rather than creating a new vector with the updated values, you can just change the values by translating or moving it in the directions of x, y, z. So in this case, I'm adding in the move speed times delta time on every frame, and nothing for y and nothing for z. So it does the exact same thing as this up here, but this is probably a more proper way to do it. So let's go ahead and play this one more time, and I'm gonna click on the player, if I can, to show that the player does take damage here. So where's the player script? Okay, character script. You can see it, the base health is set to 50, but because that projectile was able to interact with it, took 5 damage, and the projectile was destroyed. So one more thing I want to show regarding projectiles would be how to add a sound to them. Now on my Gumroad, there's a audio script that allows you to create audio sources on demand. But if you want to do it the classic Unity way, then you can do so by adding in a audio source component directly onto the projectile. So with this audio source, you're going to want to play an audio clip, of course. You can click on this little circle over here to select sound effect from your game assets library. So I'm going to select this fireball sound effect. You want to turn off play on a wake off, and we actually want the sound effect to trigger when the fireball collides with the player. So in order to make this sound effect play when they collide, what we can do is add in a reference to the audio source here. So I'm going to call this audio source, and we want to get a reference to that on awake. So audio source equals get component audio source. So that should mean that now for this projectile scripts, you should have an audio source attached to it. Caps matter, careful there. And now when they collide, we're going to want to take the audio source and we're going to want it to play whatever sound clip is inside of it. Now there's going to be one more issue here, which is that if you destroy the game object immediately, what's going to happen is that the audio source will be destroyed along with it, so you won't hear the sound effect. And that's one thing that the Gumroad audio script I've been talking about, which I have other tutorials on, helps with, because when you use that you can target any transform to add the audio source onto rather than having the audio source have to be on this game object, which is about to be destroyed. So actually, rather than setting the game object inactive, because that will stop running the scripts on the game object, a better way we can do it would be to take the Collider.2D attached to it and the Sprite renderer. And now that I think about it a little bit more, rather than setting the game object to false, because I think that'll stop the scripts, what we should really have happen is that the renderer attached to it and the collider attached to it will just make those inactive, rather than the entire game object inactive. So what we can do here is do get component on the sprite renderer. So we can take the sprite renderer and set the color, the alpha to that. So just like the position, we can't set the individual properties of the color individually. So I'm going to do a new color and we'll make it 1111, which is perfect white but with full alpha. Oh wait, sorry, we want no alpha to make it completely invisible. And then we need to get component on the Collider.2D. And we want to make that inactive. So enabled equals false. This is going to mean that the sprite will be invisible and the game collider can't collide anymore. And then before we do the final destroy on the game object, we can take the audio source's clip length and wait that many seconds. And finally, in order to start triggering the final destruction in the update method, we can say collided equals true, and we'll need to create that boolean up here. So collided boolean, that should default to false. So this is going to be set to true after it collides. So if it's collided, okay, so now what we want to check in collided is how much duration has occurred with the audio clip being played. So one way we can do that is audio source dot time, which is going to give you the playback position. So if that is equal or greater than the clip length, then that's going to mean that it's done. So if audio source.time is greater than or equal to clip length, then we can destroy the game object. Okay, so with this implementation, it should in theory work, and the update method will keep being able to be called until the audio source is finished playing. But I'm going to do one more thing. If it hasn't collided yet, I'm going to update the transform. This is just kind of more for good practice. You won't be able to see it and it won't be able to collide with anything, but we really don't need the projectile to keep moving invisibly while it has collided, because we're only keeping it in the scene so that it can play that sound source. Okay, so let's go ahead and test this out in the actual game. Okay, so as you could see, the fireball collided, it turned invisible, it wasn't able to collide anymore. So the player's health is still 45, and it remained in the scene until the audio clip was done playing, and then it destroyed itself. So that was exactly what we were looking for. Okay, so one more thing I want to change here is that the projectile should be facing to the right because we are applying a movement to the right. So I'm actually going to flip the X on the sprite renderer so it's always facing to the right. And we're going to change the box collider and make this face over here as well. Now with this, if we were to say rotate it later on, let's say 180 degrees, and we were moving it in the same direction, it would just move to the left properly. So really the only thing that needs to happen is that the flip X should be checked there for this particular sprite. Just make sure that your sprite is moving in the direction that it's actually facing. So in this case, we can probably just go ahead and hit play. So I'm gonna hit play, we'll test it out, and then we'll kind of duplicate things a bit. Okay, great. So now with this one item, we can duplicate it a lot. And go ahead and hit play one more time. Okay, so that's pretty much all there is to creating a basic projectile inside of Unity. So I've been Chris, thanks for watching, and I'll see you guys in my future video content. So let's see, whoops, I didn't quite get there. Okay, but yeah, you see, and we knock it back, and kind of lands over there. Okay, so the first thing we're going to want to do here to add physics to our game and to allow this object here, the cart, to be able to be affected by things like gravity or other forces acting upon them is to add a Rigidbody 2D component to our projectile. So in the inspector over here, I'm going to go ahead and add in a Rigidbody 2D, and it'll be set to dynamic mode. Dynamic mode means that regular forces will be able to act on it. So if we, in another script, do something like add force of 1,000 to this, it'll be able to apply that force and be affected by things like linear drag, angular drag, and as long as gravity scale is not set to 0, gravity will also still be an impactful force on that object as well. So a dynamic rigid body makes it pretty easy for our game to get physics that are kind of similar to something like you'd see in Angry Birds. So it's generally the way to go for complex 2D physics. Now, in order to make this object launch, we're going to need a script to do that. It could either be on the object itself, but generally we would have other objects apply the force to the cart. But if you were to think about it logically, usually an inanimate object doesn't make itself move. It's an outside force that has to act on it. So just to simplify things, we could go over here and create a new empty game object and make sure it's not nested. And we could just call this God Powers, where anything we want to be able to do seemingly from nowhere as the god of this world, we could do that through this God Power script. So let's create that here, and I'm gonna create an add, and let's open it up for editing. Okay, so now that we have this God Power script open, we can go ahead and give it some functionality. So what I want this God Power script to be able to do is to apply a force to our target, causing it to move, and the target, of course, is going to be this cart projectile. So the first thing we're going to need to figure out is our target. Now, there would be many ways for selecting a target, but to make this video a little bit simpler, I'm going to, actually, we'll make this a Rigidbody 2D, and I'm going to call this target. So in order for it to be a valid target, it has to have a Rigidbody 2D because we're applying a force to a dynamic rigid body. And then we need a function to actually apply a force. So let's see here. Public void apply force, and we don't necessarily need to pass a parameter of a target because we already have that set in the script, so we can just reference the variable setup here. But what we might want is a float value of the force. So how much force do we want to apply to the target? And we might also want a vector2 of direction. So we'll have a force and a direction to apply that. And now all we need to do is add the force to the target. So let's see here. It needs to be a vector2 of a force. So that'll be the direction times the force. So all we really need here is direction times force here, which returns a new vector 2D at the correct values. And that's actually it, I think. So that's really, really simple there. But we actually need a triggering event for this apply force method to be called. So one easy way to do that on the update method would be to check if an input key is being held down. So if input.getKeyDown. So if this key's down, I want to start getting ready to apply a force, but I don't want to apply it yet. Instead, I'd rather charge up the force for a set amount of time, basically until the input key is released. And then once the key is released, it's going to actually fire projectile or apply the force to the projectile. And we'll make this a private Boolean charging, which defaults to false up here. And so if charging equals true, then we want to get the time charged is going to be plus equals time.deltaTime. So basically the time since the last frame. And this needs two equal signs because it's checking to see if it's true, not assigning it. And also the time charged should default to 0 every time it starts charging. Let's see here, another private float time charged. And another thing we can check for here, if the input key is not down, it might be up. So we can check if the key was released, get key up, decode.space. And let's see here. So if the key is up, then we want to release the charging. And we also want to apply the force. So let's see here. That's going to be time charged times force multiplier, which we haven't created yet. And then the direction, we'll figure that out in a minute here, but I guess we'll just make that another public variable direction for now. And then after we apply the force, we want to make time charged. And then after we apply the force, we can make time charged equal to 0. Probably redundant. I think we only need to apply it either here or here, but it doesn't really hurt anything. I guess I'll only have it there once since it's unnecessary. So let's see if charging equals true, time charged plus equals time. Okay, so now we just need these variables up here. So let's see, force multiplier. That's something we can allow the designer to set in the inspector. So let's create, or actually we can make it a float. So force multiplier and public vector2 direction. So we'll need to set those values in the inspector. But aside from that, as long as we set these three values whenever we have this God Power script created in our scene, it should probably work. So let's go back to the inspector and see what happens here. So we need to set a target. So we can select that for the cart since it has a rigid body. Also renaming the cart would probably be a good idea. Let's call it cart projectile. Let's go back to guard powers. The force multiplier, I honestly don't know how much force we need to apply to that cart to make it move in a reasonable fashion. So I'll just try that at 100. And for the direction, let's start off by having it be 1 in the X, which means it's going to be going over this direction. And let's go ahead and hit play and see if this works at all. Okay, so first off, the cart fell through the floor because I have not actually added in a tile map collider here to this ground. So let's fix that real quick. So on the grid, tile map, we just want a tile map collider 2D, which will stop objects like the cart from falling through. But that will only happen if there's actually a collider on this cart as well. So on the cart, I'm going to add in, let's say, a circle collider. And let's resize it a little bit here. So that shape seems more reasonable. And now let's go ahead and get back to our scene. Okay, I'm gonna hold down space and let go. You can see it rolls along the surface there, not too bad. Not exactly what we're looking for, having a curved projectile, but it definitely is moving. Also, it might be cool to have a little text indicator here about how long it's been held down. So I think we'll actually add in a text UI component. So let's add this over here and we'll add it to the top left of the canvas. Change the color to white. And we'll make the font Penny Bold, which is a free font you can get online. And time held down, or charging time. And that'll of course be default to 0, but really what we're going to need to do is control that with our God Power script. So here I'll add in a text component, charging text, and using Unity UI, using UnityEngine.UI. If this is set, then on update we want to set the text. So if charging text is actually set, then charging text.text is going to be equal to basically this value plus the time charged. But we might want to allow someone in the inspector to change this value. So I'm actually going to replace that with a public variable. So we'll do a string and we'll call charging text intro, I guess. And we'll set that default value to that charging time 0. Also, we should remove those extra characters. So the actual value here is going to be charging text intro plus time charged. And I think with this text, we can go ahead and anchor it in the top right-hand corner and push it away from the side a few pixels. So I'm going to offset it 10 pixels away from the top left corner. And on the God Power script, we can reference that text. Now, we might want a better way of doing this. Obviously, if we're manually referencing every object in our screen, if we remove those objects, then we run into problems. But to keep things really, really simple here for testing purposes, this is okay for now. So I'm going to also rename this text charging text to make it more clear what it actually does. And let's hit play. And let's hold down. Okay, so we can see that the text is changing, but it doesn't actually update there. And the reason for that is our text is just simply too small. So let's stretch it out a bit more. So now we just want to put this cart at an elevated space and add an extra brick underneath here so that when we apply the force, we'll actually be able to see a little bit of a curve because gravity will be applying on this while the forward force is also applying on that, and that's where dynamic rigid bodies come good. And then we'll actually make it so that when we apply a force here, we'll get an actual curve, something like this, that will hopefully reach this caveman guy over here. And then later we'll be able to have him bounce it back to the starting place. So let's go ahead and add in a couple extra tiles here. I'm not going to worry too much about the art consistency at the moment. And then let's get the cart somewhere on top of there. And we'll hit play and test one more time. So the charging time still not really updating that well. But you can see how when we fling that cart off the cliff, there was a bit of a curve there. And that's all due to the gravity. So the problem here with the text is that the float is trying to show every decimal point, which is going way too far for the space we have in the canvas text. So what we can do here is actually cut off some of the decimal points. So how we can solve this problem of the float having too many decimal points is to do a toString method, and then we pass in a string of basically how many decimal points we want it to have. So we could do 0.00, and that's going to be a float with 2 decimal points. So let's see if that's still working over here in play mode. Okay, so we hold down the charge button, and it has 2 decimal points. So that's pretty much exactly what we're looking for. So now we want to actually have this cart launch in a arc so that it will kind of land over here on the caveman. So we want it to go up and then come down. And obviously the easiest way we can force it to come down is to have gravity in our world. So I'm going to change the direction to 1 and 1. So this means it's going to be going in this direction initially. We can actually make it a little bit more high than it will be far by reducing the x. So now this, instead of 1, 1, it's something more like 0.81. And if we had 0, 1, it would be straight up. So let's go ahead and try this out. So I'm gonna charge it up a bit, and let's release at 4 seconds. Okay, pretty close. I think we need about 3.5 seconds in order to hit that player object over there. But in order for it to hit that in order for it to actually contact with this character over here, that character is also going to need its own Rigidbody 2D. We will leave it as dynamic over there, and let's create I'd say a capsule collider. That usually works pretty well for characters that are taller than they are wide, so let's adjust that a bit. And let's see if we can make that hit this character over here. So 3.5 seconds, and what I expect to happen is that they'll apply a force to each other. So this guy got knocked off the cliff, very much Angry Bird style, and the cart bounced backwards, which is pretty cool. So you can see how complex physics interactions are made really simple with Unity's rigid bodies. But now the final thing we want to be able to do is to have this character knock back the cart to its original starting place. And we might also not want this character to move so much. There's a few ways we could do that. We could have this rigid body actually be a kinematic rigid body, where it would not be affected by forces. And then in script, we would have it apply a force back over here. We could leave it as dynamic, and we can massively increase the mass so that it'll become a character where basically it is very hard to move because it would need a large amount of force to move that mass. We could also increase the linear drag so that if there's any force applied to it, it fades out very, very quickly. So those are a few options there. Maybe I'll increase the mass by 10 and the linear drag by 0.1. I mean, it is on a surface here, so there would, I guess, be some drag or tension due to that. But now we're going to want kind of a reflection script to knock this projectile back over towards the starting point. So let's create a script, and I'm going to call it knockback. So create an add, and let's edit it. So the moment where it is in contact with the other object is going to be a onCollider enter 2D. And when that happens, we're going to want to get the Rigidbody 2D of the collision target. So rigid collider's rigid body, I guess. Probably can get a better name for that if you want. And let's do collision dot other rigid body. Oh, okay. I guess it already had a property for picking that up, so that's pretty easy. Actually, if that's the case, then we don't even need to get it because it's already got with this property over here. But we need to pass that into a function. So we're gonna call this function knockback, and let's pass in the collision dot other rigid body here. And now we create that function. Oh, well, this has the same name as the script, so... But we're trying to give it the same name as the class, so that is going to cause us some issues there. So we could either change the class name, or we can change this method we're trying to create. I guess we could call it commit knockback or something. And let's create that function. So it's going to take this other rigid body, and we want it to add a force to it. So the force is going to be a variable we have to set. So let's make it a little bit simple in this one, and we'll just make it well, let's actually make it consistent with the other one. Let's make it a direction and then a float force multiplier. We can make it a little bit more specific, knockback direction. And force multiplier, that's specific enough, I guess. So we want knockback direction times the force multiplier. And that is going to be set in the inspector. So the knockback direction, in this case, it's going to be something like a -1 and then -0.5. And the force multiplier, let's just try it at, oh, I don't know, 1,000.
One other thing I want to add here for fun is going to be that when it does do that knock back, it changes color for a second. So it's like this guy's getting mad and he's knocking back the cart to where it came from. So I want him to turn red. So how we could do that is on awake, we get access to the sprite renderer. So sprite renderer equals get component sprite renderer, and let's create a private variable for that. So sprite renderer, and we could even make a color for it to change to, and we'll call this the enrage color. And we could say enrage duration as well, and we'll default that to 0.1 f, which is going to be 0.1 seconds. But we'll also have to see how long has it been enraged. So float time enraged equals 0, and I will have a public void enrage method, which will change the color. This enrage method will take the sprite renderer if it exists, and the color will be set to the enrage color. But we're also going to want to keep track of what the original color was. So let's do that here. So original color is equal to sprite renderer dot color, and let's set a variable enraging is equal to true. So the boolean enraging equals false, and then private color original color. Well, we don't set that yet. We set that here. Okay, so that'll start enraging, and then we just need a function to stop the enrage. So stop enrage. Or actually, I have an even cooler idea for you guys here. So let's do this with a coroutine. So a coroutine is basically when some code runs asynchronously on a separate thread, and when it reaches a certain point in the code, it'll have a statement that'll look like yield return, which means until this requirement has been met, go do everything else inside of the Unity engine, everything that's happening inside of the game, and then cycle through everything and come back to this script and see if the condition has been met. I think Unity actually doesn't really have true multi-threading. It's more like you just delay the rest of this script from running, and then you go do everything else and you come back to it, rather than it truly running on a separate thread. But I'm not 100% on that. But anyway, I can show you how it works at a base level. So we need to make this function an IEnumerator, because it's going to be returning a coroutine. And we won't need this boolean for enraging equals false, and we won't need this one for time enraged as well. So it does save us having some extra variables there. So how we trigger this method is that when the knockback happens, we want to start a coroutine, and this is going to be the enrage method, and we call it just like that. So start coroutine with the method we want to run inside of that coroutine. Now this isn't a true coroutine yet, because there is no returning of a value. It has to either return null or yield return when we want it to pause and do other stuff. And where we want that to happen is going to be right here. So I'm going to do a yield return new wait for seconds, and this is where we're going to take that enrage duration. So enrage duration, which in this case is 0.1 seconds up here by default. So it's going to essentially wait for 0.1 seconds, and then it's going to come back into this script, and it's going to do something, which is going to be to return the original color. So sprite renderer.color is going to be our original color, and that's it. So this whole coroutine is going to be, if there's a sprite routine, a sprite renderer, it gets the original color, it assigns the new color, and then it waits for a specific amount of seconds, 0.1 seconds in this case, and it returns the original color to that sprite renderer. So really simple, but a cool way that we only need one method here. We don't need to create a start and stop. We can just have it all be inside of one method here. So yeah, these can be really useful for a lot of things when you get the hang of them. So let's see here.
I think we just need to test it and see what happens when it bounces in there. Oh, we do need to set an enrage color, so I made that publicly accessible so our inspector guy can go ahead and choose this enrage color for the red. Let's just make it a really deep red over here. Don't know exactly how that'll look, but it should be okay. And of course the alpha, we want that set to 255 so that it'll actually still be a visible character. So let's try to make this. Ooh, what happened there? Okay, I'm not certain, but I think that might have been due to the capsule collider shape there. I'm going to try freezing the rotation here so the character can only move left and right. It can't actually go rolling around like that. That doesn't make too much sense. Maybe it was the angular drag. I'm not 100% certain. But let's just play around with it a little bit and figure it out. Okay, so it looks like there's a force being applied to it. Let's actually take off the freeze rotation and just let this character fall down and then see what happens. Maybe it was because it was stuck. Okay, you know what? It's the knockback script itself. So the commit knockback. So in the knockback script, I think other Rigidbody is actually referring to this Rigidbody, not the one it's in contact with. And secondly, we don't want it to apply to ground colliders. So I guess we'll need to filter it out a little bit. So first off, let's do the Collider.Rigidbody. So let's get the collision collider attached Rigidbody and see what happens here. So right now, I believe this would be applying the force to the ground, but the ground obviously can't move because it's a tile. Object reference not set to... Yeah, okay, that makes sense. So let's check if there's even a Rigidbody on the collision collider. So Rigidbody 2D collider body is equal to collision.collider.attached body. So if collider body, then we will commit the knockback. Otherwise, we just kind of ignore it. So let's get that Rigidbody 2D class there. So now we're basically just filtering out that this knockback will only happen on anything that has a Rigidbody 2D, and I guess that's fine. You could go another step and make it so that like you only allow commit knockback to occur if they have like a specific tag, like if they're tagged with projectile or if they have a specific script on them. Basically, however you want to filter it out, you could do that here. But let's see if this is good enough for our purposes here. So I'm gonna save that script again and we'll go ahead and hit play. Okay, so nothing too weird's happening. Let's try getting the cart to actually hit that player. So 3.3, ooh, that was a nice knockback, but not quite in the direction we wanted, and he still went flying off the cliff. So maybe this guy needs a little more mass and linear drag. And let's also change that direction. So let's make it -1 and then -0.5. So let's charge it up here. And he hits it. Okay, so this knockback direction, that's actually -y. So that's why he's punching it down to the ground. We want it to be up and to the left. So right now it's something like this, which is kind of what we're looking for. Let's try this one more time. Okay, so not bad, kind of close to what we were looking for. Maybe a little bit too much Y and a little bit too much force. So we'll try it again here. And yeah, that's pretty close to what we were looking for. Now, if you don't want this guy to move at all, you could just freeze all of the constraints. Now, if you don't want this guy to move at all, you could just change the body type to a static rigid body, which will still be able to interact with this cart over here, but this itself will not move. So let's try demonstrating that. So this time when we charge up and land on him, it should only move the cart. So you can see the enrage happens, but this does not move at all. So kind of up to you on how you like it. I'll leave it as dynamic because I think that looks a little more funny. Okay, now one more thing. Let's say that with these forces, you wanted to make sure that this cart will go back in the exact direction it came from. and you want to completely discount the forces that are acting on this cart when it gets here. So basically, you want to control exactly what force is going to be coming over here to this location. Well, we could do that pretty easily here. So I'm going to add in an optional piece of code you can run here, which is going to be to eliminate force. We're going to do that on the collider body. And actually, let's make that a public variable. Eliminate starting force, and that'll be a boolean. We'll set to true. So if we have that set, then we will actually run this method. Otherwise, we'll discount it. So you can choose whether or not you want that to be there. And let's make this function here. So eliminate force that takes a rigid body 2D. Actually, you know what? Making an entirely separate function for this is probably overkill. We could just go on the collider body 2D here. And I think on this collider body, what we want to do is set the velocity to, well, basically vector 2.0. So we want to take all of the force and eliminate it before we actually add in this knockback force. So that guarantees that the force acting on the object after this will be exactly whatever the knockback force is, and that there'll be no other outside forces. Now, of course, gravity will continue to affect it after it exits this function and a couple frames pass by. But at this point, we will know what to expect. I believe anyway. Let's see if that actually works. So I'm going to launch it at this guy here, and let's see if... Okay, so that was one version. Okay, so we just have to test this a few times and see if at all times the exact force goes back consistently. And so far it seems to be doing its job pretty well. And then we just kind of need to fine tweak the numbers. So let's see. Whoops, I didn't quite get there. Okay, but yeah, you see it kind of goes back in the same path because it has the same force applied to it. So now what we could do here is just lower the force down a bit, like to 400 or something. And we knock it back and kind of lands over there. So as far as using dynamic rigid bodies and applying forces go, that's how you can launch a projectile towards an area and then have something knock it back. Now, you might say make this guy into a baseball player, have him swing a baseball bat with an animation, and then only if that baseball bat is actually swinging will allow the knockback function to occur. But this should give you a really good idea of how you can get these kind of interactions going. Now, if you do need your projectiles to follow an exact path, then what I would recommend for you is to, instead of using dynamic rigid bodies, you use kinematic rigid bodies. And then you could define paths or target positions for an object to move to over time. But so kinematic rigid bodies don't use forces, but you would instead modify the position of the object directly, and you would do it on the rigid body, like rigid body position, set it to a new position. Hello everybody, Chris here, and in this video I want to show you guys how we can make a kinematic rigid body follow a curve or a precise path between one point and another point. So we can have easing for this curve, we can make it wobble if we want. Basically whatever kind of path we want our object to follow, we can do that through scripts. So this isn't strictly an animation, but if we take a look at the code that I went ahead and wrote, we can see that it uses these properties called animation curves. So animation curves allow us to set values against time. So basically, for any time during the course of this script, it's going to have a certain value. So this curve is for the X value, and you can see it's got some curves here. You can set default curves by changing this kind of thing around. I'll hit Control-Z to undo that. And you can also add in extra keyframe points. So if you want it to have a more complicated animation, just double click on the curve somewhere and add in your extra keyframe. And then for the Y curve, we have this where as it occurs between 0 seconds and 2 seconds, it's going to go up and then it's going to come down. So this allows us to precisely control something like a jump where it goes up and comes down. For one of those values, you could of course add in a z-curve if you wanted to make this 3D as well. And we take these values at the given times and we apply that to the starting position of the object here. So basically whatever the starting position is, we add the value that is at whatever time, 0.1 seconds, 0.5 seconds, so on and so forth. And we add that to the position to get our new position, creating the curve that looks something like this. But you can, of course, expand out the values. If you want it to be a longer effect, then you just move it over here. If you want it to be more dramatic and powerful, then you increase the X or Y values. So to play it one more time before we delve into the code a little bit here, you can see the path it's following. It moves over on the X, but with the Y, it goes up and then it comes down, exactly following our curves over there. So if we take a look at our script here, we of course have those animation curves. You need one for each value because it's a value against time graph. So one graph per X, Y coordinate. And we're applying those values to the rigid body. If you're using kinematic rigid bodies, it's recommended that you change the position on the rigid body rather than the transform itself. That will help you a lot when it comes time for things like colliding with other objects. You'll get none of that unwanted choppy effect in things like pixel art games where when one object tries to move into another, it kind of kicks it back out as it bumps into the wall. The rigid body 2D will prevent all of that. And then we have curve position here, which I think is actually unneeded. That might have been something I had in the original script, but didn't actually need in the end. Time elapsed here, obviously, for determining what point in the curves it is currently, whether it's started or not. And then we, of course, need to get reference to that rigid body. So on awake, we get the component rigid body. So it should be attached there. And we could even add up here a attribute, require component type of rigid body 2D. That would be a good idea because the script does, in fact, require that. So then the work actually comes down here in fixed update. We have this starting function. So basically, if it's not started yet, we start it, which sets the time elapsed to 0, and we get our starting position. On every other frame, what we do here is we add the time.deltaTime, the time since the last frame, and we set the time elapsed to the positions in the curve. So we get the value from the curve, we evaluate it based on the time that it has elapsed. So if 0.5 seconds has elapsed, we get the X value and the Y value at 0.5 seconds. So that will give us basically how much value the starting position should have changed over time. So our new value becomes the starting position plus whatever the value is at the evaluated time for both the X and Y positions. Now, you can get a lot more complicated in terms of curves, looking at the keyframes, but this is definitely the easiest way to get the value out. So I recommend you use the animation curve.evaluate method, and it's really, really simple here. So we set that as a new vector 2 for the new position that our rigid body has. So body.move position to this new position, and then that's it. So our new position is going to be completely controlled based on this follow curve. Now, obviously, I'm having this occur on the object as soon as the game loads. You could have this be something of an event where it has to come into contact with something like an onTrigger enter 2D. Then you start this method and run it on the object. So that would be a decent place to look at after this. But this is the result you get with what we have so far. So really easily being able to create curve-based movement on an object that is a kinematic rigid body inside of Unity. So hopefully this helps you guys out quite a bit if you're trying to make curved movement without relying on a dynamic rigid body, without using the Unity physics inside of your game, but rather using kinematic movement. So I've been Chris, thanks for watching, and I will see you guys in my future Unity content.
Hello everybody, Chris here, and in this video I'm going to be showing you guys how to create a start menu from scratch. So let's just go ahead and get into it. Inside of your scene, if you don't already have a canvas UI element, you're going to need one, and it should be enabled while you work on it. So if you don't already know, the canvas is for displaying graphical user interface items.
basically anything that doesn't interact directly with the game, but is rather more of a display showing text on screen, images on screen, laying out anything to the user like an options menu. That almost always goes on the canvas. And then GameObjects would exist outside of the canvas. And you can see that they work on different scales, because if we look at the canvas and all items under it, it'll have a rect transform instead of a regular transform. And this is measured in pixels. So you can see this is set to 640 pixels by 360 pixels, which is the size that the game is operating at right now, 640 by 360. Now yours might be way higher than that because you're not making a pixel game, but just know whenever you're talking about the rect transform, you're talking about pixels. And then everything else in your scene, like a character, is just going to have a regular transform, which is dealing with Unity units, which is measured more on this grid you see in the background, 1 square being 1 unit. So because we're trying to build a menu, we're going to be building under the canvas element. So what we can do is right click on that, go down to UI, which is going to contain everything that can be attached to a canvas out of the box. And we can start by adding a panel element to the canvas. So a panel serves as both a container for child game objects. So if you wanted to add something to the panel, you would right click on the panel and add it there, like text or image. But you can also see it has an image script attached to it. And by default, it stretches the entire canvas. So it's basically a background image of a color. So if you ever want to change this to a more custom image, something that actually has art on it, you can click on that little icon there to select an image from your project. And you can do something like change it to a fireball with basically transparent areas. Now that's probably not what you want for the background of a panel, but just know that you can do that there. Probably a little more relevant for prototyping is you can click on the color selector here and just change the background color to whatever you want. You can also increase the alpha. You'll notice that the panels are set with a default alpha of 100, which is about 40% opacity, which means that it's 60% see-through. And if there were things behind it, let's say parent game objects, you would be able to see those. So to kind of demonstrate how that works, I'll just add a secondary panel here. And you can make the panels, by the way, not be a fully stretched rect transform, but something more like a custom shape size. So if I change it to just center, but with specific sizes here, I can do something like 200, 100, and now we have a panel with a specific set size here. And you can see that because this panel has a default opacity of about 40%, we can see some of the color of the one behind it coming through. And that would be especially evident if we increase the alpha on the parent panel. So one thing we could use a secondary panel for would be something like a header bar. So if I click on the anchor presets icon over here and we change it to be top center, it'll make a little bit more sense if we want to make this a top bar. And we can also click on stretch horizontally over here on the right. And if we hold down Alt to set position and click on this stretch icon over here, we can stretch the horizontal dimensions to the size of its parents. So if we were to resize the parent panel now, like let's say we stretch this in, you can see that the child panel is now going to reflect whatever its parent size is. So setting certain elements to stretch in anchor presets will be helpful when you're trying to resize your UI or your game menu to different sizes. Now, in terms of height, if we wanted that to be a set size, we can decrease that size to something like 50. Of course, we're still talking about pixels here, maybe 75. And now we can have this as one game object to add children to, and this is another game object we can obviously add more children to. So a lot of game menus are obviously going to have a close button. So let's right click on the parent. So because this orange is pretty ugly, I'm going to change it to something a little bit more eye-pleasing right now. Well, actually just leave it kind of a gray, I guess, for now. And for the top bar, we'll want to add something like a title for our game. So we can right click on the top bar, go down to UI and text, and we can give it a game title. So I'll just call this tutorial game and be very unoriginal there. You can also align the text with these alignment tools here. So I'm going to align it both horizontally and vertically in the center. And I'm going to actually stretch this element to the bounds of its parent. So that's going to mean that the space of the top bar is also the space of the text for now. So one option for controlling the text size here is to hit best fit, which will try to adjust the text size automatically depending on the display resolution of your game, which obviously can change. Your player might have it set at 1920 by 1080 pixels, or they might be on an older computer and they're running it at like 1280 by 720 pixels. So best fit is one tool you can use for that, to have it automatically resize. As an alternative, you can just hard code a font size rather than having it be within a range. Up to you what you want there. And you can also increase the max size and the min size on that best fit. So since we're talking about a main menu here, we're probably going to want a bunch of buttons, like one for starting a new game, one for saving, and one for exiting the game. So let's go ahead and create those here. But when I think of a menu, I also think of a layout, which could be either a grid layout or a vertical layout. So vertical would be top to bottom, a list of buttons that will be displayed at even intervals. And grid layout would allow you to have multiple columns, so it could be like first button, second button, third button, fourth button. Up to you what you want to do with that exactly, but we can create that by going to... But if you want to create a layout, to organize your buttons, you can right click on your panel and you can do create new empty, and then in the inspector for that game object we're just going to add a component, and you can type in layout and see what's available to you. So there's grid layout, horizontal layout, and vertical layout. I didn't mention horizontal layout. That's the same as vertical layout, except it's going left to right rather than top to bottom, and grid allows you to have basically little grid squares. So let's do vertical layout group for now, and we'll probably come back into these properties a little later, but we'll leave it there for now so we can see how it looks without changing anything. And I'm just going to call this menu buttons group. And that's all we need to do for that game object, but we'll need to add some buttons below for the actual game functionality. So I'm going to right click, add a button, right click, add a button, and right click, add a button. Oh, and for the menu buttons group, we're also going to want to change its size so it has more space to actually draw these buttons on. So what I'm going to do is I'm going to drag these corners to align up with the panel above it, and drag it to the bottom of the main panel as well. So now we can see that these buttons are being spaced out evenly with the space that's available to them, but they're all also hovering on the left and starting from the top with no padding, so that looks pretty terrible. So I'm going to start by changing the child alignment in the menu buttons group, and we'll make it, let's say, middle center. Now, if you don't like this automatic spacing, you can also change the child force expand to remove that height component, and now it'll put them close together. So if you still want some space between these elements, you just change the spacing, add a bit of that, so you can make it 10. And if you would rather these buttons be at the top of your menu buttons group, then you can change it from middle center to upper center. And if you don't like how it's basically right aligned with the top, you can also add in some padding here. And you could add it to all the sides just to make sure that no matter what, the buttons are never going to get too close to the edge, which would look pretty bad. But now we have 3 buttons that we can use for things like starting a new game, loading a game, or exiting the game. So let's do those buttons individually. So I'm going to call this start new game, load new game, and you can also give some kind of indication that it's a button. So you could say like B start new game or button start new game, whatever makes the most sense to you. So this is button exit game. We'll also want to change the text of these buttons so that it actually makes sense. So let's call this a new game, and then this will be load game, and this will be exit game. Okay, so now we're going to want these buttons to actually have some functionality, and in order for that to happen, we're going to need to script it somehow. So in order to add functionality to these 3 buttons, we're going to need to create a script in one way or another. Now we can condense this into a single script, which I think makes sense. It could be a global manager that these buttons reference, as long as you add the function to these on-click events in one way or another. Now, if you've never added functions to these on-click events, you can do it in the editor and you can also do it in code. So if you have a object that has a script attached to it, like let's say this button itself, you can reference any of the scripts attached to it and then call a method on it. So you could call this button.select method, which is going to happen whenever on-click happens. So by doing that, you can have it be something like new game start script function, and then you choose the new game function so that when this button is clicked, that function is going to run. Alternatively, you can just have these delegate methods be set in code as well. So it's up to you how you want to do that. But either way you're going to do it, you have to create the new game, load game, and exit game functions. So to keep things relatively simple and straightforward, I'm going to create a script and attach it to the parent panel, which I'm going to rename main menu here. And we'll add a new script by hitting add component. And I want to type in script for a new C# script. And we're going to be calling this script main menu. And now we want to open this script up for editing. I personally use Visual Studio Code. Default in Unity, I believe, is either MonoDevelop or Visual Studio, the full-fledged version. So in this main menu script, we either need to get reference to the buttons so we can set the on-click event, or we're going to need to, in the inspector, reference the main menu script in each of those buttons to call the main menu functions. So you can do that whichever way you want. So you can either do public button, new game button, public button, load button, public button, exit game button, and then we'll be able to, let's say, change the on-click event in here. Or when we've fully written the script and the functions, which should be void functions, they don't have a return type so that we can use them here, we just reference them down there. So in order to use these button classes, we need to be using Unity Engine UI. And now we're going to create these three functions. So first, the public void new game takes no parameters. Public void load game. Next we'll have public void open load game menu. And the reason we're doing that is that generally if you're going to load a game, you're going to have a bunch of different save files. So you would need a separate panel window that your main menu opens up in order to pick which game your game is trying to load. And then finally we'll do public void exit game. So new game and exit game can be done pretty easily. At a very, very basic level, we can reference the scene manager, which we get from Unity Engine.Scene Management. And we can load scene, whichever scene is going to be the first one into your game. And you would just load that with the default values for that scene. So later on, if you have, let's say, a database of all the game objects that should load in that scene when it first starts, you can load that at this time. But for now, we're just trying to put some really basic functionality into that because serialization and basically game defaults or what objects should pop up in the scene is a whole nother story. So in order to get the name of the scene from whoever is designing the game in the inspector, we're going to set a public string new game scene name here. So wherever the script is attached, they'll be able to set the name of the scene. And then we'll pass that into the new game. So basically whatever the new game scene name is set for, that's going to be the first scene that this function actually loads. So it'll just load straight into that scene. And then after that, you can do things like load up the default values for that scene. So the exit game function is also going to be very, very easy. We call application.quit. And that's pretty much it for that. Now you should note that this function will only actually work if you are working in a compiled version of the game, not in your editor. If you click it in the editor, it's not going to do anything. But if you want to test it out, just go to File, Build, and then build it for whatever platform you want to test it on, and just make sure that that button works in the actual thing. So for opening a load game menu, we're going to either want to activate a menu object that's already in our scene, or to instantiate an object from a prefab, which basically means we have the settings for that object inside of our assets folder, and that we just basically create a copy of that in the actual scene. So how you're going to actually do it is kind of up to you. But to keep it simple, I'm just going to do public GameObject, and we'll call this load game menu. So we'll set a reference to this inside of the inspector for the main menu. And then we're going to take that load game menu object and we're going to set it to be active. And by setting it to be active, if it's a UI panel, it's going to show up, which is pretty much what we want. We want to open the menu. So that's as simple as we could possibly make this script for right now. Now what we need to do, back in the inspector, where we have the main menu and the main menu MonoBehaviour script attached, is we need to set the values for those objects. So I'm going to drag this new game button, the load game button, and the exit game button into the respective spots. I'm going to call the new game scene name level 1, make it very simple. The load game menu we haven't created yet, so we can do that by creating another UI object. So I'll just create a panel here and we'll call it load game menu. Now obviously, just like the main menu, you're going to want to add a bunch more stuff to this, like grid layouts and titles, but for right now we'll just make it very simplistic. So I'm going to change the color just so we know that that is different. And I'm going to set that game object to inactive so that by default, when we're in the main menu screen, it doesn't have the load game menu open. And now we can set that load game menu as a reference here. So I'm going to drag the game object for the load game menu. Just so you know, if you don't already realize, a game object can basically be anything in your hierarchy or any prefab that you have in your assets folder. And if you ever want to create a prefab, then you just drag one of your game objects into the prefabs folder and it'll copy all of the values into here. So now I could create copies of this load game menu anywhere I want, which is pretty handy actually. So one more thing to realize is that as it stands right now, these buttons aren't actually going to have their on-click functionality yet because we haven't set the delegate methods. So as I mentioned before, you don't necessarily have to reference the buttons in the script. What we could do is have the buttons reference the script itself. So just to quickly demonstrate that way of doing it, I'm going to drag in this main menu object and we'll say runtime only for when the function will run, but we go to main menu and we do new game here. So now when this button's clicked, it's going to call the new game function from the main menu. So that's one easy way to do it. But if you want to do it in script instead, then what we can do is call public void awake. And for each of these new game buttons, we need to set their functionality. So new game button dot on click add listener, and then we pass in the name of the method. So new game. And that's really all there is to it. So we need to do the same thing for the other buttons. So load button dot on click dot add listener, and we'll say open load game menu. And then exit game button dot on click dot add listener, exit game. And now when this script awakens, or basically when it exists in the scene, whether or not the object is set to active, that method is going to be called, and these buttons are going to get their on click listeners. Now it might be a good idea as well to do some error checking, so you could make sure that the new game buttons actually exist and they're not null before you try to set listeners to them, or else you run into errors in real time. So you could do something like, if new game button is not null, then you add the listener, else write some debug message to the console letting you know that it doesn't have a button set up here as a reference. But for right now, those buttons should work. So let's go ahead and hit play. So we can test our buttons now. For instance, load game. You can see when I hit load game, it sets the load game menu to be active. Now there's nothing on it yet. It's a pretty lame menu, but the load game button does in fact work. Now in order to close that menu out, you probably want another button inside of that menu for like an X button to close the menu. But for right now, we know that works. Now, the new game button won't work because we don't have an actual scene named level 1. So you see when we hit new game, it says scene level 1 couldn't be loaded because it hasn't been added. Basically, it doesn't exist. And then the exit game button isn't going to work simply because we're working in the editor, but it is being called. We could actually add a debug message just to prove that it's being called. So we could say debug.log trying to exit game doesn't work in editor. So let's test that out one more time just to show that it is being called. Okay, so you can see trying to exit game doesn't work in editor. Oh, and by the way, a open save game button would work exactly the same as this load game button. You could just, on a different menu, you probably wouldn't have it in the main menu because you're not saving a game there, you are trying to start a game. But you could just have save game menu dot set active true, but that would probably be from a different scene inside of the game, or if you got to a save point, that kind of thing. So for this tutorial, let's just do a little bit more. For one thing, I'm going to take the load game menu and I'm going to set that to be not transparent at all. I'm also going to add some padding to all sides, and we'll add in a title panel. So right click, panel, and then make sure that this is centered and stretched on the top. I'm going to decrease the height, and then let's add a title text there, calling it load game, and we'll also add in a button for closing the panel. So I'm going to put this button in the top right hand corner, and you can change the image if you want a more fancy looking button for closing it. But if you just want a really simple prototype of an X button, you can just go to the text as a child element under the button and change the text to X. You can also set it to best fit so that it is going to be a little bit bigger. Now we're going to want to take this button and somehow, once again, either through script or you can directly attach the method right here, we're going to want to close the load game menu. So I'm going to actually reference the load game menu object here. I'm going to drag this down below, and I'm going to take the game object that's set to, and I'm going to set it to not be active. So we're taking the load game menu object and we're calling the GameObject.setActive method and making it set to inactive, which is exactly the opposite of what we're doing here with this open load game menu script. Now, to show why prefabs are powerful, we did already create a load game menu prefab, but now it has extra stuff associated with it. And if we ever want to call a load game menu from anywhere else in the game, we don't want to recreate it every time that we need a load game menu. So what we can do is we can basically update the prefab. So the quickest way to do that, if it's light blue here, that means it's attached to a prefab, and we can update the prefab with all of the values, all of the objects that are nested under it, simply by hitting prefab over here. So now this load game menu prefab has the panel, the text, the button, and the button's text all associated with it, and we can add it to our game anywhere we want, exactly how it is right now. But yeah, make sure it's actually instantiated onto the canvas or it's not going to render properly. So you can see now we have a second load game menu, which is exactly the same as the first. You can see if I enable either of them that they're exactly the same. So if you haven't gotten too used to prefabs, I really recommend you start working around with them because they'll make your life a lot easier. Okay, so we can delete this extra game object from the hierarchy. We don't need it in the scene. Now let's just go ahead and test the load game menu and the button one more time. So we're going to hit play. We're going to get the load game menu to pop up, and I'm going to hit the X button to close that menu, and we can keep cycling between them. So now we have a working new game menu that has a new game button, a load game button, and an exit game button. Now the load game, obviously you can't load the game yet. There's a lot more coding that needs to go into that. But we have the basic framework for our menu at this point. Now, one last thing I want to do with this video is to create a new scene, and we're going to call this the level 1 scene, just so that that new game button has something to actually load into, basically proof of concept here. So I'm going to hit play on our sample scene, and I'm going to hit new game. And what happens? What happens is we get an error because that scene hasn't been included in the build settings. So in order to do that, we could drag this scene into the hierarchy and set it to unload scene. And I think that should work. As long as it's in the hierarchy, it'll be referenced. But we can go to File, Build Settings, and add open scenes to make sure that that scene is going to be included in the build when we actually export our game to the different devices that can play it. So yeah, if you're ever wondering why your scene can't load, make sure it's in Scenes and Build here. But now that it's there, I don't think we even need to have it in the scene. I don't even think we need to have it in the hierarchy anymore. We just need to reference it at least that once. So let's save the scene one more time, hit play, and try to hit that new game button. And we hit new game, and it loads level 1, which has absolutely nothing in it except for a camera with a blue background. But we can tell pretty easily that that's different than this one, because this one has the canvas on it. I guess the camera color is actually the same blue background. You can change that, by the way, if you want. But that's the basics of how you create a main menu screen from a technical standpoint. In the future, we'll talk more about how to have save game screens and load game screens that are fully functional with saving and loading all the data. But for right now, that's going to be it for this tutorial. So I've been Chris, thanks for watching, and I will see you guys in my future Unity content. Hello everybody, Chris here, and in this video I'm going to be showing you guys how we can create a pause menu for any level of our game. And to make things a little bit different this time, I'm going to be instantiating the menu as a prefab rather than having it set as an object that's in the hierarchy by default. So in other words, we're not going to be putting the menu inside of the scene directly inside of a canvas, but we're actually going to use a manager script that we'll create in order to instantiate that menu on demand from our prefab, which we have stored in the assets. So I think this should be quite in-depth and probably will be across a few videos, but hopefully you guys will learn a lot from it. Now, before we can instantiate a prefab, we of course have to create it. So I'm going to create a new panel inside of the scene hierarchy. And this is just temporary, of course. We're going to be removing it from the hierarchy and storing it only as a prefab in our assets/prefabs folder. But for right now, we'll have this panel, which automatically assigns a new canvas when one does not exist inside of the scene. So I'm also going to assume that you don't want your new pop-up menu to take the full game screen. So one way that you can control its sizing would be to have it stretch, but then to give it padding, but then to give it margins on each side. So if we give it a margin of 100 pixels on all directions, or maybe just 50 for the top and bottom when we're working at such a low resolution, we can have it stretch to most of the screen, but leave a little bit of our game hiding behind it. So next I'm going to rename this panel to pause menu to better define what it actually is supposed to do. And now we'll add a couple more UI components to this. So I'll create a panel here, and I'll drag this panel to the top. And I can drag the margin for this panel up towards the top so that it only takes this little top sliver. And under that, I can add in a text component for a title for this window, and we can say this is pause in all caps, and center it so that it's very clear that the game is paused. Might also increase the size or check best fit in order to make better use of that space that's up there. And we can rename this panel to be top bar. Now inside of this pause menu, I'm going to also want to create a new empty. And with this empty, we're going to call this the layout scheme. And the only purpose of this is to organize our button components that will go beneath it. So an add component, I can type in, let's see, layout, and we'll do a vertical layout group. So now as we add new buttons to this layout scheme, it's going to be ordering them in terms of the space available with its parent component. And you can see here the bounds of the parent, which we probably actually want to stretch at least horizontally, and probably expand its space to make up the full use of everything beneath the top bar. Now we can just duplicate a few more buttons here, making sure that the parent is the layout scheme, and the layout scheme will take care of determining where they should go. A couple options you can control here are the child force expand, which will remove some of that spacing between them, but if you want to set a specific amount of space, you can do that with spacing. And we'll set the child alignment to be upper center and add 25 pixels padding on all directions just to make it look a little nicer. Now, another thing we're going to want for the top bar is going to be a close window button or a resume game button. You can determine for yourself how you want this to be placed, but I'm going to just put it as an X in the top right hand corner over here. And for the text, I'll change that to X. You could also change the image on the button component itself if you want something looking a lot nicer than just a little piece of text there, but that'll serve for right now. Another little piece of information we can add to the pause menu might be a text that tells the player that they can hit X or escape to resume, and we'll stretch that horizontally as well, anchored to the bottom, of course. If you have this situation where your background's kind of dark, it's probably better to change the color to white, for instance. And if you have any other fonts in your project, like Kinematic, you can change to that if you think that looks nicer than the default Arial. For the record, the Kine font pack is actually free to use, CC0 license, I believe. So if you want to take a look at that for kind of more gamey looking fonts, definitely Google search that, and you should be able to find it pretty easily. Also, center this text element horizontally, and now that makes it a little bit more clear. So let's label what these buttons actually do, both in the hierarchy and the text component itself. So the first button is going to be, let's just say, save game. We won't actually write a save game script in this video, but we'll have it there as a placeholder. So the next one will be, you could say hence. That's something I see some games do where they might have like a hence menu there. Of course, hence can also spoil the game, but you know, it's one option to have. And then, of course, quit to main menu. And what this button will do is basically go back to our default scene. Currently it's called sample scene in my folders here, but I'm gonna rename that to main menu to make it a lot more clear. So let's rename these buttons in the hierarchy as well. So I will call this button quit to main menu. This one will be button hence. And this one will be button save game. Okay, so now we can save this entire pause menu as a prefab. I'm gonna drag that into our hierarchy, and I'm gonna delete it from the scene. So the goal here is going to be to create the pause menu inside of our game when we need it, without actually hard storing it inside of the scene hierarchy. So it'll always be in our prefabs, and we just load it when we need it. So to do that, we'll need some kind of scene manager script. So in my scripts folder here, I'm gonna create a new C# script. And I will call this game scene manager. To differentiate it from the default scene manager in Unity, there is a scene manager which is for switching between scenes, but this is more about controlling the behaviors inside of the scenes, like being able to open the menu. You can call it whatever you want, and you can define extra functionality that it can do in the future, of course. So I'm going to open this up for editing inside of Visual Studio Code. You can use whichever editor you want. So inside of the game scene manager script, I will leave it a MonoBehaviour as well. So for the sake of this video and keeping to core Unity classes, I'm going to leave it as a MonoBehaviour. If you look into Singleton design, something like this might make more sense as a Singleton, which always exists inside of the scene and will be created on demand if it does not already exist. But for right now, what we need to get reference to is going to be a prefab. So I'm going to call this GameObject pause menu prefab, and we'll define this inside of the hierarchy. We just have to have a space here for the prefab. And what we will do here is create a method, and we'll call this public void open pause menu. So the idea here is that our prefab does not exist inside the scene, or we don't expect it to be at least. So what we're going to want to do here is instantiate the pause menu prefab if no instance of it currently exists. So I'm going to call instantiate, which is a default method to all MonoBehaviours, on the pause menu prefab. And we want to put this on the canvas. So if a canvas doesn't exist, then we want to create that canvas. And if it does exist, then we want to put this onto the canvas. So one way we can do this is also get a public, or actually probably a private canvas. We don't really want anyone setting this manually in the inspector. And I will call this canvas. So this canvas, that's what we want to use as the transform location for this method. So what we're doing here is we're creating a copy of the GameObject prefab on top of the canvas transform. And when you attach a child to a parent, that means in the hierarchy, it's going to be one level below it. So by doing this, the game object will be created on the canvas and it will draw on the screen properly. So you should do that for UI elements. But we should only be doing this if one does not already exist. So if pause menu instance is equal to null, then we should do that. Otherwise, we should simply tell the current pause menu instance to be set active to true. So set, well, it's not going to show the method until we actually define it. So game object pause menu instance. Okay, so now we should be able to call the dot set active and set that to true. So this game code is first checking to see if one exists, and if it doesn't, then it creates a new game menu. And if it does exist, then set currently existing pause menu to true. But we still need to do one thing for this simple script to work, which is to do a onAwake method for the MonoBehaviour, and we need to find the canvas inside of the scene. So the canvas is going to be get component in the scene canvas. So if one already exists, then that gets assigned here. If not, then we actually want it to create one. But you know what? I just thought of an even better way to do it. We can do this as a property. So to declare it as a property, we're going to want to define this again. So I'll call this scene canvas so that the name doesn't override. So I'm going to call this scene canvas so that its name doesn't conflict with the class name. And we need to do a get and a set. Oh, actually, really we just need get, because we're not really trying to create new canvases. So what we'll do is if the current canvas is equal to null, then we will make canvas equals get component canvas. So basically, if it hasn't been set yet, then we're going to set it with the scene. And if it's still not active, then we're going to need to create a new canvas element. So we can do that, I suppose, with instantiate. So I'm going to instantiate a new canvas. And the transform is not going to be set because we don't want to parent it with anything. We're just going to create a new canvas UI component. And then after all of that's done, we want to return the canvas. And one more thing is to make sure that the canvas variable is actually set there. So this is going to check if canvas variable is set. Then if not set, look in scene for canvas. And then finally, if no canvas in scene, create one. Then finally, we're going to return the canvas. So with this, I guess we don't need this awake method anymore, at least for the moment. And we'll be able to have a canvas basically no matter what. So even if we forget to include a canvas in the scene, it's going to create one for us on demand. And then through open pause menu, if we need that canvas on demand, all we need to do is call scene canvas as a property here. So it's going to go through all this code before returning the final canvas. And then it'll give us the transform for that canvas and instantiate the prefab onto that. So this is just a kind of more fun, cool way of doing pretty much what we would have done in onAwake, which is just to get the canvas in the scene. But it goes one step further and creates the canvas if one does not exist. Okay, so now we need to attach this cool game manager script to an object in our scene. So one place we could put it, assuming you're using the event systems that are basically defaulted into every scene, we could just attach it to that game object, and it would work pretty much okay. So next, I'm going to drag this pause menu we created, the prefab, into the game scene manager. So now this game scene manager has the method for opening the pause menu, or instantiating and opening it, but it does not actually have anything referencing that script in order to call that method. So there's a few ways we could do it now. One is just to check if the escape button is pressed, and if so, open the pause menu, which is probably what we're going to do for starters. Another way is that you can have an event trigger in your game, like you go up to a save point, you hit enter, it checks if there's a trigger collision with that save point, and then if there is, then you open up a menu. Basically, you reference the game scene manager and then call pause menu open. So getting that event in game method to work is a little bit more involved, so that'll be a different mini video series. But for right now, we can make it really easy on us by just having it trigger when the escape button is pressed. So a generally better practice would be to separate the import script or import manager from something like a game scene manager. But what I'll do just here for this video is I'm going to make an update method. So we'll just kind of include that basic functionality for this game scene manager in here. But it's up to you if you want to separate it later on into separate scripts and make everything, and to decouple everything from different systems. So we can do public void update, which exists in all MonoBehaviours. And what we would do is if input.getKeyDown is equal to the key code.escape key, then we know that import key is down. And now we can call the open pause menu function. Okay, so let's go ahead and actually test this out to see if it works. Okay, so we're in game, stuff's happening, I'm gonna hit escape, and what happens? We get a null reference exception. Okay, so I'm gonna check that error and see where it was. I'm guessing it was related to the canvas. Okay, so to correct a couple things in the scene, where it says get component canvas, this is actually checking on the current game object, which in this case is the event system. So there was a canvas in the scene, but it wasn't able to find it. So the method we're actually trying to call is find object of type canvas. So if it finds a canvas object in the scene, it will assign it there. Now for this instantiate, you can't instantiate a new game object as a component there. So another way we could do this, and I think this is probably the better way, would be to do a prefab as well. Rather than manually creating a new game object with something like GameObject.instantiate and then adding components like the canvas to it manually, why not just have it all saved as a prefab with all of the settings we want inside of our assets folder, just like with the pause menu. So for that, I will do public game object canvas prefab, and instead we'll just simply be creating a copy of that canvas prefab, and then we'll get component canvas on top of it, because the variable canvas is storing a reference to the component, not the game object. So the components are what's attached to the game object. So now we can take this canvas, make it into a prefab by dragging it down below once Unity updates here. So I'm going to create that prefab down here in my prefabs folder. And to prove that everything works, I'm going to delete that canvas as well. And I'm going to set it as a prefab that's attached to this game scene manager script. So now if we hit play, we can test if the canvas and the pause menu will be created on demand. So I'm going to hit escape, and oh, look at that. So we have canvas clone and pause menu clone created here. As you can see, the pause menu is attached to the clone, and we have all of the buttons, the text, and the close menu button up here exactly as we created it in the prefab. So using prefabs, you can accomplish a lot, especially if you need to duplicate enemies or things of that nature. Prefabs become very, very useful. Now I'm back out of the game runtime and we're just working in the hierarchy again. So we start to do a few things here. We have a pause menu that can open, but none of its buttons actually do anything at the moment. So we need to create a script for the pause menu and probably attach it as a MonoBehaviour on the pause menu itself. So let's go to scripts, and I'm going to create a new script, and we will call it pause menu. So this time, I'm not going to be keeping a reference to the buttons inside of the script, but rather the buttons are going to reference the script inside of the inspector, where you can set on click delegates straight in the inspector, which is great for designers. You don't have to worry about code. So we just need to create the methods, which this pause menu is capable of doing. So let's start with a close menu button. And this is going to take the game object and set active and false. Now another alternative, if you want to destroy the prefab so it's not in your scene when it's not being active, then another thing you could do as an alternative is destroy this .gameObject. Okay, so when you say this, you're referencing this script, but you actually want to reference the game object that it's attached to. So we're going to be attaching the pause menu script to the pause menu game object, but we don't want to destroy the script because then the rest of the pause menu, everything but the script functionality, is still going to be there. That's why you need to call this.gameObject, not this. Pretty common mistake there. So next up we'll do open save menu. And just for fun, because we're doing it the prefab method, we could put in a public game object, save menu, prefab here, and then we'll create that. And it's the exact same thing as the game scene manager. We just want to open that save menu. So I'm going to run this over here. So the next thing that we would need to be able to do is to create an open save menu function so that the button inside of the pause menu can call that. So as things are here, we could rewrite it. Basically, the open pause menu function, we rewrite the same thing here, and we could also rewrite the same code where we get reference to the canvas, just like in the game scene manager. But we don't actually want to have to rewrite code over and over again, and it'll make things messy anyway. Now, because the pause menu is not actually going to be inside of the scene when the scene loads, it's instantiated from a prefab or the save menu as well. We can't actually reference that script at the moment by doing something like game scene manager, because it doesn't exist when we're working with the prefab. Prefab only has knowledge of the components that are under it. Now, we also can't just simply make the game scene manager a static class like this because it inherits from MonoBehaviour. So what we actually want to do here is to turn the game scene manager into a singleton. And when it's a singleton, it'll be able to be referenced statically from other scripts like this. So we'd be able to call something like game scene manager dot whatever method we have in there, but you can see those methods, they need to be static, or we need to have reference to the actual game manager instance. So in the next video, we're going to be talking about a really cool library called Singleton, and we'll actually be turning this game scene manager from a MonoBehaviour into a singleton instance, which still has MonoBehaviour functionality basically. And it actually goes a step further than that, because we'll be able to create this game scene manager as a file that exists inside of our assets folder. So the game scene manager will become something that always exists. There'll always be one copy of it, and we can reference it from other scripts like this pause menu, even if the pause menu is not going to exist when the game starts, but rather be instantiated as a prefab. And what you might notice is that going this direction with singleton systems that exist one of in your system is actually a bit more similar to what Unity's coming out in the future, which is the Unity ECS, or Entity Component System. Now for now we'll be using singletons. ECS is nowhere near ready for the public yet, and this should serve as a cool way to get these global scripts running that we can use inside of our other game objects, our UI components, and basically be able to reference their functionality on demand. And be sure that it always actually exists one copy of inside of our scene. So anyway, that's going to be the next video. For now, that's going to be it. So I've been Chris, thanks for watching, and I'll see you when we continue working on these pause menu scripts inside of Unity. Hello everybody, Chris here, and in this video we're going to continue working on our pause menu script by turning it into a singleton object. So if you're not familiar with the singleton design pattern, it's where you would have one item inside of a scene that spawned from a class. So basically, whenever you have a singleton, you can only create one of in your scene, and it should be able to be statically referenced, usually by the name of the class .instance, and then you reference whatever methods you want in it. So using a library like Singleton, which implements that design pattern, works out really well for us when we want something like a system which should be global, stay in the scene, possibly transition between scenes and still be there, but gives us the ability to have global functionality that we could easily reference in other scripts. And knowing that no matter what, because we're statically referencing that class, it's going to be talking about the same object at all times from all scripts. So if you go into the Unity asset store, you can search for Singleton, which as you can see is a free add-on. just by typing in Singleton, it'll be the first one in there, and YA just means yet another Singleton library. And so we can import that into our project. You don't need the examples unless you don't want it to be there. Just everything under the Singleton folder, import that. Okay, so now that we have this in a folder in our project, if you want to pop that into a plugins folder, I guess we can do that. It kind of makes sense. So I'll create a folder called plugins, and we will drop Singleton into that just for better organization. But now we can edit any MonoBehaviour script and turn it into a Singleton object. Okay, so earlier I actually meant we were going to take the game scene manager script and turn that into a Singleton object. The pause menu, if we have a pause menu script at all, that will still be attached to the prefab where we have a pause menu prefab. But for this game scene manager, anything that's a manager is going to be something that we want to have a global presence within the game. So it's a perfect case for using Singleton. So to use the Singleton package, all we need to do is change it from a MonoBehaviour into a Singleton of the type of the class. So if we have public class game scene manager, then it's Singleton game scene manager. So we're basically wrapping our class inside of a Singleton object here. And we can import that using Singleton. So now at this point, this class, whenever we have it inside the game, it should only be able to have one instance of the game scene manager, and we should be able to statically reference it. So how the Singleton library here works is that all of these scriptable objects, meaning you can create an instance of them inside of our game resources, the assets folder, they'll all be collected and managed inside of the Singleton updater script, which loads when the game loads. So the Singleton updater will pick up all of our Singleton classes, all the instances of those classes, and load them with that helper script. So by having that helper class, it's able to pick up on all of these scriptable objects and allow them to run their game functionality without themselves actually technically being MonoBehaviours. And because they're managed by the Singleton updater, you're also able to call stuff like onUpdate inside of a Singleton object. So now just to show, if we dive into Singleton and then base Singleton, that's where you can see that it is a scriptable object. So being that game scene manager is now a scriptable object, we can actually put in an attribute here so that it can be created as an asset inside of our project, and it'll automatically be picked up on by the Singleton updater without us having to actually attach it to a game object in the scene. So to do that, we use the create asset menu attribute, which will take, I believe it's a file name, and we will set that string to be game scene manager, and menu name will be the path and the name of this create assets menu function in the right click and up here at game object. I think it's either a game object or component. It'll show up here for us to be able to call that function and actually create the game asset. So let me show you what I mean here. We're going to call this systems as a path, and then game scene manager, which means it's going to be added in a menu folder called systems, and then under that is going to be game scene manager. So as long as we save this, we should be able to see the create asset menu function back inside of Unity. So if I right click here after everything compiles and we go to create, you can see this new menu item called systems, and it has game scene manager under it. So by using that right-click menu, going up to Assets, Create Systems, we can now create an instance of that game scene manager to store inside of our project, much like a prefab would. But I'm going to create this in a folder called Resources. I believe that's the standard way to do it. And in this, I don't know, we'll make another folder. We'll call it Systems, just kind of organizing everything here. And inside of here, we'll actually run that function. So create systems, game scene manager, and oh, look at that. Now we have a game scene manager inside of our project. You can see that it still takes references to the pause menu prefab and the canvas prefab. And if we hit play to load the game, this game scene manager should show up in don't delete on scene load. So let's see, or don't destroy on load. And you can see it's being managed by the Singleton updater. And we can see all of our Singleton objects automatically populate in here. So this is really cool. Any kind of system you want to have inside of your game, something that should always exist, you can just create a Singleton object for it, and it'll automatically load with your game. You don't have to attach it to anything in the hierarchy anymore. Singleton updater will automatically be instantiated as long as you have that plugin inside of your project. So this is really, really cool, and hopefully in future videos I'll show you guys a lot more that we can do with this as well. So for now, you probably want to actually change this game scene manager to have the default set. So we can go grab the prefabs. So let's see, the pause menu prefab and the canvas prefab. And if we get rid of the canvas inside of the scene and hit play, we should be able to use this game scene manager in the same way pretty much that it worked when we had it attached to a script. So let's see, escape here. But one error we're running into, we do need to make sure that Game Scene Manager is no longer attached to Event System or anything else in the scene, because it's no longer a MonoBehaviour, which means you can't attach it to anything. It's a scriptable object now. So let's see, Event Systems, Game Scene Manager. Yeah, okay, so we should remove that. And now we can go ahead and hit play, and it should work properly now. Okay, it's playing, looks like no more errors, and we hit escape. And it's now actually taking the escape function. So let's go back in the code and see what went wrong here. Okay, so the thing is, update no longer exists. Remember, this is a scriptable object now. But because this actually gets added onto Singleton updater, which is an executor behavior, basically functions like a MonoBehaviour for our purposes, what we call instead of update is onUpdate. And that's all we should have to do. Okay, it should be public override onUpdate. If you want to see any of the other functions that exist for these singletons, you can just right click and go to definition and go to base singleton definition. And you can see these functions you can hook onto inside of the Unity lifecycle. So on fixed update if you're doing physics, on update, on late update if you need something to happen after on update. And you have several other methods there. And you can also do an override of onInitialize, which of course you're going to want to do base.update, so this gets called still, so that the singleton updater actually grabs this singleton. And deinitialize, where you can have stuff happen when this singleton object is no longer being used. But for now, public override void on update and whatever code you want it to run. And we can go ahead and hit play now. We hit escape, and look at that. The pause menu is being instantiated from our scriptable object, which is a singleton, and only one will exist inside of the game. And the reason we're doing all of this is that now that we know this game scene manager is an object which will always have an instance of it as long as you've created the scriptable object, then we can just reference game scene manager.instance anytime we want to get anything off of this game scene manager, such as a reference to the canvas prefab or the pause menu prefab. So that's going to help us out a lot when we're trying to reference it without actually seeing it inside of the hierarchy. So like if you have to reference a game object directly that's inside your hierarchy, it needs to be put there before the scene exists. But if we can just call the class.instance, then as long as there's an instance inside of our currently running game, it'll get referenced to that. So in the next video, we'll be working on the pause menu and probably changing around a little bit of the code in the game scene manager, changing this to be more like open menu that we can call on any game object that is a menu. And in the end, we'll be able to have the pause menu open up this save menu and probably implement some more menu-based functionality there. So until the next video, I've been Chris, thanks for watching, and I will see you in my next Unity video. Okay, so in this video we're going to be working with our pause menu and the Singleton game scene manager. By the end of this video, I think we're going to be taking much of this functionality, like opening a menu and closing a menu, and we'll be able to actually just straight up take it out of this class, and rather have most of our functionality go with the system or the manager, whatever you want to call it, where the code that actually executes will exist here. So for that reason, we're just going to make the game scene manager change to menu manager, because we really only want this class to be for this specific function. So menu manager, just make sure that wherever there's a reference to that name, we change it here. So menu manager and all those 4 spaces, and the name of the file as well. And we will change this open pause menu to open menu. And in order to open a menu, we need to know which game object we are referencing. So game object menu prefab. Yeah, and we can actually call this more like create menu. Now, whether it makes sense to you to actually have the menus exist inside of your scene all the time on a canvas that is set up in your hierarchy, or if you want to create them on demand with instantiation, that's up to you. For right now, I'm just gonna keep it as instantiate because that's what we were doing in the last couple of videos. So we need to create a menu from a menu prefab. So we'll take this parameter and make it instantiate that menu prefab at the scene canvas.transform. And since we'll be creating and deleting menus on demand, I'll just get rid of this part because the idea here is going to be I'm always going to destroy those menus. So we'll also want a public void destroy menu, which will have a reference to a menu MonoBehaviour. So I'll call this menu and we'll create this menu class. We can actually just go ahead and do that here. So I will. So this name actually conflicts with something in the Unity editor. So we could call this something else like game menu, just to keep it be 2 separate names. And then we can generate this in a new file, which will be created inside of the same directory, as long as we're using Visual Studio Code. And so this is going to be a MonoBehaviour, which should be attached to every game menu prefab. So let's import that from Unity Engine there, and we'll worry about what this actually does in a minute. So now for destroy menu, we'll check if menu does not equal null, then we'll destroy menu.GameObject. And we can actually have the menu manager maintain a list of these menu game objects if there's more than one on the screen. So I guess we'll call this list, list of game menu, and we'll call this active menus. Now we're going to want this active menus to be fresh every time this menu manager instantiates itself. So we can override the initialize method. So that's going to be private, or protected, sorry. And then the return type is void, and we do base.initialize here to make sure it gets added to the Singleton updater. And now we can set active menus to a new list of a game menu. So something I'm not 100% sure on here is if we can reference a prefab as the script that's attached to that prefab. So instead of passing in a game object menu prefab, both in the inspector and down here, can we just reference, let's say, public game menu, and then we'll call this menu prefab. And then we'll call this pause menu prefab 2. Actually, we'll call this pause menu prefab and comment out the game object version of that. And now we'll pass in game menu over here, and then menu, and then for open pause menu, instead we just want to open the prefab. So we'll do create menu here, and we'll use the prefab. So now we want to actually instantiate the menu dot game object. So whenever you reference a prefab in the editor, when the game actually loads, it becomes its own game object. So in theory, this game menu script should be attached to its own game object, and we should be able to instantiate a copy of that game object with this instantiate method. So we have to see if that's actually going to work though. Now, for future reference, we want to be able to keep track of all of the active menus. So as we create this game object new menu, we also want to add that to the active menu. So I'll do new menu, and we'll get component on that, which is going to be the game menu. So this is the new instance of the game menu script on the new instance of the game object. And when we destroy the menu, we also want to remove it from the active menu. So active menus.remove menu, removing it from the list, and then we destroy the game object. So by doing this, this active menus list should contain all the references to the active menus, as long as we always remember to call create menu and destroy menu when we're loading and unloading our game menus. So with that, let's do a little testing back in the editor. So we have this menu manager, and it is a scriptable object. So we go back over to our resources systems folder, and we find the object, and now we're looking for the pause menu prefab. So this pause menu prefab, as it stands right now, should be a game menu, not an actual prefab. So let's see what happens when we actually change that. Pause menu prefab, and it's still there. Okay, let's try that one more time. Pause menu prefab. Okay. You know what the problem is? We changed the name of the class, so the actual scriptable object has lost reference to it. That is one downside of having these scriptable objects, so be careful about that. If you change the class name, you might need to recreate your object, or at least re-reference the script there. So I'm going to just recreate the object to be a little quicker, and let's try getting a reference to that pause menu. Okay, so that doesn't actually work. We do need to reference the game object itself. Okay, so given that that's the case, we'll have game object pause menu prefab. And all that we'll need to change here is that when we're calling a method on it, like creating the menu, we just need to get the component out of that prefab. And we should also make sure that that actually exists, the component. So we're going to call this, so in the on update code, we're going to call game menu equals the prefab.getComponent game menu. And if menu does not equal null, then we will create the menu with that. We can move this comment up here. So create the menu with the menu. Otherwise, we should log an error. So debug log error pause menu prefab has no game menu script attached to it. And get component, you also have to put the little parentheses there because it is calling a method. Okay, great. So now we can attach the pause menu prefab here. Now, if we run the game as is, it's going to error out because this pause menu prefab does not have the script attached to it, hence writing this debug message code. So let's actually just go ahead and test that out in game. When I hit escape, we should get an error. So I hit escape, and oh look, we get the error because there's no script attached to it. So we need that script attached because the menu is going to contain some references, hopefully. So at this point, what the menu will be responsible for is containing probably mostly references to the button variables and that sort of thing, and maybe some properties as well. But most of the code will actually be run in this menu manager. But let's just attach the script to that prefab. So we're going to call the game menu script, and obviously there's nothing on it yet, but as we add stuff to it, we want to make sure that it is actually already loaded in there. So let's play it now, hit escape, and it's loading again. Now the close button doesn't work at all right now because we're not using the pause menu script anymore. I'm not even sure we need this close menu function here because I think GameObjects can just call this directly. So we'll actually see by basically going into this prefab. Okay, and we'll need it in the hierarchy temporarily, but we'll go into the prefab and find the close menu button, which I will rename menu button. And let's see if we can just add the onClick event directly here. So pause menu being referenced there. And we'll go into functions, GameObject. Okay, so it has set active, but it doesn't have destroy. So there's a few different ways we could go about it here. We could add the close menu method into the game menu script, which would be pretty much how we had it in the 2 videos ago. We could also just have it call GameObject.setActive, and we'll make that not active. And then in our menu manager script, we can just check to see if any of the game menu game objects are inactive, and if so, just destroy them. Or a third option would be we can take the pause menu with the game menu script and have this take a reference to our close menu button. And then from there, we just call the game manager or menu manager. And from there, inside of the game menu script, we will just call menu manager.instance.destroy menu. And that would be better if we actually want to keep track of all of these active menus, which I'm honestly not 100% sure if we would need that later on or not, but being able to manage it like this would allow us to play around with these game menus if we ever needed to change something, like if we, I don't know, you needed to change the color of all the game menus simultaneously or something like that. Okay, so for the sake of argument though, I think what we will go with is that we're going to keep the functionality in the menu manager, and then the game menu will simply contain a reference to the button. And as we create a new menu, as long as the menu manager exists, it's going to add onto that button the functionality where when it's clicked, it's going to destroy the menu. So to do that, in game menu, we should have a public button, destroy menu button. And we can, of course, keep that lowercase because it's not a property. And we're going to be using Unity Engine UI for that. So that's all we'll have in this script for right now. And now we'll go back over here. So when we create the new menu, we're going to get reference to the game menu, which we already did, but we're just going to cut this code out here so we can do a little bit more on it. And then when we're finished doing more stuff, we'll add it into the menu. But for right now, we want to assign functionality to the buttons. So what we'll do is menu.destroy menu button, and we'll do the on click event, add a listener so we can add a Unity action, and that will be to destroy the menu of the menu itself. So if we finish that up, it should work there. Cannot convert from void to Unity events action. So normally when you do add listener, you can just directly reference a 0 argument method, but we actually need a argument here, which is the game menu. So what we can do here is change this code up a little bit. And instead, we're going to be creating a delegate here. So this is going to be a delegate of the method. And by typing it like this, we're actually able to pass in the parameter. So if you ever run into adding a listener for an on-click event and you need it, just wrap it in a delegate and pass that in as the argument for the add listener method. Now let's see here, menu.GameObject. Okay. So this naming is actually a problem because we passed in menu over here. So we need to change this to some kind of new name. Let's go with menu component, I suppose. And we'll update the references to make sure we don't have anything going on with that menu up there. We only want the menu as the argument to be the thing we instantiate from. So let's see, menu component. Okay, we get the destroy button. We add the listener, which is going to destroy the menu of the menu component, which should get the game object and destroy the game object, also removing it from the list. So I think we're actually good here. In theory, this should work. So let's go test it out, of course. Okay, so back in the Unity editor to test this out, let's actually set a menu button here. So the menu button is obviously going to be inside of the prefab. As long as we're working with the prefab, you can just drag and drop references to other game objects inside of it, because this prefab is going to be instantiated all as one thing. So it's always going to have a reference to this. So dragging that in here will work pretty easily. So we apply that to save it to the prefab. Let's delete it from the scene hierarchy, hit play and test things out. No errors in the console. Hit escape to open the menu. And now if we left click this, it should close the menu. Awesome. So now we have the functionality of these menus being set without even having anything go on inside of the game menu. The game menu just contains a reference to the button. And doing that sort of thing, we can separate basically our properties from the actual game code, having managers or systems run the code, and then attached to our actual game objects are just basically components that contain a bunch of data or references to variables. And this is kind of going more in the direction of Unity ECS, which isn't out yet, but the idea is you would have components rather than MonoBehaviours, and they can only contain values. So I don't think a button would technically qualify there, but you would just have like floats and booleans over in these components, and then all of your actual functionality would be in system scripts. But that won't be out for quite some time now, so don't worry too much about that unless it's something that really interests you. So now, one more thing we do need to be able to take care of is to reference the save menu prefab. So the pause menu is supposed to be able to open the save menu as well. Now, I think for right now, I'm just going to take this prefab, cut it out, and paste it into the menu manager. We'll just have the menu manager contain all of the prefabs for the game. But it'll be the buttons on the menus themselves that actually do the opening, but the code will be stored here. So save menu prefab. We can actually just go ahead and delete the pause menu altogether, so I'm going to do that here. And now, whenever we create the menu, we'll want to somehow check if it's a pause menu or a save menu to determine what buttons should be being put onto it. Now at this point, you could split this up into several different scripts. You could have like a save menu manager, a pause menu manager, all that other kind of stuff. So for right now, I will do public void, and we'll say instantiate pause menu. And then we'll also have public void instantiate save menu. So what we'll do is we'll check what type of game menu this actually is before we do things like assigning this. Before we do stuff like assigning menu specific buttons. So the pause menu will have an open save menu button, but the save menu will not have that same functionality. But we don't want to keep retyping this instantiate code. So actually we'll call this more like add pause menu functionality and add save menu functionality. So in order to figure out if we should add pause menu functionality or add save menu functionality to the game menu, we need to check what type of game menu this is actually being. So game menu will actually turn into an abstract class here. So I'm going to do that now. Because we don't want this to be its own class that people actually inherit from. We want to add a save menu script or a pause menu script onto the game object. So we're going to just check if menu component.getType is equal to type of pause menu. And if that's the case, then we'll do something. Else if menu component.getType. You know what, this would actually make a little bit more sense if we just wrote it once. So type is menu component.getType. Okay, so yeah, write once and then just reuse the variable. So type equals type of pause menu. Okay, great. And let's see, else if type equals type of save menu, and then we'll do that. So great, add save menu functionality, add pause menu functionality. So at least at a basic level that seems logical. So let's see now, how are we actually going to add that on? Well, first we're going to need reference to that menu component. So to do that, I guess we'll cast it. So casting it as a pause menu. Let's see, menu component. Does that work? Okay, well, it should. So let's see, pause menu, pause menu. Okay, yep, no errors there. And then save menu, save menu. Great, so now we can have some custom stuff to happen when it's a pause menu and some custom stuff to happen when it's a save menu. So for the pause menu, so this is going to include a public button, open save menu button. And of course, we have to be using unity.ui. And now back in the menu manager, we can basically do this function again. So we need to be doing it on the pause menu though, but we need to be doing it on the pause menu. So now we're going to get the other button, which is open save menu button. On click, add listener, and the listener there is going to be create menu. And the menu we're creating is the save menu prefab. Actually, right here, we can basically reuse this code because we're going to need to make sure that that prefab exists. So let's go ahead and create another method. We'll call this public void, or actually private void, because we don't really want other classes to call this. So we'll call it private void validate prefab, and which is going to take a game object prefab. And then we're going to basically just call this code down here. So obviously that's also calling the create menu. So we can say validate and create, and this should be more like menu prefab, because what we're doing here is we're checking if the prefab has a menu script, a game menu script. We want to be specific here. And if so, then instantiate the prefab. So we can just call this now. So we're going to be calling it on the pause menu prefab here. Pause menu prefab. And now we can call this same code over here. So instead of calling create menu directly, we're calling validate and create menu prefab with the save menu prefab. And for the add save menu functionality, although that doesn't do anything right now, we can set it up for later. So casting the menu component as a save menu. Now if we add anything to add save menu functionality later on, which we probably will, then that can go in here. Now just for cleanup, this private game object pause menu instance, we no longer need that because we're actually just maintaining a list of all the game menu instances. And better than managing it as a game object, we're just referencing the game menu script instead of the game object directly. Also making sure that only game menus can appear in this list. Okay, so that made this error out. And actually, this really shouldn't be here anyway, because this just creates the menu. So we're going to cut that out. And what we'll do is go down here to where on escape, it will create that menu. And what we can do is for each let's see, game menu in game menus, or what was it actually called up here? Active menus, sorry. Active menus. We check if the game menu is actually a type of pause menu. So if menu.getType equals type of pause menu, then we'll assign exists to true and break, because we don't need to check through any of the other game menu scripts here. So bool exists, and now if exists does not equal true, or rather we can just do exclamation mark exists. Now that's going to give us an error because it may not actually have been set there. So we'll default that value to false so the code can run, and there'll always be a false unless it actually gets set to true. And if it doesn't exist, then we run the validate and create menu prefab function here. So by doing that, we've decoupled the create menu from checking to see if the pause menu exists, which is good. So let's go ahead and see if all of this actually works. So first, inside of the prefab, I'm going to change this from game menu to a pause menu. So remove component, add component, pause menu, and we need a save menu prefab to put in here. Okay, also the script needed to load a bit there. It should have the parent variable set here too. So you see the destroy menu button and the open save menu button, those should both appear there. So if we take this pause menu prefab back out, we're going to have the destroy menu prefab. So destroy menu destroy menu button. And we're going to reference that here. Oh, also, let's go to the scene so we can actually see stuff. Okay, so to see it, we're going to need to create a canvas at least temporarily. Well, why does that look so messy? Let's try re-adding the prefab onto that. I think that should fix it. Okay, so I'm not exactly sure what went on there, but if I stretch everything here, we can just kind of reset some of these values, and I'll hit apply. So setting those settings back to the prefab, and hopefully that doesn't happen again. Oh wait, but we also needed to do a couple more things there. So we need to set an open save menu button here. So you can see in the layout scheme, we created that button before. I'm gonna add that to open save menu button. So by doing this, the menu manager will be able to reference this button, and we just need to make sure to apply it on the prefab, and we can delete it from the scene. One thing we will need to create though is an actual save menu, because we haven't done that yet. So to do that for right now, I'm going to duplicate this pause menu. And we're going to rename it as save menu. And I'm also re-adding it from the prefab. So make sure that this is actually a separate prefab from the pause menu. So we're going to strip these buttons out because those won't exist in a save menu. We'll break the prefab instance, so we'll need to resave it over here, but that's okay. And for the top bar, we're going to change the text from pause to save. Or we could call it save game. That's a little bit more specific. And maybe we expand the space at which it can display there as well. And we need to change the script on the prefab from pause menu to save menu. So save menu. And you can see here it takes a destroy menu button at the moment. So I'm going to assign that there. And now we can overwrite the prefab that exists in our prefab directory. And finally, we can delete these from the scene. Well, I'm actually going to remove that text at the bottom as well. We don't need that. And so overwrite the prefab one more time. And now we can delete it from the scene, delete the canvas. And the last thing we need to do is for the menu manager, we need to assign the save menu prefab. So I'm going to assign that here just very easily. Selecting the prefab. And we hit play. So we can see if the pause menu can in fact open the save menu now. So let's see, does the pause menu open? Yes, it does. If we hit save game, does the save menu open? Or something opened. Let me see here. Pause menu, pause menu, pause menu. Okay, so it's cloning the pause menu, so I must have a minor issue in the code. Let's see here. Create menu. Okay, so the add pause menu button, open save menu, is calling validate and create menu prefab. So let's check down here, and what we see is, oh, it's using the pause menu prefab all the time rather than the parameter we passed in. So we just need to change that to prefab from pause menu prefab, and that should work here. So let's go ahead, hit play, we'll hit escape, save game, and it opens the save game menu. Now what we might actually want to do is have this pause menu become inactive temporarily or permanently. We could destroy it or set it inactive so that while the save game menu is open, the pause menu is not open. So this might not be what we want in the end, but we could just have the pause menu destroy itself whenever that button gets called. So pause menu dot open save menu button dot unclick dot add listener. And yes, we're calling the same method here, but you can do that multiple times. So we just want to make it call destroy menu on this menu itself. So that would be the pause menu and a semicolon. Okay, that actually goes on the inside. A semicolon. Okay, so now the onClick event has two listeners, to create a new menu and to destroy the current menu. So let's test that one more time, and then we can probably call it a video here. So we hit escape, save game, and the save game menu should also have the same functionality because it was a game menu and it was being created. So we click that and as the functionality to destroy the menu. So now we have a menu manager that allows us to create two different types of menu and assign custom functionality to both of them. The main menu manager is created using Singleton, so it's always a one-of inside of our scene. And we can basically use that, we can extend that later on to add in new types of menus or whatever we need it for. So hopefully this tutorial has been really helpful for you guys in getting set up with your pause menus and save menus, but hopefully even more than that, learning a bit about singletons and how you can implement them inside of your Unity game. So I've been Chris, thank you for watching, and I will see you guys in my future Unity videos. Hello everybody, Chris here, and in this video I'm going to be showing you how we can allow a player to change the position of UI elements such as a health total or maybe how much gold they have, using an options menu that we create inside of the game. So in this scene, I've already gone ahead and set up a very, very basic GUI where we have this health total showing in the top left-hand corner. And you can see a couple elements beneath it. It's got a health image, and it's also got a health text. The image just to show the icon, and the text to actually show the value of the health to the player. And this is all anchored in the top left-hand corner. You can see on the select transform, it's anchored up there to the top left-hand corner. So what we'll be doing in this video is making it so that the player can change the anchor point to any of the corners, whether that's top left, bottom right, or top right. And very similarly, you could also say allow the player to adjust position X, position Y, and similar settings in order to tweak it a little bit further. So we're going to be doing all of those settings inside of UI control menu, which is just a game object I've set up here. It doesn't have a script yet, but it's going to be a menu that is specifically for controlling the position of the GUI. Obviously, you'll need a more extensive menu system with like a main menu, and then you come into this menu. You can see some of my other tutorials on creating a more complicated menu system for that. But we're solely focused on moving the GUI through an options menu. And so in order for this to work, we're going to need to create a new script for this UI control menu, because right now it's just a panel with a background. So in my folder for the scripts, I'm going to right click here and add in a new C# script. I will name it the same thing with the object, just for some consistency. And I will drag this script in to the UI control menu as a MonoBehaviour script that we can go ahead and edit. So I'm going to edit this script inside of Visual Studio. And this script is going to need a reference to the GUI because we're trying to modify the GUI, so we need to know about those GUI elements. Now you'll notice here for the GUI, I already went ahead and created a very simple script here. And this GUI script does nothing but get a reference to the health GUI component, which is this showing up in the top left-hand corner. But you'd probably have more elements here inside of the script. So it's just to manage all the GUI elements in one place. And then the health GUI just has references to the image and text. So in the UI control menu, we want to get a reference to that GUI. So I'm going to call this preview GUI. And the reason for that is that I'm imagining in this scene, it's more like the main menu of the game, where we're not setting the GUI directly, but we're gathering all of the settings for the GUI so that when we're in the actual game, it'll show properly. So this is really just for rendering the preview using the settings that the player picks. So you could even rename this GUI to preview GUI if that makes more sense to you. Now in the UI control menu, I'm also going to want a drop down where I can select which corner this element can be set to. Basically, if it's in the top left-hand corner, the bottom left, or so on. So one really good way we can present a drop-down menu to the player is by using enum variables, which will basically take a string name and assign that to an integer value. And then in the actual code, whatever name is passed in can basically be used to determine what kind of setting is actually being assigned to it. Even though the setting itself isn't a string, we use a string to represent that setting. So I'm going to call this location. And there's going to be 4 options here. So top left, top right, bottom left, and bottom right. Now this just creates the enum type. We actually need to create a field for it as well. So I'm going to do public health location, And we could default this to a value, so let's just do health location.top left. So by default, it'll be anchored into the top left. Okay, so now it's showing up in the inspector. We'll make this health location dropdown show as an actual UI component in a little bit. But before we get to that, let's actually make the method so that depending on what the health location is set to, the GUI health location element will actually change its anchor position. So let's call this method public void update health anchor position. If you can think of a more compact name than that, then please go ahead. And we can pass in a health location as a parameter here. Alternatively, you don't necessarily have to pass it in as a parameter. You could just use the value set in the class itself, but it depends what makes more sense to you depending on how you're going to be designing this. But in any case, we need to get reference to that health location. So with the health location, I think a good way of solving this here for a small list of options would be a switch statement. So we take a switch statement, we pass in the health location, and then depending on what case of health location, which will be top left, top right, bottom left, and so on, then we will change something about the GUI. So let's set up all of these cases here. Okay, and now depending on what setting we have passed in, we want to change the GUI. So with the preview GUI, we're going to get reference to its health GUI element. And on the health GUI, we want to get access to the rect transform component. And we're going to want to do stuff with that. But because in all cases, we're going to want access to the same rect transform, we can actually move this part outside of the switch statement, only calling the method once. So let's say health rect transform is equal to preview GUI, health GUI, get component rect transform. So with the health rect transform, we're going to want to change its anchored position, and we're also going to want to change its pivot point. So in order to change the anchored position and the pivot of the rect transform, we're going to want to be modifying these values here. So min, max, pivot. These are all normalized to the shape of the parent object. So this preview GUI is stretched to our entire interface. It probably would be in most cases. And if we set, let's say, the anchor to 1 over here, making the min x position of the anchor all the way to the right, then it automatically assigns the actual position up here based on the parent object. So we don't even need a reference to the parent object here. We just need to change these values to either 0, 1, or -1, depending on what positions we want. So we can see the anchored position takes a vector 2. So we need a new vector 2. And this is the top left position. So the anchored position should be at x of 0, and then y of 1, I believe, because higher is, and 1, I believe, for the y position, because when you go up on the screen, that's talking about a higher y position, and lower is negative. So in theory, I think that should work. We'll, of course, test it later on. And then the pivot as well, I believe, takes a vector 2. So yes, vector 2. So we also want the pivot to be 0 and 1. And actually, we don't even need to do the work of figuring out these values, because we can just test it in this inspector interface. So we can see top left for pivot and the anchor is 0 and 1 on both the min and the max. And then top right is 1, 1 for all of them. So let's go ahead and update that in here. And now that I think about it, I think we might actually want to be setting the anchor max and anchor min. So I'm going to do that, and we'll see if it works, if we need to go back to anchor position or not. So anyway, this is a new vector 2 with values 1 and 1. And the same thing for the max and pivot. So I'm just going to copy that. Let's do anchor max, anchor pivot. Oh, no, sorry, just pivot. And let's copy this up here, change the values. So we want 0, 1, 0, 1, and 0, 1. And let's get the values for the bottom left-hand corner. And let's get the values for the bottom left-hand corner here. So it's zeros all the way across. So let's copy this and change the values to 0. So 0, 0, 0, 0, 0. 0, 0. And then the last one should be 1, 0, but let's double check just to be sure. So changing it to the bottom right-hand corner is 1, 0 all the way across. So 1, 0, 1, 0, 1, 0. And just like that, I think the anchor should be able to be set here. So now all we need to do is create a drop-down menu that when one of these is selected, it actually updates the preview GUI location. Let's reset that location back to the default for right now. And let's see here, the UI control menu also needs reference to that GUI component. So I'm gonna attach the preview GUI there. And now let's create a simple UI dropdown. So UI dropdown, and we'll have this over here. So with this dropdown script, the component, we're gonna want an onValueChanged, where we're going to pass in the UI control menu. And the UI control menu is going to get passed in an integer 32. So I guess we do need to change this script just a little bit, converting an int 32 into the enum value. So let's do that. Selected. We can honestly just make this, let's make this int here. So to do convert value to enum. And we'll also need to set the options here based on the options that exist in the UI control menu. So one option here would be to manually set all the options, and then when you get those values passed in, like which would be like the first option would represent 0 and then 1 and then 2, you could take those values and then update the location based on that. But I'm going to do something a little bit more fancy here. I'm going to delete all of these default options. And then I'm going to load options as the game actually loads based on the enum that's set here in this UI control menu script. So in order to set these options manually, we just need to get access to this drop-down component inside of the UI control menu. So in UI control menu, I'm going to add public drop-down, and this is going to be the health position dropdown. We'll import dropdown from unityengine.ui. And so when this script awakes, we want it to set the values in the dropdown component. So health position dropdown is going to be equal to the health location options, but we actually need to convert that into a list here. So to convert this enum into a list of strings, we can do enum.getNames, and now we need a type. So I'm going to do the type of health location. And what does this return us? An array of strings, but we want a list of strings. So we need to create a new list of string, passing in that array of strings as the parameter. Okay, so getting the names gives us a string array, but we need to have it converted into a list of drop-down option data. But you can see here that there's a method in the drop-down class called addOptions, which takes a list of strings for options. Of course, if you just do it like this, it's not going to have the sprite associated with it. So if you wanted to have a little image associated with the option, which is possible, then you would need to probably create the option data manually and add the sprites in. But here we're just going to use a list of string. So let's see here. To create the list of strings, we're going to need to do a new list of string here. And we're going to pass in the array. And instead of doing .options equal, we're going to do addOptions, passing in this list of strings. And in theory, that should work as long as the health position is set. So if this is properly set, then we're going to add the options in. Else, let's debug, log some warning out to the user or the players. So, well, probably the editor of the game, not the players. They don't have a debug log console. So anyway, debug log warning, health position drop down, not set. And then that should be okay for now. So what's happening in this script now is when it awakes inside of the game, regardless of whether this game object is enabled or not, onAwake is going to get called and it's going to add the options based on the enum to the drop-down list. And then those values are going to get passed in here. And then each of these string values is going to be associated with an integer value, which is going to be perfectly aligned with what's up here. So top left is 0, top right is 1, bottom left is 2, and then bottom right is 3. as long as we don't assign any custom values. You can hover over them and see, yeah, that's how it works. So now we just need to convert the selected integer back into the actual health location. So what we can do here is health location is equal to casting health location on the selected integer value. I think that works anyway. And yes, it does. So basically we take the integer and now we're getting the enum representation of that. We pass that into the switch. So now whatever value is selected by the player inside the game is going to be set here in this method. But one thing we also want to do here is to make this not update only inside the script, but actually to update the health location value that the control menu stores too. So we're permanently changing the health location in this script, and we're also using that value to update the locations of the preview GUI. I think we might be able to go ahead and start testing it now, so let's actually hit play here. Okay, so you can see here a dropdown hasn't been set, and we had that log warning there to kind of help us solve that. So that just means we need to drag in this dropdown here for everything to work properly. So let's go ahead and hit play one more time here. And we can see we got the enum values actually loading up here. So if we change this to a different value, hopefully we'll see something change. Okay, so the value's been selected. Did it update in the control script? No, it did not. You know what? I think I know why that is. I don't believe we set the method here. Okay, yep. So onValueChanged is currently doing nothing. So we need to reference the control, the UI control menu script and choose update health anchor position. So now the value is getting passed in there properly. And we can try that one more time. So let's try this. Top right. Ooh, nice. Bottom left. Bottom right. Top left. And those values hopefully are also being associated in this value up here, which we may or may not want to make public, because the idea is we change it in the game, not in the inspector. So you could make this a variable that does not show up in the inspector if you want, but the values are being properly changed. So obviously this is really cool, and you can repeat this same process with any GUI interface items. If you want to change like the manual position X, like the offset values, then back in the script you would just add a UI field here that allows you to input some number. Maybe it's a slider bar, and then you take that slider bar value and you use that to adjust the positions of each of the UI elements. And the same way we set the anchor position, instead you would just come in here and for the health rect transform, you do something like, let's see, do they have position here? Position X equals whatever number that you passed in. So hopefully that gives you a good idea of how you can use the options menu in order to manipulate the interface or allow the player to change the interface, customizing the position, the size of things, all that other kind of stuff. One thing I do need to point out though is that in order for these values to save permanently in your game, as you're switching between scenes, you will need to take this data, like the positions that you've set in the options menu, and actually serialize that to a save file, whether that's temporary or a permanent file. But that's a whole nother story, and I do have some videos on that as well. But as far as controlling the interface through a UI menu, that's going to be it for this video. I hope you guys learned a lot. I've been Chris, thanks for watching, and I will see you guys in my future video content. Hello everybody, Chris here, and in this video I'm going to be showing you how to use a tool called BFXR in order to generate character talking sounds, where in previous games, like let's say Phoenix Wright or Banjo-Kazooie, you would have a character that would say something on every character, a little bit like this. So I'll basically be showing you how to set that up inside of BFXR and generate your own sound effects. One example I'm kind of working on in my game Please Benize would look something like this for dialogue, and then we'll get straight into actually making it. So you can see on every character it actually tries to talk to you, and you could of course have different sound effects for a different character, and you pretty much get the idea. So before we get started with this tutorial, I wanted to point out to you guys that I have rebooted my Patreon page, and I've created it with tiers now. So if you do want to support this channel, if you do $5 or more per month, you can get access to basically any scripts and assets I release on the channel. So as I make my games, I'm going to be publishing some of the scripts that I will also probably push to the Unity Access Store, but for anybody who's supporting the channel, $5 or more per month gets access to those for free. And if you didn't know already, I do create courses on sites like Udemy related to different topics like GIMP, DaVinci Resolve, and of course the Unity engine. And so if you do $10 or more per month on Patreon, I'll be giving you access to all of my Udemy courses, basically all at once. And of course, I'll be updating the Patreon as I create new courses, so anyone who's there will be getting free access to those courses. But if that's not your cup of tea, I'll keep posting videos to YouTube, Steemit, and BitChute as well. So let's go ahead and get started with the tutorial anyway. So inside of BFXR, Blip or Select is going to be a really good starting place for the kind of sound we're looking for here. If we hit the button a few times, you'll notice that the sounds it creates are very much short attack time and short sustain time. So in other words, it's going to occur over a fraction of a second. Now what I'm going to do is lower the sustain time down even further. And we can probably actually lock the attack time, the sustain time, the punch, and the decay time so we don't accidentally change them if we hit something like mutation, because those are pretty much going to be consistent. The length of time we're talking about when we're talking about a character talking sound effect, one that plays on every single character, is something around a 20th of a second. It can be customized to however you want precisely inside of your Unity game. But yeah, I'll just go ahead and lock all of those because that's not something that's really going to need to change. Now up here at the top, choosing the different kind of synthesizer can get you a lot of different sounds. You can see just clicking around, the bass sound that each of these have is quite different. The one I like for these kinds of sound effects, these little Blip character talking, is whistle. I think I was also using a little bit of tan and pink earlier, but once again, you can kind of just dive into the tool and futz around for a little bit and try to get your own sounds. So from here, we probably want a lower frequency. I can't imagine that having a really high-pitched sound is going to be great for not pissing off your players. So I'm going to lower that down a bit. Compression, I think I had that kind of on the lower side as well. And whenever you want to play the sound back as if it was actually running in your game's dialogue, you can just hit the play button a bunch of times. And if you do it kind of at the speed that your text is going to play, you can get an idea of how it's actually going to sound. So down here, a lot of the extra stuff like harmonics and fall off, vibrato, depth, and speed, I was basically leaving that at 0. It's not really necessary here. You can obviously tell there is a lot of different sliders to play around with. Bit Crush I actually found was pretty useful. So you can see just with this one slider bar, you can quite significantly change how it actually sounds. So once you get a sound that you like, make sure you just test it a bit, and if you still like it, go ahead and export it. It'll come out as a WAV file and you can put that wherever you want on your computer. So I'll just say tutorial speak here, and I'll just put it in my Unity project as well. So it should pop up here if I was to switch over to the Unity tab, and it'll be there as a sound effect we can use. One more thing that I'll point out though is that if you do want these little blips to sound a bit more feminine because you have feminine characters, you can kind of adjust that just by moving the frequency over a bit. So you can see if we play it back with a frequency of 0.36 here, it sounds a lot more high-pitched by default, which is going to sound closer to a feminine voice. And of course we're talking about blips here, so it's not really vocals. But men, of course, do have deeper voices than females, so it makes sense. And we can take that and lower it back down if we want to return it to more of a male or something like a robot's voice. Anyway, once we have it inside of our project, if you're working in Unity, you just have to make it play as an audio clip. Now, for actually getting the dialogue to play back in the way I was showing you guys earlier, that does require some scripting, and I will have some videos on this subject showing off my scripts, and probably have the scripts for download as well in the near future. So for right now though, I will change this audio clip to the tutorial speak, and we'll go back in here and allow the Bernese to talk a little bit with that dialogue. So let's test it out in game. Okay, so now in my current dialogue system, when I walk in here, it's going to start playing back, and you can hear the sound effect playing as the character speaks his lines. So cool. So that's pretty much all there is to create simple blip sounds to play back on every character while your characters are talking in a more classical style of game, whether that's 8, 16-bit, Phoenix Wright, you know, that kind of stuff. So that's going to be it for this tutorial. So I've been Chris, thanks for watching, and I'll see you guys in my future video content. Hello everybody, Chris here, and in this video I'm going to be showing you guys how to set up a basic spawner script so that you can create game objects on your screen. Basically, this could be enemies, projectiles, or just about anything you want to create on demand. And in this case, we'll be implementing the spawner with a left mouse button click. So the setup for this is relatively simple. What you should have is a game object that you're going to want to duplicate. You can create that in your scene, but ultimately where it should end up is as a prefab object in your project. If you don't already know what a prefab is, it's basically where you take anything in the hierarchy, which is going to be a game object, put that in your assets folder, and then that can be referenced from your scripts. When it exists inside of your assets folder, we call it a prefab, which is basically a default set of values and scripts that will all be attached to a game object that you can instantiate or to create a copy of inside of your game when you need to. For right now, I'm going to delete this old prefab, and we'll just recreate the prefab by dragging it into the assets folder. You can see that I've created a subdirectory called Prefabs. That's just for organizational purposes. It can actually exist anywhere in your assets folder. So all you have to do is literally drag it from the hierarchy into one of your folders, and then that will create the prefab. Now, as for your game object itself, you can have pretty much whatever you want attached to it. In this case, I have a sprite renderer, a default box collider, and a rigid body. The only difference that I've changed is that the gravity scale has been set to 0 so that gravity does not affect this object. Basically, it won't go downwards when the game starts. Now, how do we actually instantiate this prefab, copy it to the scene over and over again? Well, I've created an extra script called spawner, and this of course takes a game object. Since I deleted the old prefab, we need to add this back in, so I'm going to do that here. And the spawner script can exist anywhere inside of your game scene. It does not need to be attached to the default event system or anything. It just needs to be on some game object when your scene starts. So I'm going to go ahead and edit this script, and I'll show you guys what's happening here. So the first thing we need to do is take a public game object. You can call this enemy or whatever, but it's going to be the object to spawn. So when we're talking about a game object, we're talking about one of these items that will exist inside of the game scene. You can see that they all have transforms, no matter what other extra scripts are attached to it, but they can have extra components and custom scripts to go along with it to define what it can do and how it interacts with the scene, such as box colliders and Rigidbody 2Ds. So next we need a spawn method. So for me, I created public void spawn vector3 position. It has no return type, but it takes a position as an input type. Basically, this is going to be the location where you want the game object to spawn. So in order to create it, with any MonoBehaviour script, you can call this method instantiate, which will create a game object of the type you pass in. So this is a game object enemy, and it's going to create a copy of that game object with all of the defaults that we have inside of the inspector for the prefab. So by default it would be position 0, 0, 0 because that's what the prefab says, but you'll notice that there's a .transform .position equals position part added on to the instantiate call. So what I'm doing here is once this object is created with instantiate, this returns a game object. So we're basically doing the game object .transform, so we're getting the transform component. That's where you control the position, rotation, scale, and taking the position of that, that's the XYZ coordinates, and assigning it to the position we passed into the spawn method. So what this means is that the position of the new game object that we instantiate is going to be equal to the position we passed in for this method. So the only thing you need on top of that is to have some kind of event to create that game object. In this case, on the update method of the script, I'm checking for if input get key down is equal to key code mouse 1, that's left mouse button. Then we'll basically get the position we want to spawn the enemy at and go ahead and call the spawn method. So in this case, one way you can get a position is to do camera.main.screenWorld.to_point. So what camera.main.screenWorld.to_point is going to do is we take a position on the screen, which is the mouse position. Now the mouse position by default, it's referring to basically the canvas coordinates or the pixel coordinates on the screen, not the actual game coordinates. But with screen to world point, we can take a position on the screen and convert it into a point within the game world. In this game, wherever the mouse is located when we click, it's going to be converting that into a position that's compatible with these transform positions. And we of course call this on the main camera, assuming that the main camera is the one that you're showing to the player when the game's actually running. That would be your default camera here. So by doing that, we calculate the position of the mouse in terms of game coordinates. But there's one thing to note about that, which is that the camera position also has a Z position of -10. And if you just get this world point, it's going to also have the Z position of -10. And that would be bad for a 2D game, because if the Z position is the same as the camera, you're not going to be able to actually see the game objects. The game objects need to be in front of the camera. So for that reason, I have made an adjustment to the world point, basically same X coordinate, same Y coordinate, but we take the transform of the prefab, the enemy spawnable game object up here, and we just take that Z position and we make that the new Z position of this adjust Z vector. So that's going to be a 0 there. So it's going to be the position of the mouse in terms of X and Y, but then the Z position of 0 of the enemy prefab. So by making those adjustments, we can just pass in that position into spawn and be able to create the game object. Essentially, wherever we click on the screen with the left mouse button, that's where the enemy is going to spawn. So if we go ahead and hit play here, we can demonstrate that once again. So we obviously have this default game object left in the screen, but wherever I click, that is where a new game object is created. And you can see, because of the components attached to it, like a dynamic rigid body, it's able to interact in terms of a physics engine, which is pretty cool. Now, just to point out again, it doesn't need to be an enemy that you're spawning with this method. It can be literally any game object. So if you have a projectile, which is its own game object, if you have a player that you want to spawn, you can do all of that with the instantiate method. So it's very useful whenever you want to copy a prefab with default settings to your scene, and then you can just change the position on where you're creating it and anything else you need to update before it finally gets added to the scene. So that's going to be it for this video on how to instantiate or create game objects using simple scripting inside of Unity. So I've been Chris, thanks for watching, and I'll see you guys in my future video content. Hello everybody, Chris here, and in this video I'm going to be showing you how you can work with events inside of Unity and to have actions occur on those events, such as clicking on a game object, inside of both scripting and inside of the inspector. So what you were seeing right there was trigger actions for two different events, one of which is on mouse down, which refers to having your mouse be clicked while it's hovering above a game object that is calling that method. In that case, it was the big bad enemy game object I had over here. I modified the spawner script a little bit with on mouse down so that when you on mouse down click, it spawns a copy of a game object at that position. The other event that was triggering was down here on this game object at the bottom, which we should really be calling a deletion zone for the sake of clarity. Basically deletes any game object that comes inside of this zone. It's box collider trigger, and it just deletes it. So this deletion zone is using a event called onTriggerCollision2D, and the spawner script in the game object is using onMouseDown. Now there are also items like UI components, including button and toggle, which will have different events that can trigger, such as onClick events, and toggles will have onValueChanged, and we'll talk about how to implement those in a little bit. Beyond that, you can also set up something called a Unity event to create your own custom events, which can add delegates inside of the inspector as well, but that'll be a more advanced topic for a future video. So let's go ahead and start with talking about how to script actions to occur on some basic events. So in a previous video, I had the spawner use this update method, which was if input.getKeyDown, it would basically spawn the game object attached to the script at the location where the mouse was pressing. Now this method private void on mouse down ties into the overall Unity event system, and any MonoBehaviour can use methods like this. So it works very similarly. Rather than having to write if input.getKeyDown, we simply create a on mouse down method, and you can notice that if you start typing in Visual Studio on, you'll get a lot of different events which you can have stuff happen when those events occur. And all you need to do is basically implement one of these methods, and then you fill out what happens when that occurs, and that's really all you need to take care of. Now, although there are quite a lot of events you can implement just like this, there are going to be some limitations. So first off, on mouse down requires you to actually be hovering over the game object in question, because when on mouse down checks, it checks if the ray from the mouse click actually collides with the game object itself. The previous implementation, where I just checked if the mouse button was down or not, doesn't do that. It's slightly different. So you do have to keep those in mind. And that's also one reason why implementing your own Unity events can be pretty useful. But just to keep it to the basics here today, on mouse down, once again, it refers to when you have a mouse button pressed down and you are hovering over the game object. So in that case, it's going to call the same functionality I had up here, which gets the position of the mouse cursor. So instead of pixels, it's going to be the same coordinates that all of these game objects share rather than the canvas UI. And then it just finds that position, sets it equal to the same Z position, which is going to be 0 rather than the Z position of the camera, and spawns the game object there. So very simple. But over on the deletion zone, we have private void on trigger enter 2D. Now there's a couple things to note about this event. One is that if you do on trigger enter, there's one that says 2D and there's one that is actually 3D. The 3D one is just on trigger enter. And the reason you need to differentiate those two methods is because 2D colliders and 3D colliders don't work together. So if you're working with 3D colliders on your game object, then you should be using on trigger enter. But if you're working on a 2D game with 2D colliders, whether that's a box collider 2D or a capsule collider 2D, you should be using on trigger enter 2D. The other one to note is on collision enter. So on collision enter is referring to when two objects that are allowed to actually have physics collisions collide with each other. So that would be two colliders that do not have the trigger box checked. So when I'm talking about the trigger box, I'm talking about right here on a collider, there will be a checkbox for is trigger. So if you have is trigger checked, what actually happens when something bumps into it is the collider itself will completely let whatever is colliding with it through. It only triggers events. So if you uncheck this, then those two items would be able to interact in terms of physics. So it might be able to bump into this ground here and not allow it to pass in terms of physics. But if you leave is trigger checked, then anything can pass through it. It's only going to respond to on trigger enter events. So if you are going to be working with collidable colliders, basically ones that don't have trigger checked, then make sure you use on collision enter or on collision enter 2D. You'll also notice that there are exit methods in correspondence to these. So if you have on collision exit, that means when the game objects stop colliding with each other, and on stay is while those are colliding with each other. On trigger enter has the same methods as well. So there'll be on trigger stay and on trigger exit as well. So with that aside, what the actual code inside of here is very simple. If it collides with a game object, which would require it to have a collider attached, like a box collider 2D, it simply destroys that game object or to delete it from the scene. It doesn't delete the prefab, it deletes the actual object inside of your game scene. And that's important because if it was deleting the prefab, then that would delete out of your assets folder and you would never be able to instantiate it again. But don't worry about that. It's just the game object in your scene, which would be in the hierarchy somewhere. So I'll play this one more time and you can see how the events work without actually implementing a lot of effort. Of course, the reason why these game objects are falling is because I added a bit of gravity scale to a Rigidbody 2D, so they are able to fall here. And you notice it doesn't actually interact in terms of physics, it just deletes it as it enters into this box collider, which is what you would expect from a trigger collider rather than a collider that does not have trigger checked, where it might be able to bounce off of the collider or something else of that nature. So beyond custom scripting functionality to happen when events occur, you can script a method, basically anything you might want to call that would return void, and you can attach that to the functionality of, let's say, a button UI component. And those components, of course, you can create by, say, right-clicking on a canvas on your scene, going down to UI button to create a new button. Okay, and usually you only want one canvas, so be careful about that. I'll delete that canvas there and just make sure this button is under the canvas as a child. And then you can add in delegate methods to these events. So certain events are exposed in script to the inspector, which is very useful because now what we can do, rather than having to, let's say, write in a script on button clicked, what we can do is just create any method we want to call, and maybe we call it in many different areas in our game, but we can have it run that method, in this case, when the button is clicked. So one thing we could do, for instance, here is to take this panel. So I'm going to drag this panel game object, and I'm going to go down to game object here. So the game object here is a script that's embedded inside of every object in your scene, every game object. And we can set that to active, which means in the case of a UI component, it's going to be showing. So let's actually move over to that UI. Okay, so in order for that to show, we have to enable the canvas, of course. But if you enable and disable the panel, it's basically opening and closing your menu. Okay, so let's go ahead and test this out now. So when I hit play, we have this button showing on screen. I click on it, the event triggers, and all of the delegate methods I've attached to that event trigger, which in this case is setting the panel to active and opening up our pretty messy menu. But the important thing is it worked, it shows on screen. Now, while I was getting this to work, I do want to point out, it's important in your scene that you have this event system object. This defaults in every scene as far as I know. And event system and standard input module, I think, is the event system that you need to care about. These button events, like on click, are only going to work if you actually have an event system script inside of your scene and it's enabled. So if you see event system in your scene, which should be there, make sure this component is enabled if you're having any issues there. The only reason it was disabled for me is I was testing things earlier and I created a mess for myself. So anyway, the button has the method attached to it now, and what's great about it here is you can easily attach as many callback functions as you want to happen from basically anything in the scene. So if you have an audio source, you could, let's say, grab the audio source script and tell it to play whatever sound effect is on top of it. Now obviously there's no audio clip here, but if you attach the audio clip in an output mixer group, that would be able to play a sound when you click on that. So you can see how being able to expose the events to the inspector is really useful, and that's what Unity events do. So Unity events, there'll be another video about how to set those up so that you can have events trigger on whatever you want to happen. And that's pretty much it for this video. So hopefully you guys learned in this video how to interact with events at a basic level and how to attach events to things like on clicks or on value changed inside of your canvas UI components. That's going to be it for this video. I've been Chris, and I will see you guys in my future video content. Hello everybody, Chris here, and in this video I want to show you how you can recreate an animated opening and closing door inside of your game using my asset, which I will be providing in the description. So basically the idea here is that there is a zone where the door will automatically open as long as it is being occupied by a box collider object, probably your character. And when you leave that zone, or when all objects have left that zone, it'll go ahead and close, allowing you to have an easily opening and closing door that also triggers an animation. Okay, so what I'm going to do now is show you how to import and use the asset in your own project. So if you go up to the Assets menu and you hit Import Package, Custom Package, you're going to want to find the Unity package file that you downloaded and open that up. This is going to have some default stuff you can use, including the sprite for the wooden door, including the animation there, the 3 scripts that are attached to that door, the prefab for the door, a couple sound effects, which you can replace if you want, and then the animation controllers and animations, which actually allow the door to open and close on demand. So you go ahead and import all of those in. If you want as well, we have the scene that we're about to recreate right here called doorscene.unity, and you can use that as a testing file. So let's go ahead and import all of this into our project, and I'll go ahead and reload the scene. Okay, so this setup is really simple. You can see that we have a collider surrounding this door. That collider is to allow or prevent the player or other characters to move through the door when it's closed and to let them through when it's open. And then over here we have a secondary trigger zone, and this trigger zone is what allows the door to know whether the space is occupied or not and whether it should be open or closed. So if we take a look down here, we can see there is an audio source attached to it. Note that there's no audio clip currently because the audio clip we want to play is actually set in the animation itself. I'll show you that in a minute. We have an animator, of course, so that the sprite can change. So occupied zone shows 3 events here. So these are Unity events, and you're able to attach event triggers here. So for instance, we have animator set bool, set animation bool, occurring when the zone is occupied, and when all occupants have left, we make it so that the boolean has occupant is set to false. And then if we look down here, we can see that animator set boolean script. The reason this is necessary is that Unity events like these up here by default cannot pass into parameters. So we need to create an extra function because the default animator function set bool requires 2 parameters, so you can't use that directly here with a default Unity event. So this just exposes that and reduces it to 1 parameter. Instead, we have the Boolean name set ahead of time, so has occupant, and then we just set it to true or set it to false, and that's what allows the animator to know whether a character is standing here or not. And then play audio source. This script exposes the audio source.play method with a clip passed in to the animator. So to understand all of that better, it'll probably help if we go ahead and open up the animation window and the animator window. So in animation, there's 2 animations attached to this door, and you can, and I would recommend you do override it if you want to change the sprite. So I have my door here, and you're welcome to use that if you'd like. Basically, it's got 4 frames. So when it's opening, it's going from the closed state to the open state. It will look kind of like this. And then when it's already open and trying to close, the animation will look like this, where it goes from the sideways closed view to all the... And then we have the close animation, where it will go from being open to closed. Now, aside from the sprite changing, there's also this box collider enabled thing. So it's box collider enabled, and it's a Boolean checkbox. So what this is triggering is for the first box collider set in the object, which is this non-trigger box collider, the one that actually has real collisions happening. If the door is open, as you can see here, it is in frame 1, then that box collider is not enabled, and a character will be able to pass through it normally, as you saw at the start of this video. However, if the door is closed, then we want that box collider to be enabled. And that's how you can change whether a door will allow the character to pass through or not, regardless of the door still actually being there as an existing game object. So at both of these animations, you also see at the top, there is an animation event here. So an animation event is where you have some function run when a frame is triggered. So when the close animation starts, it's going to play this audio clip. In this case, it's this door closed 3 .wav file, I believe. It's a sound effect anyway. And it will play that at this object because it's using the audio source of the door. Likewise, with inside door open, we can see here that it is playing the door open 01 sound effect. But if you want to change these audio clips to whatever door opening and closing sound effects, then you can just click over here and select the audio clip from your library of sound effects. Likewise, to change the sprite, you just drag in your sprites into these positions here. You can increase the number of frames if you want to. So with that aside, let's go ahead and take a look at the actual animator. So we can see that by default it's in the idle state, which is actually just closed. But the first time it's closed, we don't want it to play any animation. I'm not 100% sure if that's actually necessary, but anyway, it starts closed, and then from being closed, it can only go to the open state. So this happens when hasOccupant is set to true, and that will put it in the open state. And then from open, it can only transfer into the closed state if hasOccupant is false. And from closed, it can transfer into open if hasOccupant is true. So you can see how once it's open, it can cycle into closed, and once it's closed, it can cycle into open. And that's how you have the door keep opening and closing whenever a character steps on or steps off of the point. So to show how it is one more time, I'm using this game object here. There's no movement script attached to it, so I'm going to move it manually. Obviously, if you use a movable character and you have a player movement script attached, all you need to do is have that player move over here. Make sure it has some kind of Collider 2D not set to trigger, and that it has a rigid body. Whether that's dynamic or kinematic is up to you. So with your player game object, or whatever you want to pass through the door, once it reaches that point, it's going to play the open animation, and once it steps off, it is allowed to transfer back into the closed state, and we can go back on to have it open. We can pass through it, come out the other side for it to closed, and hopefully you guys get the idea. So that's pretty much all there is to using this basic template inside of your game. If you are going to be doing pixel art, I will point out there's one extra thing inside of this project, which is the Pixel Perfect camera. That's the reason it says up here at the top, preview packages are in use. If you want that for a pixel game, which is probably recommended, honestly, you can get that from the package manager. It's actually an official Unity asset. It's just not in its 100% fully released version. It's still a preview package, even though it says it's like version 1.0 and above. So you can see here I have the 2D Pixel Perfect package. You would probably be able to find it in all. Yeah, it would be in all if you don't already have it attached. But that's only if you want the camera to play better with pixel art. Obviously, the script would work whether you do have a pixel art door or it is a hand-painted door. So that's going to be it for my tutorial on how to use this animated door asset. I hope it helps some of you guys out and you can make some cool content with it. So I've been Chris, thanks for watching, and hopefully I'll see you guys in my future content. Hello everybody, Chris here, and in this video I want to show you guys how you can have objects spawn when a scene is created inside of Unity. So rather than having your game objects already set up in the scene like over here, you can hit the play button, and when your scene loads, objects will spawn immediately like this tree did when the scene loads. So the idea is, over in code, you want to hook into the scene manager scene loaded event. So the scene manager always exists inside of Unity, and you can add a delegate method by calling this, so delegate and then the name of your method, to run whenever the scene is loaded. So if you're using a normal MonoBehaviour, your method for adding this in might be more something like onAwake or onStart. Currently I'm using, Singleton, and the idea behind these singletons is that they will always load with the scene. Not really the focus of this video though, of course. So anyway, just when the scene starts, make sure that you hook into that scene loaded event. And then for a method, basically you want to take a prefab, some raw data, and one way or another you want to instantiate your game objects onto the scene. If you're using the new ECS system, it would be more like creating entities out of prototypes, but the idea is pretty similar either way. So for the time being anyway, until that ECS system is more fleshed out, you can do GameObject.instantiate to create any game object on demand. So with these scene loadout and scene object classes, I'm trying to create a scriptable object method of basically storing all the data that a scene should initially load with. So basically the default values for all the game objects that are going to load in the scene. But the important thing you really need here is the prefab, the spawn position, and the spawn rotation. So if we go take a look at my scene object, which is a scriptable object, scriptable objects basically, you can create them in the editor and you can store that data permanently without having things change in the inspector wildly. So scriptable objects are pretty nice because you can kind of just store the data to a file rather than needing to have like an object in your game scene all the time to hold that data. But here it's just really simple at the moment. Spawn position, spawn rotation, and prefab. So the prefabs, obviously, if you haven't worked with those inside of Unity, when you take a object from your game scene and you drag that into your project folder, it'll create a little file which is kind of just a copy of all of that data. So you can see here like the prefab for the game control. If I was to drop this into the scene, it would have all of this stuff associated with it. So if you instantiate a prefab, it's going to be creating a copy of that into the scene with all of this same data. And then the reason you might want to have a custom spawn position and spawn rotation is that you might not want that object to appear on the scene with exactly that position or exactly that rotation. So by having it instantiate with a custom spawn position and spawn rotation, you can have some custom settings for that object. Now you don't have to stop there at spawn position and spawn rotation. You could also do something like let's see, game object, no, that's bad, because that variable name's already been used. And then you could do game object.getComponent if you really wanted to, and then get any of the components that should exist on that prefab, and then to change the values on that as you instantiate the game object. So I don't know, if you needed to set something to full HP, you could get component health, and then do like set health 50 or whatever. But anyway, the simple idea to take away from this video is that you should hook into the scene loaded event, and then if the scene matches your data where you have a list of objects you want to create, then you should go ahead and instantiate those game objects onto the scene. So I guess I'll show one more thing in the scene loadout. I will have different scene loadouts for different scenes. So you can see here scene name, and that's how you basically check to see if the active scene.name is equal to that. And if so, you load all the objects for that scene. Basically, the loadout is scene specific. You could also do this with save files. So if you have a save load system, you might be saving some data like which enemies still exist inside of your game world, which ones have been destroyed. And so that when you load the game, you could load all of that data here, and then basically you get like current save load data, and then you would spawn the objects which should still exist onto the scene when the scene loads. But having that kind of save load functionality is a bit more complicated than what we're talking about right here. So just focus on instantiating your game objects when the scene loads. So basically when the scene loads, you call your delegate method to spawn the objects, and then you spawn the objects. And so that's how you can have it where you hit the play button, your scene loads, and then the objects in your scene are going to spawn. Kind of like so. Now, I do think that having a save load system here in order to save the locations and load the locations of all of your game objects as your character, your player goes through the scenes, changes things in the game, triggers certain events would be really useful to have. So I will try to cover that in the future as well once I've created it for myself. But yeah, for now, that's going to be all for this video. So I've been Chris, thanks for watching, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this video I'm going to show you guys how to set up a simple save system inside of Unity for your game so that we can save data to a file and load data for that file and bring it back into our game. Or basically what we're doing is data serialization. So what we're going to serialize is going to be the position of this save me game object. That is the Unity logo over here. You can see in the inspector, no scripts attached yet, but we will add one so that we can take the position of the transform and get it into the format we need it to be so that we can save that data to a file and then load it. So generally I would find it to be a good idea to use a manager class to handle saving and loading from a file, especially if your game is going to be complicated with many different game objects and settings that you need to save. But to get started with this simple example, we'll have it be a MonoBehaviour script that we attach to the save me object. So I'm going to create a new script here, and I am going to call it position saver. So this will create its own file for this particular game object and save the data of this transform to that. So let's go ahead and open this up, edit script. So inside of this position saver class, I'm going to create a save method and a load method. So let's go ahead and declare those. So public void save, and then public void load. I'm making these public so that in the future other game objects may be able to reference this script and call these functions. And I'm also going to create another class down here, which is going to be serializable. So we can declare that with the serializable attribute, which comes out of the system namespace. So private class position data. The reason we do this is that you can't really serialize a MonoBehaviour directly, out of the box at least, because MonoBehaviour has a lot of extra non-serializable stuff. So we just want a class where everything can be serialized properly, and then we'll serialize the data as a position data and load it as a position data, where the MonoBehaviour script will actually use that data. So the position data is going to take a vector3, and that is going to be public vector3 transform position. So in order to save the data, we have to first put it inside of our serializable class format. So I'm going to declare here position data, data equals new position data. And then we'll say data.transform position equals the transform position of the game object where this MonoBehaviour is attached to. And that's not a method, it's just a property, so we don't need the parentheses. So the idea here is that it's going to grab the game object that the script is attached to, get its transform position, and it's going to add that to the data. Then we can serialize that to a file. So there's different serializers for different data types you can use here, like JSON, XML, or binary serialization. And the idea is more or less the same. You pass in the object you want to save, you give it a target location or a file you want to write to, and then you write it. And with load, it's kind of the reverse. You locate the file and then you load it, and then you pull the data out of that. So for this one, let's do an XML serializer, because XML is a very easy to read format. So you can look at it and see where your data is or isn't saving. So we'll call this XML serializer, and import the reference to system XML serialization. And let's create that as a new XML serializer. So in order to create this, we need to tell it what kind of XML serializer it is, which is going to be a type, and the type we want is the data type. So this is going to be position data. Next, we're going to need a file stream, which I will call file stream fs, which is going to basically tell the serializer what file we're writing to. So a new file stream, which is going to take a path here, and a file mode. So for the file mode, we want it to be able to open or create, I believe, because if it's not already there, we want it to let itself create one. The path is going to be something we're going to want to set up here. Now, generally, if you're using a manager and you're saving and loading the game, you would do this all at once. So you'd have one mega serializable class, which contains all of the different game data that you're going to want to save to a single file. But here, we're just writing one piece of data to one file. So just keep in mind that with a bigger project, you would almost certainly want one object to manage the saving and loading of your data and contain all of the data from all your different game objects in one thing. But for right now, let's set that path. So we'll call this path, and the path, actually we can make that a property. And the reason for that is that we want to get the application save path at load time. So application dot this a temporary cache path, which you could use if you want to have some temporary files saving in the background as your game runs. But there's also the permanent path, which is the persistent data path. So application.persistent data path. And then we can also append on here the file name. So let's do a public string file name equals position saved, I guess. So we'll add that on here, plus the file name. And you may also want an extension, so we could say declare here the extension as .xml. Okay, and we can add that in here. So this is going to be the path to the persistent data folder plus file name plus extension. You can also add in some directory or folders there if you want to get the full path. So I will call this full save path. And we get rid of that semicolon and set that as the full save path for the file stream, and now that should resolve. Okay, so now that we have the file stream created, we need to serialize to that file stream with the data. So I'm gonna say XML serializer.serialize, and we get the file stream there. You can see that it can take different types of streams. And the object that we're serializing is our data, which we created up there. So in 5 lines of code, we've basically created the save method. We may later on find that we want to do some checks like making sure that the file exists or if it doesn't exist, and then depending on if that's the case, change some things around. But this is the basic idea. You create a serializer, you give it a file stream, and then you serialize to that file stream with the data. And then the reverse is very similar. So we're going to want to pull in our position data, and we might return it as our return type instead of void here. It depends if we want it to just be exclusively on this object or if we want to load the game or load the file and then return that data to other objects in our game. So for right now though, let's get a XML serializer, and well, let's create it the same way. Just copy and pasting this from up here. And then we need to get a file stream. We could call it read stream. Maybe that's a little bit more verbose. Read stream equals new file stream. And we're going to get this from the full save path. And let's say file mode dot open. Okay, and now we're going to want to deserialize the file. So we just need the stream here, and that's going to give us the data type that is inside of the object. Okay, so this deserialize method is going to return an object. It's not actually sure what the data type is, but we can cast it to our data type like this as position data. So we will call this position data loaded data equals whatever gets returned from that. So let's say now that we wanted to take the position that we saved and load it to our transform. So we can just do transform.position equals loaded data.transform position. So let me comment this out a bit. Loads. Okay, so now that we have this class created and commented out and everything, we can add it to our script. Apparently I already did that though. So the position saver here, I think it's supposed to have a public variable. Let me check the console. Okay, there it is. So the file name is going to be position saved by default. And this script would create one file for each script we have it attached to. So keep in mind things like overwriting file names by accident. When you're actually doing your full save system, get more complicated about it and definitely test things. But just for this simple example, what we could do now is say add in a couple buttons, one that will do the saving and one that will do the loading of our position. So let's do that. I'm going to create a UI button, and this UI button is going to be kind of in the bottom left of our interface. We will have the button text be save position, and this will be the save button. Okay, so now for this onClick event, we want to connect it to our game object over there. So I'm dragging the game object, and we're going to reference the position saver script. So position saver.save. And now we can duplicate this button, move it to the bottom right hand corner, and we will make it do position saver.load, and change the text of the button so that that's reflected there as well. And we can rename the button. So we have 2 buttons, a save button and a load button. So yeah, that's looking pretty good. So let's go ahead and hit play and test this out. So obviously there's no move script on the object itself, but we can manually change the position really easily. So all I need to do here is click over here on the position X. So in order to change the position manually, all we need to do is drag this position X over here. Then we'll hit save position. It may run into an error, but we'll see. Okay, position saver, position data is inaccessible due to protection level. Okay, so the reason we're getting that is that this class down here is not public. So I suspected that that might have been the case. So all we really need to do here is change it from private to public, and the serialization should work. I don't believe we need to take it out of the class. We can just leave it nested. But yeah, it does need to be public so that the serializer knows what type it's actually saving. So let's try this one more time. Okay, so let's move the position here, hit save position. Okay, that's cool. Now let's move it over here and hit load position. Ooh, very nice. Okay, now let's save the position again. And then we can load that position. Ooh, okay, looks to be working. Pretty cool. So one way we can take a look at our data and make sure everything's fine in the file, aside from physically testing it in the game, would be to actually go to its location on our computer. So to find where Unity saves data by default on the Windows operating system, we can go to %appdata%, and then you go back to appdata local low. And then before you set a company name for your game, it's going to be default company. So we come in here and look for the project we're working on right now. So this is Zenject test. And then Unity. And to be honest, I'm not 100% sure where it's actually saving from this location. So why don't we actually add in a debug line here. So for the script, we can say debug.log file saved to, and then we'll put in full save path here. And we can run and test this one more time, and it will give us the location that we need. So save position here, it's appdata local low default company Zenject test position saved. So it's a good thing that we actually did this test here, because it looks like the directory is being combined with the file name here, which is technically fine. It's saving to a file named Zenject test, but it was supposed to be inside the Zenject test folder. So if we actually go take a look here at default company, we can see our data is actually being saved here rather than inside the folder. That's not quite what we want. So we can go back up in here and add that slash to make sure that the directory is formed properly. Okay, let's test one more time. So save position. Okay, looks proper now. Let's go check the Zenject test folder, and we can see our file is here. So I'm going to open it up with Notepad++. Good tool for reading these kind of files. So inside of our position data, we can see the transform position has been serialized to the file. It's currently got the location 000 because in this current scene, that's where the object is. And this works fine because inside of Unity, vector 3s are serializable out of the box. But note that complicated data types like a MonoBehaviour game object are not serializable out of the box. So if you want to save data to a file, you need to break it down into a simpler data type like a serializable float, rather than trying to serialize an entire game object to a file. So be careful about that. Now we'll do one more test here by moving the position. I'm going to move all the positions, and then we'll hit save here. If I go back into Notepad++, it'll say that the data has been changed. We reload it, and we can see our data has been saved there. So as far as actually saving and loading the data, that's all there really is to it. So from here, you could try different data types like JSON or binary, binary being unreadable to the human eye. But it does take up less data space, so if you really care about the efficiency, that might be the way to go. JSON is another very human-readable data format type, so it's really up to you what you want to use for your game and which files you might have. So that's the basics of how you do serialization, saving, and loading inside of Unity. Some things you might want to look into at this point would be creating a save load manager class, which can handle the saving and loading for everything inside of your scenes rather than each individual component or each individual game object saving and loading for itself. And if you have to keep references to specific objects inside of your scene, for instance, if you can have like the position saver attached to 5 different objects, but they want to all be in one file, then you would want a way to uniquely identify those. GUIDs or GUIDs are a good idea for one way you could do that, basically giving a unique ID to every game object inside of your scene. But yeah, as far as basics go, hopefully this has helped some of you guys out. Thanks for watching, and I will see you guys in my future Unity content. Hello everybody, Chris here, and in this video I want to show you guys how we could assign unique IDs to each object inside of our game scene so that the scene can basically remember exactly which object we're talking about if we have more than one of the same type. Basically, the idea of a GUID is it's a unique identifier that will never be the same as any other object inside of the game. So by maintaining a reference to that identifier, we can always find that object within our scene, whether we leave the scene and come back or we load the game. So specifically, if we want to have a scene where we have some game objects that are always going to exist in the scene, we load them out of the box, and we may want to change some data about that as the game progresses, then one way we could give those objects the GUID ID is to have another game object, which would be a GUID manager for the scene. So in order to, let's say, give the save me game object a GUID for its position saver script, I will start by creating a empty game object, and this will be separate from that object altogether. I'm going to call it GUID manager, and inside the GUID manager I'm going to create a new script. We will call it, I guess, scene GUID manager, because it's going to manage the objects for this particular scene. And then if we open this up for editing, we can allow it to do what it's going to do. So for this GUID manager to work, we're going to want it to assign GUIDs to other MonoBehaviour scripts that are going to implement an interface. And that interface is going to be called iGUID, representing that it has a GUID attached to it. So this scene GUID manager is going to manage iGUID objects inside of the scene. And iGUID is going to be an interface we'll create here where it will force a MonoBehaviour or anything else we attach it to have a iGUID property, a GUID property attached to it. So we'll do that by right-clicking here, doing new item, and we'll add in an interface. So the interface, I'm going to call it iGUID here, making it public, removing or changing the namespace, and we'll bring that out. So this is going to require a GUID. So we could call this GUID. I'm making it all caps just to keep it distinctive from the class name. Though I guess you could do it like this too, and that would be fine. Up to you. And I guess that's all we'll need in there for right now. We may add stuff to it later on. So inside of this manager, I'm going to maintain a list of a class we'll create here. So I guess we'll call this GUID connection, and we'll say GUID connections. And this GUID connection class, we can declare it down here. So this will be GUID connection, and this will take a iGUID. And this GUID connection class type I'll create down here. So public class GUID connection. And this will need a public iGUID object, connected object rather, and then it will also need, so inside of the class, public class, so inside of the GUID connection class, I'm going to need a reference to the game objects that implement iGUID. So I guess I'll call this GUID object. That makes more sense to me. And then I think we're going to want a GUID here as well. So this GUID will be the same thing in the object, but I just want to represent that in the list as well. So the iGUID will have its own GUID, but that should be the same one that we set up in here. So as you can see, the object doesn't serialize immediately, so I'm going to make that serializable. And now our list of GUID objects or GUID connections will show up here, so we can add one in. Okay, so as you can see, it doesn't really serialize right here. iGUID, because it's an interface, it doesn't serialize out of the box. If you use a tool like Odin Inspector, you can make interfaces actually serialize, and then you can assign that. GUID also not serializable out of the box. So one way we could get around this would be to have different fields for what actually publicly displays. So we could say public game object, And this will be game object that has iGUID script attached. And then maybe we can do some checking over later. And then that will pull the iGUID in here. And then rather than serializing the GUID itself, what we can do is, let's say, just do a string. We can just do lowercase GUID, and that should be okay. But maybe we get rid of this field because it's not really going to be necessary. Whenever we want to get the GUID, we'll just get the GUID out of that GUID object. And let me make sure, we're going to want get and set. So the interface will have a requirement for a set as well, so that the GUID manager can set the GUID on the GUID object. So this variable right here, we're going to want to make sure that this changes whenever the GUID object changes. Let's take a look over here. Okay, so now we have the ability to set a game object here and a GUID here. We're actually going to want this to be a read-only field, so let's make that a thing. Or we could make it private and then serialize it. So serialized field, that'll be good. We can remove that up there. So what we're going to want to happen is whenever this game object is changed, if this GUID field has not been set, then it's going to generate a GUID, and it's going to assign that to the iGUID interface inside of the game object. So how we can make that assign a new GUID if one does not exist is we can create a onValidate method. So onValidate for the MonoBehaviour, and this will assign the GUID of the connection to the GUID of the object. Generate one if none exists inside of the connection. And we're only going to generate the GUID with this class because we don't want to accidentally generate one randomly on the game object. And we also might accidentally delete that game object or something, so we're going to want those GUIDs to remain statically stored inside of the scene GUID manager, or wherever the safest place we could find to store it would be. So onValidate. So we're going to need a for each GUID connection in GUID connections. So if the game object is set, then we want to check for its iGUID component. So GameObject, oh, hold on, be careful. It needs to be connection.GameObject. We're not referring to the MonoBehaviour GameObject, but the GameObject stored in here as a reference. We're going to need that to get the component, a component that has iGUID attached to it. Okay, I think that works. I'm not 100%. We'll check later. So we'll generate the GUID if none exists. So we can do that with a connection dot. Oh, okay. So we are going to need this to be public down there. I think there's a read-only attribute. So I suppose in this GUID connection we can also set up a actual GUID property. So call that GUID equals, or GUID, and then we'll have get, and then a set. Or actually, maybe we only need a set, because if we were getting, then that would probably be the GUID object or just the string value there. Let's keep that value there private though. So the GUID, whenever we set that, well, shoot, I guess we need a private GUID here too. So the GUID is going to be equal to the value, right? And then whenever we have that GUID set, then we're going to want to change the string value to the string representation of the GUID. So I think that should be okay. Let me take a look now. Okay, and also whenever that's set, we're going to want to set it on the GUID object as well. So GUID object dot GUID equals value. Or actually, we'll just make it equals to the value right there. Okay, so now we want to set that GUID in the outer class. So connection.GUID equals system.GUID.newGUID. Okay, so this should generate a new GUID value, if I recall. And in GUID connection, no, that should be the name of the list up there. We can also get rid of the start and update. I don't think we need it at the moment. Okay, let's see if anything is working so far. Okay, so in order to use this GUID manager, we're going to have some classes that at least implement the iGUID interface, of course. So let's find the position saver and make it implement iGUID. So the interface here, get set. What we could say here is that there is a private GUID. So the save and load method will probably be moved out of here later. And later in this class, we would only create the serializable data type for this MonoBehaviour script and deserialize the data, but not actually write it to the file. That would be the responsibility of the manager. But for right now, we can set some data. So if we do GUID.toString, we can serialize the otherwise unserializable data as a string rather than a GUID. So when we load, and then of course, in order to have that field set, we have to declare it down here. So public string GUID, and we're going to want to load that as well. So we're going to want to set this GUID as the loaded data.GUID. Can you actually set it straight up like that? Okay, so I'm not certain about if you can do this, but we can give it a shot. We will just cast it as a GUID. Okay, so in order to bring the string GUID back as an actual GUID object, we can do new GUID and we can put in the string, so loaded data.GUID. And that should work there. Okay, so we have the GUID saved and loaded as a string, and it returns to a GUID object. Let me see, is there anything else we need here? Maybe we should do some validation checking. So if the GUID connection has a game object set, but there's no GUID script, then that should error out. So if GUID script is equal to null, then we debug log a warning that the attached game object in the scene GUID manager does not have a MonoBehaviour script that implements iGUID interface. Okay, good enough. So let's see, down here, it's generating the GUID if none exists, but does that actually get assigned? In theory, it would be assigning with the set. Assign new GUID object to, assign new GUID to the iGUID script. Okay, and there's quite a few things going on here, so it's going to need a little bit of testing, but the basic idea is there. So let's try assigning a game object here for the GUID connection. Okay, so the GUID has been created. I don't believe we have any proof that it assigned there. What's this error message about? GUID connection, set GUID. Let me just open that up. Okay, so basically inside this GUID connection, the GUID object never gets assigned. And by GUID object, I mean the interface up there. So actually, maybe what we should do, since this is the class that's not really supposed to do anything on its own, we will get rid of this part, or rather, we'll bring it up here. So if the GUID script is found, then we're going to assign that GUID up here instead. So the GUID script is going to want the GUID value, so connection.GUID. And then I guess we do need the GUID value, so let's get that. So return underscore GUID as a property, sure. And this should only occur if it actually passes in there, because we obviously can't assign a GUID to a null interface. And then this generate should only occur if there is no GUID set. So if connection.GUID equals GUID.empty, Or we could say null or connection.guid equals guid.empty. Then we'll generate that. But really I only want that to generate as well if the iGuid object is actually properly assigned. But either way, we do want the values between those two objects to always be the same. So I guess we'll just leave it there and it would reassign on every validate. So I'm going to clear the log here and let's try reassigning it, see if anything happens. Nothing really does. But what I'd like there to be is some kind of field that we could show the GUID value up here in the position saver class just to prove that they're being assigned. So I'm going to add it here, edit the script here. And let's actually make a private string here, which will be called GUID. And then we'll serialize that field. The private is so that it can't be changed in the inspector. And then in order to access the value out of here, I think we're actually going to need to make that a non-auto property. Okay, so get is going to return whatever the underscore GUID is set to, and then set is going to set GUID to a value, but when that value is set, if it's ever set, GUID is going to be equal to underscore GUID.toString. Also, I do want to initialize this. Okay, so that might work. Let's take a look at the inspector and see what happens. Okay, that's actually pretty close to what we want. So the GUID is showing up here in the position saver, and we have the GUID manager over here which has the same GUID. So what happens if I change this for some ridiculous reason and then we go back over here? Does it update? No, it does not, at least initially, so we would need to fix that. But at least the GUID manager is assigning the GUID to the position saver. Let's see if we can get something that Let's see if we can set something up so that anyone in the editor wouldn't make bad things happen like that. These should always be the same. Okay, so one idea I have in mind here is to make it read-only, and then we would have this GUID be set up in the constructor method for this object. So GUID connection, and then we're going to want to generate a GUID right here, rather than ever allowing anyone to change it. So what we could do here would be GUID equals system.guid.newGUID, and then this will be the only place we ever set it. So yeah, we're going to change some stuff up there. And then when that is set, so we also want GUID.toString here, and then this will be the only place that string gets set. I believe we can actually turn this into an auto property now, so let's try that. And we can make this a private set because we don't want it to be accessed from anywhere else. Okay, this is already looking a lot better. So up here, if none exists, well, that will never happen because in the constructor here, it's generating a GUID. So we don't need this check anymore. But we do always want to make sure that that gets assigned. Okay, let's take a look at the Unity inspector now. Okay, well, it doesn't look like there's an out-of-the-box way for the read-only to prevent you from editing this, but the one option you could do is to create a custom editor script, which would involve a little bit more coding to set that. So how I usually do it is I use an attribute called read-only. It exists in Odin, which is a premium add-on you can pick up in the asset store. It helps in serialization to the Unity inspector, and it also has a more advanced serializer for writing data to a file. And the read-only attribute that exists in there, it would lock down this field for editing inside of the inspector. So you wouldn't have to write it yourself. But just, yeah, know that that would be a weakness. If you can edit that, that's not great. Also, another recommendation I might want to add, when you have your lists here, and obviously it's going to look a little different for you. It looks like this because I have Odin Inspector installed. But when you have these lists, you might want to make it harder to, let's say, delete that in here. That would be a good recommendation as well. Once again, you can write custom inspectors, look into that kind of stuff. Because the idea here is you really don't want to like lose these references unless you're absolutely sure you want to get rid of them. Otherwise, when you hit plus and you generate a new one, it's going to create a new GUID. So those are some things to think about going forward. So you can see how over here in the position saver script, it lost the reference because the GUID connection, the original one, no longer exists. Now, if I assign this game object over here, then it should get this GUID value and reassign that. So that works. The only problem is we need to do everything possible to make sure that the GUID manager does not lose these references. So what I would probably do is, if you have these GUID connections here, anytime that you would allow it to delete an object, like hitting this X button over here, you can have an editor-based script to have a pop-up here to say, are you sure you want to delete this object? So perhaps what we can do in the next video is to set up some protections here so that our GUIDs cannot be changed so easily. So until then, that's going to be it on the basics of adding GUIDs to your game objects using a scene GUID manager. I've been Chris, thanks for watching, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this video we're going to be talking about Zenject, and I'll be giving you guys an introductory lesson into using Zenject in Unity. So if you don't already know, Zenject is a dependency injection system for Unity. You can pick it up on the asset store, just type in Zenject. So what dependency injection allows you to do is to create your classes and your MonoBehaviours depending on abstractions or interfaces rather than the concrete implementation of those interfaces. So if you have a class and you say that you require an iGreeting, so you need an object that, let's say, has a message attached to it, so a message property. You'll never need to go and in those MonoBehaviours create that object manually by doing something like new greeting, where greeting was the concrete class which implements iGreeting, but rather the Zenject system, or the dependency injection system, allows itself to create that object for you and insert or inject that object wherever you need it. So if you, for instance, need only one game manager class, so you need one object that implements the iGame manager, then you can basically bind that one instance of the concrete class to the interface, and wherever that interface is referenced and has the inject keyword, it will automatically insert itself using the Zenject system. So to make that sound a little bit more concrete, we can take a look at this working example, and I have three classes here. Greeting consumer, which is a MonoBehaviour, which injects an iGreeting object into the class. So this is a iGreeting interface, and if we take a look at that interface, you can see it has one property called message. So by referencing this interface, we can basically say, hey, any object that implements iGreeting will have a message, and therefore we can use any object that implements iGreeting here in order to log out that message to the console. Now that's pretty much standard, right? But the thing that Zenject is great at is we never need to tie the concrete class specifically to this greeting consumer class, but Zenject will fill in the concrete class wherever we need it. So we have the iGreeting interface, it's an abstraction, and then we have the concrete greeting class over here. So you can see it implements the message property, and the message property returns this variable over here, hello world. So we would expect that anytime that we inject a iGreeting object with this greeting class, then the message that's going to be logged to the console would be hello world. Now, how does Zenject know to use the greeting class wherever we require a iGreeting? Well, that is where the installers and the contexts come into play. So there's a few different contexts you can use for your game. The first, if you want something to be the context for everything in your game, meaning you would bind a concrete object class to an interface, and then wherever that interface is referenced across your entire game, then that concrete object will be used to inject. So that would be a project context. So if we right click here and go to create Zenject project context, it's a prefab that automatically loads when you're running your Unity scenes or your game. And it will apply to every scene inside of your game. So we can put an installer here, which the installer tells Zenject basically, hey, what concrete object are we going to use for the interfaces? So we'll probably bind it here in this project context, just so that it applies to everything in the game. But another example of what you could do would be to right-click on your scene, go to GameObject, Zenject, and do a scene context. So the difference here is the scene context, whatever bindings you make, only apply to that scene. So if you try to resolve an object inside of this scene, so maybe you have the greeting dependent MonoBehaviour here, and that requires the iGreeting class to be, or the iGreeting interface to be injected with an object. Then as long as it can find it in the scene context, or if it can't find it in the scene context, the project context, it'll be able to resolve that game object and put the concrete object where it needs to be. So to just point out though, if you have two bindings to the same interface, whatever the lower context is going to take precedence. So if you have it in project context, but you also have it set in scene context, the scene context will overwrite the project context, which you would expect. So let's see. In order to bind it, though, we're going to need to make an installer. So I have one right here ready to go. I guess it's simple enough. There's no real point to rewrite it. So let's just open it up. So you can see there is one method in here, which is overwritten from the installer class, I believe. And it is install bindings. So in install bindings, we reference a container object. And I believe the container, it depends on wherever you're putting it to. So if you have it in the scene context, then the container is part of that scene context, I believe. Not 100% on that. But anyway, what you do is you can tell it to bind an interface, an abstraction, to a concrete object. And then you can tell it, is it a single object across your context? Or you could do this, where you would say as transient, where whenever an iGreeting needs to be injected, it would create a new instance of this concrete class for every time you need to inject it. Usually though, I find that doing as single is usually what I need. So we'll just leave it at that for now. So this means that wherever we resolve the iGreeting interface, it's going to have a concrete object of which there is only one in our context, which is either the project context or the scene context. You can also do game object contexts if you want to get very specific. So there's one object which gets injected everywhere we need it, basically. So there's many little tricks to binding things here. For instance, another way you could do it is bind interfaces and self to, I believe you put the concrete object here, and then you could do as single. Now, what this one would mean is that this greeting object is going to be a single object within the context, and any interfaces that concrete class implements are also going to be bound with this concrete class, basically all resolving to the concrete class as one single object. So if you have like one class that implements 5 interfaces, then you can basically tell it to bind all of those interfaces at one time by doing it this way. Obviously that's not necessary here and a bit more complicated, so let's just get rid of that for now. So next we need to take our mono installer and add it to the scene context or the project context. So there are 3 different types of installers here. If we were to create a new scriptable object installer, a mono installer, or an installer, these are all scripts, but a scriptable object installer allows you to create an instance of that installer as a scriptable object, good for doing things like settings. A mono installer is like a MonoBehaviour script. You add it to a game object, and then, for instance, I add it to the scene context as an additional script, and then the scene context itself can reference that script as the installer. And then installer down here is an installer without direct context with it. And then the third option, installer, is kind of independent of the Unity system. So it would just be an object that exists and you wouldn't directly attach it to anything within Unity. It's good for doing things like unit tests, if you get into that later. So as you can see by clicking on the greeting installer, you can see that this was created with the right-click create mono installer, which is a mono installer of the class greeting installer. So now all we need to do in order for the installer to be added and load with our scene to bind the interface to the concrete object is to take this, drag it in here, And now we add it to one of these lists up here. So the one that stands out to me as making sense is the installers list. So I put it in the scene context, though obviously we could add it in here as well to the project context. So let's see, greeting installer, and we could drag that up here, and it would work exactly the same way, except that the project context is for every scene in our entire game project, but the scene context is specific to that scene. So I'll just get rid of those settings there so that we're not having any confusion. So within this scene, the iGreeting should bind to greeting, and then the greeting consumer is going to be injected with the concrete implementation of the iGreeting interface, and we're going to log the message to the console, which is only possible if we have a concrete object, because obviously the interface, it's just basically setting requirements. It doesn't have any message in itself. So I'm going to hit play here, and we're going to take a look at the console, and that was from the testing earlier. So let's hit play and see if it still spits hello world to the console. So waiting a second here, and there we go. A bazillion hello world messages, just what we needed. So obviously you can see that this is only possible if we have something setting the greeting object inside of the greeting consumer, and that's what Zenject does. So the greeting consumer MonoBehaviour class doesn't need to know anything about the actual implementation of that object. It doesn't need to create a new object. It just gets injected by Zenject, and Zenject basically manages all of those dependencies for us. So hopefully you guys get a decent grasp on this. I've been playing around with Zenject myself in the last few weeks. I found it to be pretty cool and a much better alternative to using, let's say, Singleton objects for all your class managers. Because as you can see, this decouples your concrete classes from each other. So if I was to completely remove the greeting class from this project, it wouldn't have any impact on this greeting consumer class itself. I would just need to supply any other class that implements iGreeting into the Zenject installer, and the project would still work, which is really cool. Okay, so one last thing I want to point out before I go, and this is going to be the topic of the next video, is that if you dynamically create, and this should really say a game object here rather than a MonoBehaviour, if you dynamically create a game object, basically where you would do like GameObject.instantiate, that won't actually work with Zenject doing it that way. So in the next video, we'll talk about how you can create game objects in the scene, like when you spawn enemies and stuff like that, by using a factory where Zenject will still be able to work with that factory and add in the dependencies as it creates the game object in your scene. So it still fully works with MonoBehaviours. You'll just have to get out of the habit of doing this, where you instantiate, I don't know, let's say a new greeting consumer or something like that. But rather it'll be more like greeting consumer.factory.create, and that'll create the game objects wherever you need them, but with Zenject injecting all of the dependencies. So that's going to be it for this video. Thanks for watching. I hope you guys got something out of this, and I will see you guys in my future Unity content. Hello everybody, Chris here, and in this video I wanted to talk to you guys a bit more about Zenject and how we can take game objects that would normally be instantiated using something like the GameObject.instantiate method and get object creation to actually work in conjunction with Zenject, so that those game objects that have dependencies will actually receive those dependencies and go through the Zenject system. So right now I have this greeting spawner class created. It basically every second will create a copy of this greeting consumer somewhere on the screen. And it's doing that using the GameObject.instantiate method, which is what you generally do in basic Unity. However, when you instantiate a game object using this method, it doesn't go through the Zenject system, so the dependencies never get injected. So if we take a look over at the greeting consumer class that I created in the last video, you can see that it expects to get injected with an iGreeting. Now, if that object is in the scene when the scene loads, basically it's something we hard put inside of the game scene, then it will get injected. But when we're spawning it using instantiate, it does not. So let me show you what actually happens right now. These game objects, the greeting dependent object is being represented by a check mark on the screen. So you'll see a bunch of these check marks pop up, but inside of the console, only the first game object will actually log the hello world message to the console. So the first object gets injected properly, as you can see here, but every other object is getting a null reference exception. It's not being injected with the concrete greeting message for the iGreeting interface. So how do we solve that? Well, one way that they recommend in the documentation for Zenject is to use a factory and then to let Zenject go through that factory and inject the dependencies that way. So how we can create a factory is actually pretty simple. So we're going to do a nested class for that factory here. So I'm going to do public class and I'll call it factory, so that whenever we want to reference this factory class, we could type in greetingconsumer.factory. And this inherits from the placeholder factory class, and it's a placeholder factory of greeting consumer, which basically means that we're going to be spitting out greeting consumer objects from this placeholder factory. Now, if we need to add any dependencies, then we simply add it to the left as a list of parameters as the generic type parameters. So here I can put in a iGreeting, which means that this placeholder factory is going to inject the iGreeting and it's going to resolve a new greeting consumer object. We don't need to type anything else for this placeholder factory. If you look through the documentation, there's also an iFactory interface which would allow you to have extra customization for your placeholder factory. But if you just need it to do a simple injection, then you can use placeholder factory, and then in the main MonoBehaviour class, all we need to create is a public void construct method. It needs to be construct because game objects, MonoBehaviour game objects cannot have a regular constructor in Unity. And then we need to tell the class what kind of object we need injected. So we need the iGreeting, and then we basically take this iGreeting and we set it to the new iGreeting. And if I recall, I believe you need to move the inject over to this so it becomes a method injection rather than a variable injection. The documentation does recommend using method injection and constructor injections whenever possible. I won't get into the details about that. So this is going to mean that whenever the factory creates the game object, it's going to run that construct method. I think the name of this has to be construct, and it will inject at that point in time. For the game object that already exists inside the scene, we might need an inject here as well. We'll test it and find out. But that's the general idea here. You use a factory to create it, and you implement this construct method and you inject there. So now, with this factory, we want to go over to the spawner class, and we instead want to do greetingconsumer.factory.create. And I guess we need to actually add in the iGreeting object here. So what we can do, since this greeting spawner will already exist in this inside of the scene, it's okay to inject it in here. So the iGreeting object will just come into play right there, and we pass it into the factory. And this will create a greeting consumer object, so we should change this type over here to greeting consumer, making it more specific anyway. So when you're creating your factories, if you're using the placeholder factory class, then your output type goes on the right over here. And if you need anything to be inside of the factory, so another object like a manager that you might use in order to create your objects, you could add it in here. So how you can take the greeting consumer class and make it so that you can dynamically inject this iGreeting whenever we create a new object, rather than using GameObject.instantiate, we can use a factory instead. So to add a factory, we would do this as a nested class, public class factory. So this will be greetingConsumer.factory for this particular factory. And it extends from placeholder factory. And the output type is going to be greetingConsumer. Now, if in the factory you're going to have any other dependencies like a manager, then you can add in extra parameters before the output value. So requirements for the factory on the left, and then the output value on the right. But I believe we don't actually need that here in order to inject the iGreeting. So we're not passing an iGreeting object into the factory, but we're going to allow the factory to instead run a method that we're about to implement here, which is public void construct, which requires an iGreeting, and we'll call that greeting. And then we will take the iGreeting variable and set that to the value we passed in. So it's a lot like having a constructor here, but using object constructors for one reason or another doesn't work with Unity. So we need to instead implement this method here in conjunction with the placeholder factory. So I believe we inject here to get the iGreeting object. And so the placeholder factory will run. At some point during that, Zenject will be used with the factory. This is a class out of Zenject, by the way. And Zenject will run this construct method and inject the iGreeting, similar to how we were with the variable injection. Now, I think we might want to leave the inject here for the objects that are already in the scene, like the first one that was manually added. I'm not certain about that, but we'll see how it goes. So now over in the greeting spawner, we want to change instantiate to consumer prefab.factory. Oh wait, sorry. We want it to be greetingConsumer.factory. Okay, and the factory is going to have a create method. So we just run it like that. And then this is going to return a greetingConsumer object rather than a game object. Okay, and now over on the greeting spawner class, we are going to need a factory. And we're going to want to install and inject this factory as well. So over here, we're going to need an inject. So this class is going to use the Zenject library, and it is going to be a greetingConsumer.factory. And we'll just call this greetingConsumer.factory. Okay, great. And now down here where it says instantiate consumer prefab.GameObject, what we want instead is to do greetingConsumer.factory .create. So that'll spit out the greetingConsumer game object, so we can change it over here, unless we want to cast the greetingConsumer as a game object. Of course, the greetingConsumer itself is a MonoBehaviour script, which is attached to a game object, so there will be a game object there. Depends on what we need to reference over here, if anything. So I'll just reference the MonoBehaviour script there with greetingConsumer. And now this factory, we need to add this to the installer. So over here on this greetingInstaller class, we're going to bind a factory. So to bind the factory, we have type parameters on the left, if any, for the factory itself. We don't have any. So next we need the type of game object we are binding with the factory, which is greetingConsumer, the type of object that the factory spits out. And the factory type is greetingConsumer.factory. And then we are going to bind this as single. So this means for the greetingConsumer class, we are going to have one greetingConsumer factory, and it's a single factory. So wherever we have a need for a greetingConsumer.factory that outputs greetingConsumer, it's going to be injected with this single game object. So we'll have one greetingConsumer factory for pretty much everything inside of our scene or project context. Okay, so just looking over everything again, the factory should get injected here, and whenever we need those dynamically created game objects, the factory will run. And the factory is a placeholder factory of greetingConsumer. It doesn't take any parameters, but it should inject this iGreeting in when the object is dynamically created using the factory. So let's see how that goes. Clearing the console and making sure that the greeting dispenser still has the script attached. Okay, it's still there. It's referencing the MonoBehaviour script on the consumer prefab. So this may work. Let's go ahead and see what happens. Okay, assert hit. Okay, so as it suggests right here, we're supposed to use instantiate prefab for component because we're using a MonoBehaviour here and we want to create the game object for that MonoBehaviour. So over in the greeting installer, instead of binding the factory as single, what we actually want to do is from component in new prefab, and then we need the greeting consumer prefab. So this should actually be a setting for us. So let's call this greeting consumer, and we'll say greeting consumer prefab. And then what we can do is we can move the prefab from the greeting spawner class over to the greeting installer. So this will make it so that the prefab for the default greeting consumer will be basically at the context of the scene or the project, depending on where we put this installer, rather than attached to the greeting spawner itself, which is probably better anyway. So in order to set this value, one way we could do it is to make this public, because this is a mono installer, so this variable will show up in the inspector where we can set it. And then that'll be passed in here. So it's going to take the component from the GameObject prefab and it'll use that in creating the new object through the factory. So let's just go ahead and set that up over here. So let's see, over on the scene context where we have the greeting installer MonoBehaviour, we are going to want to pass in the greeting dependent prefab. So greeting consumer prefab. Right, that is a type of greeting consumer. And then it should disappear from the greeting spawner. So the greeting spawner really no longer knows anything about which object exactly it's spawning. It just knows that it relies on a factory in order to spawn that object. Okay, so now I think it should work, but we will hit play and find out. So we have the hello world to start. Oh, and look, more objects are being created and they are getting injected with the concrete greeting object instead of getting a null reference error failing to inject the interface. So it's actually working now, and that's exactly what we wanted here. So basically what we've done is we've created a factory that will pull in Zenject and inject the dependency where we need it for an object that's being dynamically created with a factory. So yeah, hopefully this tutorial has been really helpful for you guys, especially if you're trying to get something like an enemy spawner to work where those objects are created after the scene loads. So I've been Chris, thanks for watching this tutorial, and I will see you guys in my future Unity content. Hello everybody, Chris here, and in this video I'm going to be showing you how to create a scriptable object installer for Zenject and Unity, and to basically pull settings out so that they can be maintained in that scriptable object as a scriptable object installer. So we have this greeting consumer prefab setting here, and right now it's attached to this greeting installer mono installer. That's okay if we want it to be managed here, but if we'd rather have it centralized in a scriptable object asset that we can create multiple instances of, such as one settings for your live production game and then one for testing, then hopefully this tutorial will help you guys out a bit. So the first thing I'm going to do is go over to my scripts installers folder, and I'm going to right click, create a new scriptable object installer. So this is going to be the settings installer. So inside of the settings installer, we're going to have a game settings object. So game settings, we haven't created the class for this yet, but we're going to allow this game settings to reside inside of the scriptable object. You can see up here, create asset menu. Whenever you have an object that, or class rather, that extends from scriptable object, you can create instances of that object inside of your assets folder as something you can just navigate to and edit in the inspector. So we're going to need a game settings class, so I will create that in the scripts folder. So new item, and I will call this class game settings.cs. So this game settings class is going to not use an interface. But rather what we can do is we can have multiple copies of the settings installer, and we'll just bind it to resource locations. Rather than binding an interface as a concrete object, we will bind an object in our assets file to that class. So it'll become a single object pulled out of some resource location inside of our project. And inside of this game settings class, the only setting that we are going to want to maintain is coming right out of here from the greeting installer. So the greeting installer, so we're going to have the setting of public greeting consumer prefab, and put that in game settings. Now, as you might imagine, the greeting consumer prefab is going to need to be here inside of the greeting installer. So what we can do is we can actually inject into an installer itself. So we're going to inject game settings here, which we'll resolve later, and then we can take settings dot greeting consumer prefab, and this will all work in the same way. Now, obviously, in order for this installer to work now, it will require there to be at least one instance of a settings installer at the context of wherever it's loading, if that's the scene context, or above it at the project context. So do be careful about that so you don't run into any errors. Now in the settings installer, we're going to bind whatever game settings object is basically set in this scriptable object, and we're going to bind that to the container. So bind game settings, and we could actually do something like bind interfaces and self to game settings. And this would be nice if we ever decide to add any interfaces to the game settings. They'll already be bound here, and we won't need to do a custom binding for every single interface. And we're going to bind this to single. So whatever settings are here is going to be the settings that resolves basically everywhere within the context that this settings installer is added to. So I think now we just need to actually create an instance of the scriptable object. So over in the project for the resources, I believe it does need to be in the resources folder. We're going to create a copy of this installer. So the settings installer, and we can call this test settings installer. So as you can see here, the settings aren't showing up here for the test settings installer. The reason for that is I accidentally made the game settings private. We need it to be public so that it will show up in the Unity inspector by default. And it's still not loading, so I guess we need to take the game settings and also make the class serializable. Just so that Unity knows to try to serialize this. You don't need to worry about this warning here where it says that the class isn't serializable, because we're not trying to serialize it to a file, we're only trying to serialize it to the Unity inspector. So I think with that it should show up. Okay, and there we go. So it's now serializing here in the scriptable object, and we can set that greeting consumer prefab, going over to the prefabs folder, drop it in there. And now, as long as this test settings installer is actually being run and installed, then this setting should show up in Resolve. Now, in order to do that, we would want to add the installer to either our scene context or our project context over here in the resources folder. I will add it to the scene context. So where it says scriptable object installers, I'm just going to hit plus, and we're going to install our test settings installer. Okay, great. So what should happen here now is that this game settings is going to resolve after the settings installer runs. It's going to become a single object, and anywhere where we need to inject this game settings object or any of the interfaces that it implements, currently none, then the game settings should be injected here before the install bindings runs. But we will hit play and see if all that happens. Okay, so I missed one thing here, and that's that we need to specify what instance we're actually binding the class from. If you look through this, you could see I'm binding the class, but I'm not specifying what instance of the class I'm actually binding. So we need to take this object over here and specify that as the instance. And we can do this by adding in between as single and bind interfaces and self2 from we add in from instance, I believe. Okay, so from instance, and then we give it an object, which is the game settings. So let's go ahead and hit play and see if that works with that change made. So we hit play and I don't see any errors. Everything's spawning again. So it looks like our Mono installer is now using the settings pulled out of our Scriptable Object installer. And now what's so great about using a Scriptable Object installer is if we want to create a different, basically list of settings, then we just right click, go over here to create installers, settings installers, and I can call this live settings installer. And then whenever I want to interchange these, I just put whatever settings I want in here, go back to the scene context. So now all we need to do is drag in this live settings installer, replace the test settings installer, and then whatever settings we have in this scriptable object will be used instead of whatever's in our test settings installer. So really cool way of doing settings within Unity. So I've been Chris, thanks for watching. I hope you guys found this tutorial helpful, and I will see you guys in my future Unity content. Hello everybody, Chris here, and in this video I'm going to be showing you guys the basics to setting up unit testing inside of the Unity engine. So in this example we're going to be unit testing this incredibly simple class. So we're just going to be testing this method over here where it multiplies an integer value by 5 if it is positive. If it's less than 0, then it will throw an exception. Bad value, this should probably be something like a number format exception, but you know, whatever. But then otherwise, if the number is 0 or positive, it will return the input value multiplied by 5. So something really simple that we can easily test. So these days for unit testing inside of Unity, they tend to create what are called assembly definition files or .asmdef files. And what those assembly definition files do is organize the different files in your project, usually scripts, and have them compile individually as separate projects. So it's kind of like in Unity where you have like a bunch of different solutions. The assembly definition file allows you to customize what those solutions are, so that if you, let's say, build one of those solutions like the testing solution, then it will only build the scripts and the dependencies that are required to do those tests rather than compiling every single file in your project, which helps if you have a larger project. But the thing is, once you start using them, you kind of need to do it for all the assets in your file. And the reason it's important to know this is that once you start adding unit tests, if you do it at least the out-of-the-box way, it's going to create an assembly definition file for your testing folder. But that requires you to have an assembly definition for all of the scripts that test is going to depend on, so you can actually import and use them. So if we go up to Window here and go down to General and Test Runner, we're going to get this pop-up where we can create an edit mode test assembly folder. There's also play mode for doing scene-based tests when you actually need to load up a scene and test things with that loaded scene. But for just doing unit tests, you would do edit mode tests because you don't want the extra overhead of loading the scene. So here I'm going to hit create edit mode test assembly folder, and we can just leave the name of it defaulting to tests. So if we open up that folder, you'll see now that there's a assembly definition file in here, and this assembly definition file can set other assembly definition files, which this one depends on. So if we want to test a script that we wrote for our Unity game, we'll want that included in this references section here. You can also set which platforms that this should be built for. So if you have, let's say, assembly definition nested in your project for only Android specific scripts, you could check Androids and leave everything else blank so that it will only ever build those if you're trying to build your game for Android, because it's only relevant then. Okay, so now we're going to want a test script. So down here where it says assets tests, I'm going to hit create test script in the current folder. Over here, I guess in the project, it's loading up there. We can just call it unit tests one. I don't know. You can probably think of a better name than that. But that should be located inside of this tests folder. So unless we have another nested assembly definition file somewhere in this folder and nested down in many subdirectories, then everything inside of here is going to be built with the tests assembly file. So now in our assets folder, and generally I would move our game scripts into its own scripts folder, so maybe we should just do that. So I'll create one called scripts here, and I'll put that in here. And because the tests are technically their own scripts, I'll also move the tests folder into scripts/tests. Now we're going to need an assembly definition file to reference this number machine. So I'm going to right click and go to assembly definition file, and I will call this game scripts. So this will include number machine in this assembly definition build, but it will not include unit test 1 because unit test 1 is going to be managed by the tests assembly definition. So basically anything in here gets excluded from the game scripts assembly definition file. So now what we need to do is add game scripts as a dependency for tests. So over here in the inspector, we want to add a assembly definition reference, and that is going to be referencing game scripts. So by doing this, we can use any classes that are included in the game scripts build inside of our unit tests. So that's really important there. Make sure you do that. So now over in the Visual Studio, or whatever your editor is, we can see now that the solution has two projects that have been custom defined by those assembly definition files. We have game scripts and we have tests. So these overwrite the default projects that Unity comes with out of the box. And if we open these up, we can see that the scripts we would expect to show up there are in fact in there. So let's open up unit test 1 here, and now we can start setting some tests. So we're not going to need this because we're not doing any coroutines. And now we can define what our tests are. So if you didn't already know, it uses the NUnit framework. So if you want to create a test, you should give it the test attribute. And inside of NUnit, you can define a method as setup, which means it will be run every time before you run a test. So we could say create a setup game object method here, and then we'll have a variable up here. So this will be the number machine variable, and I will call it machine. You can see that it immediately recognizes the class because the tests project depends on the game scripts project, so it already has the references to that project, which is what we would expect. So now we want to initialize this as a new number machine, and then we can also have a teardown. So the teardown method is going to be destroy game object. You can actually call it whatever you want. It's the attribute that matters, not the name. So machine equals null. Why not? So there'll be a completely new number machine every time we run any of the tests in this project. So let's actually create some tests. The first test will be a negative number returns exception. So to do that, we're basically going to run the method on the machine object, and then we're going to check with an assert that it throws an exception. And I think we can just do it like this. So machine dot multiply by 5, and we see what comes out of that. So this should return an int, and I haven't put an int in, so we can actually declare what that value will be up here. Negative number equals -1. Why not? So let's pass that in, and we will import system so that we know what the exception class is. And let me see here. Okay, we actually need to declare this as a delegate, so we can do that just by adding this in. I think that's all we need, really. So this should throw an exception, and we would expect that because in the validation for this method, if it's less than 0, then it throws an exception of bad value. Okay, so let's write another test. So let's see, test public void unit test. 1 becomes 5. Why not? So for this assertion, we just want to check that the value is going to be equal to 5. So we can do an assert art equal, and we expect, I guess, 5 as an integer, or we could just put 5 there. I think that will work either way. And then we want to check the method. So multiply object by 5, and we're multiplying 1. So this should return successful if it in fact becomes equal to 5. So let's test a really big number now, going to the outer bounds to see if anything weird happens. So unit test, let's say 100,000 becomes 500,000. So 1, 2, 3, 4, 5, 5 zeros. Yep. And we will assert that. Are equal. Okay, so 500,000, 1, 2, 3, 4, 5. And then machine multiply the value, 100,000. So 1, 2, 3, 4, 5 zeros. And that's pretty much it. So we've written 3 unit tests now, and we want to go ahead and test them. Well, all we need to do now is go back over to our game project. And now we can go up to Window General Test Runner. And as long as we're looking at the folder over here, we should see the script show up here, the script for the unit test. And we can see it's nested inside of the tests project, which is part of our basic unit test solution / game. So we come down here and we can see the unit test 1 class, which has 3 tests. We can right click on these and run them individually. Or if we want to run them all at once, we can right click over here on the class name and just hit run. And then we can see that all 3 of these unit tests are in fact working. You can also run every test in your project if you have multiple files by just going up here to the top, hitting run, or you can hit run all up there at the top left. Now let's make one that intentionally fails just to show that these tests are in fact working. So let's see. 1 becomes 7. Okay, so obviously in a method that multiplies by 5, this should not work. So let's check. Are equal 7 machine dot multiply by 5, and we're multiplying the number 1. So we save that. We're gonna wait for it to compile and show up here again. And there it is. So let's just run all the tests one more time. And oh, look at that. Expected 7, but was 5. And what's so great about unit tests is that you can test for a lot of different things without having to run your game. You can automate them with a testing server. And just if you do it manually, it's really, really quick to check for a lot of different things. And if you set up unit tests as you're building your game, and maybe you change a lot of stuff around, you can always come into these tests and make sure that they all still succeed, so that you will know if a change you made later on breaks something that was already working. So that's a really basic introduction to unit testing in Unity. I've been Chris. I hope this tutorial helped you guys out, and I will see you guys in my future Unity content. Hello everybody, Chris here, and in this video I'm going to be showing you how to do play mode tests inside of Unity. So as you can see here, I already have a folder set up called play mode tests. It contains an assembly definition file, or a .asm.def, and that allows everything in this folder and whatever's nested below to be compiled as its own separate project. So everything in here is going to be built under the play mode tests project. And with this assembly definition file, as we talked about in the unit test video, you can add in assembly definition references. So if you need to reference, let's say, all of the scripts of your game, then you can add in a reference to a assembly definition file over here. So you would simply click there and select the one you've set up. So if we take a look at the scripts folder, you can see that one is set up here. You can add one in by doing right-click, create assembly definition. And so this game scripts assembly definition file will allow this mover script and number machine and any other scripts to be built under the game scripts project. Note that if there is a nested assembly definition file, then all those files and tests and play mode tests will be excluded from this game scripts build. So enough about that. If you want to create a folder for doing play mode tests, what you need to do is go up to Window, General, Test Runner, and then there's play mode over here on the left. If you haven't already created a play mode test folder, there'll be a button here to create that folder. So before you actually set up a test script inside of the folder, there's usually a button there to add in a script to the current folder. But another way you can do it is right-clicking, going to Create Testing, and then C# Test Script. So let's take a look at this play mode tests script I've set up for doing play mode tests. Over in the Visual Studio, you can see that based on those 3 assembly definition files, there are 3 projects inside of this solution, and they will all build independently, of course referencing and building the dependencies if you add any end. And at least for out-of-the-box in-unit unit tests inside of Unity, the script doesn't look a lot different between this play mode test and the one we created in the previous video for just doing a simple unit test. But what is going to be different here is that because we are running it in the context of a test scene, we're able to do things like GameObject.instantiate to create new game objects, add components to those game objects, and check variables on those components, like the transform of a game object. So that would be one example of why you would want a play mode test instead of a unit test. So let's go down this script and talk about what it does and how you can add some of your own play mode tests. So inside of the in-unit framework, if you set up a method that has the setup attribute, it will run once before every unit test or Unity test in this case. So what this setup is doing is it's creating the game object we want to test, and it's adding a mover component to it with all of the defaults. The mover script over here is really simple. It requires that there's a Rigidbody 2D attached to the game object. And basically, as long as the script is running, it's going to move the position of the game object using the Rigidbody 2D.movePosition method in a certain direction multiplied by a certain speed, and of course it factors in the time.deltaTime, which is the time that has elapsed since the last game frame. You can see over here at the top, you can obviously set the speed or the direction to be whatever you want. And what we're testing for in this script, the unit test script, is 2 things. One, we want to make sure that the mover comes with the Rigidbody 2D by default. So you can see in the setup that it adds component mover, but it doesn't make any reference to the Rigidbody 2D. But over here in the mover script, we can see I have the attribute set, require component type of Rigidbody 2D. So we want to make sure that that is properly being added automatically. So if it's found on the game object using getComponent Rigidbody 2D, then assert not null should return that it is in fact not null, and the test will pass. And then down here we have another test, which is mover object will move after the game starts. So it checks what the position is at the start of the scene. It waits 0.1 seconds, and then we get the position that it's currently at again, and we make sure that those 2 positions are not equal. If they're equal to each other, then that would imply that the object did not move, which would mean the test failed. But if they are at different positions, they assert dot are not equal, then that would imply that the object moved, not necessarily through the mover script, but at least in one way or another. And we don't really have to worry about other possibilities here, because this is all being set up with the context of this setup method up here. It's a test screen, there's nothing else on it, and it's an empty game object that only has the mover component and the Rigidbody 2D attached to it. So we can be pretty sure that this method, if it does move, it's because of the mover script. So without having the play mode testing, what we would normally have to do is actually load up our screen in order to test an object. So here I have one of those game objects that does have the mover script attached here. And the normal way of just loading up your screen and testing would be like this. We hit play and we see if it moves or not, right? So let's do that, and we can see, hey, it's moving to the right, exactly like what you would expect. But if we have these play mode tests set up, then we can have it automatically load up a test scene. And if we go to the test runner, we'll be able to run these tests in the context of that empty test scene using only the setup that we have from the setup method. And you can also see tear down at the end. This will destroy the game object that was created in setup every time one of these scripts runs, basically guaranteeing that it is a new object on every single test, and not the same one. And honestly, this probably isn't actually necessary, but it's not a bad thing to have in there just in case. So over here in the test runner, if we want to test both of these things without really having to think about it, we can just kind of go up here and tell the basic unit test to run all of the play mode tests. So if you run it up here, you run it up here, it would apply to all of the play mode tests that you've created, even if you have multiple scripts that do separate things. And we can see in here that both of these tests passed. If we run it one more time, you can see that it also loads quite quickly because it's just a basic test scene with nothing else really in there. And we get both tests to pass. So just to show that it is in fact working, I will make this test fail intentionally. So are not equal position to position. This is set once. So this test should definitely fail, and we can hit run all to have that run again as soon as it compiles there. So we'll run this, and that test will definitely fail because we're checking the wrong variable. But you can see, was not expecting them to be equal, but they were in fact equal. So that's all for the basics of how you set up play mode tests inside of Unity. If you want to take things a step further, there's a library called Zenject for dependency injection inside of Unity. And the Zenject dependency injection library works really, really good with these tests, whether you're doing unit tests, integration tests, scene tests, or whatever. But hopefully this has helped you guys to understand how to create those play mode tests inside of Unity. I've been Chris, thanks for watching, and I'll see you guys in my future Unity content. Hello everybody, Chris here, and in this video I want to show you guys how you can do a simple unit test inside of Unity utilizing the Zenject dependency injection library. Since it's a little bit different when you use Zenject to do unit tests, but it will allow you to do things like use custom installers in your unit tests so that you can bind whatever interfaces you want to whatever concrete classes you want for testing purposes. So in order to create our testing folder, we want to go up to Window and then General Test Runner, just like with any Unity engine unit test. And because we're doing unit tests, we're going to be wanting a edit mode test assembly folder because we're not launching any scenes for it. So I'm going to create that there, and we can call the folder unit tests. So what this is going to do is inside of this folder, it's going to create an assembly definition file. So what this assembly definition file does is basically sets a breakoff point where everything in this folder and beneath it will be treated as a separate project inside of our entire solution for the game project. Which basically means that if we save something in here, it's going to build only the scripts for the unit tests assembly definition file and any of its dependencies, which would be over here in references in the top right hand corner. But since our unit tests are going to have their own assembly definition file, we're going to need to reference another assembly definition file that contains all of the code we actually want to test. So in the assets folder for this project, I'm going to create a new assembly definition file by right-clicking, going to create assembly definition, and we could call this tutorial scripts, I guess. Probably could think of a better name. And this would pull in our plugins and our scripts. With one exception, which is that Zenject has its own assembly definition file. So if we want to reference Zenject with this assembly definition file, which we do because it depends on Zenject, then we're going to need to add that in as a reference too. So the idea is you can have different assembly definition files which determine different segments of your total project where you want them to build independently of each other. It's supposed to save time in bigger projects when you don't want to recompile every single script, but just a handful of scripts. But because of that, we need the different files to reference each other. So in the unit tests assembly definition file, we're going to need to add in two references. One is to the Zenject test framework here. And then the other is going to be for the tutorial scripts, where all of our classes for the game are being built and compiled. So by doing this, we should be able to reference our scripts and also reference everything Zenject related. inside of our unit tests that are in this folder. So I'm going to go ahead and create that, and now we can create our unit test. So I'm going to right click here, go to create Zenject. You'll notice there's 3 different types of tests listed here: unit tests when you want to test individual components, integration tests when you want to test how components work together if you have a bunch that need to do that, and then scene tests are where you actually load up a scene and test stuff like game object physics or whatever. So unit tests. So for this video we're doing a unit test, so I'm going to create that and I'm going to call this greeting unit test. That's the only script I've really written for this test project, so I guess it's a fitting name. And now we can go ahead and open this up in Visual Studio to edit and then run our test. So inside of the test, you'll notice that it extends from Zenject unit test fixture. This is required so that we can do all the Zenject things like setting bindings. So I'm going to declare a setup method here, standard to the in-unit framework. And I guess I'll just call this bind interfaces, whatever makes sense to you. And inside of this, we will run the installers before every single test. So the installers we're going to want to run are basically going to be whatever I've written before. So let's see here. We have a settings installer and a greeting installer. So the greeting installer, as you can see here, injects game settings, and that game settings should be installed from a settings installer. So we would need one instance of a setting installer and then one instance of the greeting installer. We're free to swap out components if we wish. For instance, we could use a totally different installer to bind the interfaces, and then we bind that in the actual unit test. Now, if we take a look at the greeting installer, you'll also see it's a mono installer. A mono installer attaches to a game object. We're not using game objects right now. So if we wanted to use this installer, what we would actually need to do is extend from a installer, not a mono installer, and then the mono installer would install that base installer. So what that could look like is something like this. So let's see, public class base installer, and I'm just doing this to demonstrate. I believe it's like that, and then your install bindings method goes in there, and when you do install bindings here, you would do base installer dot install into the container. So and container is capitalized because it's a property. So the idea here is basically that you run an installer inside of the context of the mono installer. So installers can install other installers. But if you want an installer to run inside of a unit test, it should extend from installer. And the generic type parameter should be the name of this class over here. So that would be how you could make that work. But what I'll do here is I'll undo all of that. And then we'll actually make this test installer. We'll just make that an installer directly. So installer of test installer. And that basically does the same thing as up here, but I will add in the game settings requirement as well. So the idea of the injection up here is that when we bind a game settings, it'll be used to resolve this factory inside of the test installer. And we can use this test installer inside of the unit test. So now in order to install that installer inside of the greeting unit test, we're going to need to do test installer dot install container. And it looks like we're getting a assembly not referenced issue here. I think we can get around that by going to the assembly definition file, and then if we reference Zenject here and hit apply at the bottom, let's see if that fixes it. So that at least resolved that issue. And now that we have the test installer.install, we should have game settings install first. So what we're going to need for the game settings installer is, because this is a scriptable object installer commonly used for settings, we're going to need to pull in the exact instance of the scriptable object or the asset file from a location on our project. So how this might look is something a bit like this, where we have the settings installer and we install the exact instance from a resource. And that resource is going to be from a path, usually inside of our resources directory, and it's going to install to the container of this unit test. So now all we need is a path. So private string test settings path. And how can we get that path? Well, if we go to our project, we can see in the resources. We can see in the resources folder that we have two copies of the asset. We have the live settings installer and we also have the test settings installer. So you can have individual test settings for every unit test you create, and then you just bind the right one you want, and you can store all of your game settings inside of here, is generally the idea. So if I right click this and do copy path, we can get the path to this inside of the resources folder. So if we paste that in here, we'll get this. Because it is already using install from resource, we get rid of this part because it's already looking in the resources folder. And I believe we don't need the .asset either. So it'll look just like that for right now, since this file is in the root of our resources folder. So now the settings installer is going to bind this test settings installer as the settings installer. And the test installer is going to install as well on this container. And once that's done, we're able to run all of our unit tests with whatever bindings happen to exist inside of those installers. Okay, I mean, that was a bit of setup, but it allows us to be quite flexible now, because now we can do things like test if iGreeting will resolve inside of our unit test. So let's do one really quick to check that. Will iGreeting resolve using the settings up here? So let's check that. Container.resolve iGreeting, and then we'll set that to an iGreeting object. So object, and then we can assert that not null object. Great. Let's do another test. Test public void iGreeting resolves as greeting object. So checking that the binding is the right binding you want, I suppose, is not a bad thing. So greeting object container.resolve iGreeting. So now we're checking if the iGreeting does resolve as a iGreeting object, and I guess we need to convert that. So that will come out as a greeting object, and now we can assert that that is not null. So obviously, if this iGreeting object, which is a single object, if we take a look over here, it's a single object, there's only one greeting object inside of our test. If that object resolves and it's not a greeting object, then it's not going to store properly here because it couldn't cast over to a greeting object. So this should only work if iGreeting is in fact a greeting object. And you can go so on and so forth. So another example might be, I don't know, iGreeting message resolves as hello world. So we'll do container.resolve iGreeting object. And then with that object, we'll check what the message is. So string message equals this. And then assert, let me see here, for checking the message. I guess we could use art equal. So message is equal to hello world. Now this is going to resolve false. I know that because over in this greeting class, the concrete implementation of iGreeting, we can see that the message is set to hello world with an exclamation mark. So that's intentional, just to show you guys. Of course, if you want to, you can also set up a teardown method, which will run at the end of every single unit test. So I'll just generically call this teardown. And we could say something like container dot, there's something in here for like clearing everything. Unbind all, yeah, okay, why not? So we're sure that the container unbinds everything at the end of every single unit test. Okay, so let's go check out our project in the Unity side of things. So let's see, scripts, unit tests, and now we're going to want to open up the test runner. So window, general, test runner, and we can see our tests here. We can right click on them to run one at a time, or we can just hit run all and do everything at once. And so if you don't already know about the magic of unit testing and all of that, obviously it's a lot quicker to do some of these automated tests just by hitting run all than it would be to start your game and manually check for every little detail. Also, these tests once written, you can always rerun them again with a couple of seconds. So it'll help you to know if anything broke horribly when you make major changes to your game. So, as I would have expected, iGreeting resolves as a greeting object. We know that. Okay, iGreeting does resolve. Really, this is like the requirement for that to succeed anyway. But iGreeting message resolves as hello world. We can see that it expected hello world with an exclamation mark, but was hello world. So this might mean that, oh, well, it wasn't the right message we set in the greeting class, so we want to go back to the greeting class and make the changes in order to make this test work. So we could say, go over here to greeting. I think that also needs to be capital. Yeah, because this is a capital W as well. Maybe we want that lowercase and this to be lowercase as well. So we've made our changes, fixed our code in the most basic way possible. And now we can go back to our unit tests. We'll get that little circle showing that everything compiles. Or maybe it already ran. And now we can hit run all again to see if our tests work. So congratulations, our game has passed all of the tests and is now ready to ship. Not really, but this is a good start. So hopefully this has helped you guys to understand how to do some basic unit testing inside of Zenject. I would recommend you look through the documentation if you have any more questions, but for this video, I've been Chris, and I will see you guys in my future Unity content.